After my boss, my father, he ended up medically ill already, got his stroke and everything. So
Oh, you have to take care of everything.
I had to give him my room. My room is bigger than so they can buy the hospital bed and everything.
Ah, that's
Yeah,
a
because
good.
he's completely bedridden already now. He's completely bedridden already, so yeah, I have to get him the hospital bed and everything. And because of that, in return, I got chased out from the house. So yeah, I'm currently trying to get a property just near to my parents' house. So once I got the key ready, then I will move out and I will turn that room into another classroom also lah.
Oh,
Mm.
really doing the best you can. Huh?
Yeah, have to lah. Because running business, sometimes people say, oh, you're running business, you're doing good. Nah.
Doing business running good, but a lot of burden also.
Yeah, correct. Because for people like me, we have no timing over here. There's no 9 to 5, no such thing as 9 to 5. It's 24/7.
Every day running.
Yeah.
Oh, that's true. So you also handle the sales, is it?
Yeah, I handle the
Very
sales
fast.
and the management, like sales, training and management.
And the management.
For now we only focus on the PLC HMI SCADA training only.
Right.
And Mr. Deegan, he conducts the training. Probably I will expand for Excel training as well.
Excel.
Excel training.
Well, you got the trainer to teach Excel, or you yourself teaching Excel.
I can teach also, but I have to focus on the management and marketing, so I don't think I'll have the time to do the training. So I used to hire external trainer.
Got it. Excel, indeed a lot of things to teach, but
Yeah.
but the thing is, I feel that nowadays Excel is getting go to obsolete already. Not like now it's obsolete but there is a trend. Slowly, people is not using Excel anymore.
Not using Excel anymore.
Yeah.
Everything is now web based.
Exactly. AI, all these
Who uses Excel mostly? HR.
HR, I don't
HR
know.
managers, they the one who mostly use the payroll managers, they the one who mostly use Excel. So to do the calculation and stuff. But nowadays there are some platform in the website is more AI generated and more user friendly. AI is trying to take over everything already, so less human work over there.
I agree. I also a heavy Excel user. But slowly I see nowadays more and more apps or whatever.
And if it's still agreeable with according to their budget, they will just go for the web-based one, which is normally used to be the monthly
more
basis.
functionality, like collaboration, everything you can do online. Yeah.
And they can get customer support also. Excel, yeah, you have to do everything by yourself, obviously.
yeah. It's very powerful, but it's an old school type of working.
Yeah.
But anyway, I still see people offering training for Excel anyway.
Because mostly in small companies who can't able to tend to that budget, they will just go manual mode. They just use Excel.
You need to teach. I mean, of course, it depends on how advanced they want to use the function.
Yeah. Mostly, I will focus on advanced training.
Advanced training, doing all this.
We focus market on advanced training.
Yeah.
Morning.
Hey, morning. So this is, I use this laptop.
Yes.
Okay. The software can install, no problem, can use.
No problem.
Thank you.
Yeah.
Yeah, all is good.
Mr. Chan Chun Kai, right?
Yeah, right. Thank you. Okay, thanks.
Yeah.
Okay, you can sit here.
Oh, okay. Sure. You connect or off? You already connected?
Yeah.
I'm going to make coffee.
Yeah, sure.
power. This is
Ah,
power.
yes.
Okay.
This one from the power supply. So the cable is short, so I just use this to jump here.
Oh, normally not supposed to connect this way lah. Normally, how is normally the power, the wiring diagram supposed to power out? Also like jump like this, jump.
No, it jump also can. But normally what happen, because this is a PLC, this is HMI, right?
Oh, this
So
is
they
far
will-
away.
So this one will have a different,
Right.
not different power supply. Can use the same power supply from the different terminal. Like this, right? It's a loop, correct or not? So maybe this first go to the one. This one second go to here.
Or will follow all the way from
Yes.
from the panel.
Yeah, from the panel.
Or because they must use a 24 VDC also.
Okay, not necessary.
Not necessary.
Not necessary. Because just to power up that line.
Right.
Let's say for example, this is in your main control panel.
Right.
Okay, that is in the remote I/O.
Yeah, in the remote.
Then in the remote I/O you have a power supply. You can use that power supply also.
So normally, question is this. Normally, this one included in the wiring diagram. The HMI.
Yeah. Okay. Yes.
Oh, because I don't know. I just thinking, like instrumentation normally they have all these details.
Yeah.
But
But normally this one will be
this one,
in the power, where in the wiring diagram where they connect the power cables.
Okay.
24 volt.
It will show the power supply go all the way to the field for this one.
Yes.
Okay, got it. Yeah.
Or it's depend because let's say it's in the same panel like this for example. Inside here we got
Easy lah,
the
this
same
one.
panel. Okay, you can use the same power supply.
Yeah.
Let's say that is a different panel. Then maybe you can use a different power supply.
But to be honest the most convenient most of the people do is on the same panel lah.
Yeah, of course.
PLC cabinet and then HMI outside.
Yes, HMI outside.
Okay. So
Or because sometimes what happen, the PLC will be in your control room.
I was thinking possible or not. Like
Yeah,
one
of
is
course,
very
of course.
remote, very far away.
Yeah. Sometimes the PLC will be in the control room, the main PLC. So means like the 1500 is the main in the control room. So this one will control your remote I/O, your interface modules.
I remember I've seen some of kind of HMI, but I think it's not Siemens.
Okay.
It's the one with the arms. Yeah.
Okay, the robotic arm.
It's not like exactly a robotic arm. It's
Okay.
like it's kind of quite a big HMI lah.
Okay.
But I don't see the PLCs around it. So
Okay.
it's just next to the machine or something. So people will pull it up and do
Oh,
control.
okay.
Yeah. So that one I think that kind is quite remote lah. I don't know where the controller is or where the PLC is.
Yeah, the controller is a different place.
Yeah, and then at the field and the workflow, then the operator uses the
Yes.
control.
Then in that case, they will use a separate power supply.
Yeah. Also, okay. Got it. So this is the power supply point actually.
Yes.
Okay. Yeah.
So this one I will set up ready for you. So later we do some wiring.
Okay.
We can connect this temperature sensor to this PLC or this PLC also can.
Okay. This is
The temperature probe.
this is you say it's RTD, is it?
Thermocouple.
Thermocouple. Oh, this is thermocouple.
Thermocouple is 2 wire. RTD will have 3 wire.
Okay. Okay.
Last
Got it.
time I was modified this.
Thermocouple is cheaper than RTD.
Yes. Thermocouple cheaper. And the measurement rate also, thermocouple is
Lower.
Measurement.
You mean the resolution is
Yes.
lower, right?
The range yeah.
Okay.
Now I just want to make sure we already cover all these set reset already cover. Counter we already cover, right?
Haven't yet.
Counter haven't yet, okay.
Yeah.
Comparison.
We did cover. Comparison is the triggering the alarm, right?
Yes, triggering alarm.
Yes,
Later
we
will
covered.
do
We covered. Yeah.
The match, okay, we done match function block FC we done. Okay, HMI we do a simple one lah. Okay.
Okay. stuff?
Just check.
Okay. This laptop is opening up.
Yeah. I didn't touch this laptop. I was using this one. So I set up this.
That one is even
Omron,
older.
so I'm using Omron.
Oh, okay.
So I use this place. So what I just set up that place.
Okay.
Okay, so the first thing what we want to do, we see how to do the interface module
Okay.
using this 1500.
Okay.
Yeah. Then you can get idea what the main panel, the remote panels, all that.
Okay.
Day for remote IO. project view. Okay, add new device. Yeah. Okay, SIMATIC, yeah. CPU.
What 1511C.
No, we are not using that one.
Not using this one.
This one just want to do the configuration. So we can choose any. I want to just use the CPU model. Which one? 151.
1513.
Yes. Okay. I think we click here. Yeah, display work memory. Okay, click this. This one work memory. Action. Okay, we choose this one. So this one, check.
Okay.
Become white. Understand. Then you add a power supply. Yep. Yes.
Okay. Oh, before we never had power supply. Okay. This one.
Yeah. No, that day we had what power supply.
Really? Okay, okay, okay. It's go to the left side.
Left side also can, right side also can. This one. For 1500 model, left side also can, right side also can.
Question.
Yes.
Any difference to get a power supply? I mean, like,
No difference.
No difference.
No difference. Because why? The PLC, because whenever we add hardware, right? Okay, what the PLC do? PLC will scan those hardwares. So if one of the hardware missing, then it will show error, right?
and it will stop the PLC
It will
running.
stop the PLC. Okay,
Oh,
but if
okay.
you do a correct program, it won't stop PLC. You know the special OBs. So if you use the special OBs, it won't stop the PLC.
Okay.
PLC will be run mode, but the error will be there.
Okay.
Okay, but the power supply, PLC won't scan the power supply.
Okay. It won't scan the power supply.
Yes. So if let's say if you're using Siemens power supply, then you can add. If you're not using Siemens power supply, you are using some external power supply, you don't need to add also.
But this one has, has nothing, right? It has no communication. It's just a 24 VDC code.
Yes.
Nothing else.
Nothing else.
So
Because why I will say nothing else, because you see, whenever I add some modules, right, how this card will communicate to that module using this connector.
okay.
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 But when we connect a power supply here, there won't be a connector like this.
Okay.
So
Got it.
that's how
It is
we-
really physically attached to it only.
Yes.
Okay.
Okay. So, but if you add on the right hand side, then you must add the connector.
Okay.
Because then only because CPU need to send the signal to the
One by
the
one.
I
and
cards.
then one.
So need to send the signals.
So, or if it's somehow slot between, you have
Yes.
to do
You
a
have to
connector
use
for it.
Yes.
Okay, got it.
Okay. Then you add some maybe one DI, DO. Maybe you can use the combination DI DO. Click here. Yes. DI DO.
Oh, DIDO. Okay.
DO, yes. Okay, this one. Yes. Okay. Then you add one AIO. Okay.
Okay.
So the addressing you know, right? How to see the addressing, yeah? Click here. Do you remember? The addressing.
Yeah, this one.
Alright. Okay.
Understand.
Okay.
Yeah.
So digital is just 0.0, 0.0. Okay. If analog will be IW, QW.
Okay.
Okay. Now close this. Okay. Now what we do? We go back to here. Now I will add this PLC. Yeah. Okay. Now I want to add some remote I/O. Remote I/O means like this. Like this one.
Yeah, the ET.
Yes, the ET one.
So we can mix it with low model.
Actually, yeah. Actually, we can do the remote I/O here itself. We can use this PLC.
Okay.
Here we can use this PLC. Okay, never mind. We try that one. Then physically we try this.
Okay.
300 can support PI400.
Oh, okay.
So we use
Can try.
can try also.
Okay.
Then we can try the if suddenly come out the errors everything.
Okay.
Okay. First we do this. We get the idea first how the remote I/O works. Then we can try with that.
Okay.
Okay, for this model okay. Now you click the distributed I/O system. Okay. So I can use the ET200 but ET200 you click the M interface module Profinet, yes. Okay. ET200 M means is that one.
Okay.
It's something similar to this. Okay. So you need to use the 300 IO, S7-1200 IO. Then you cut this card, right? Is the one is for this IO card is for the 300 model.
Okay.
Because
S300.
yes, this is the ED200M. Okay. Then they have so many the SP, ED200 Pro, all that. Okay.
So the new generation come together with this is called what? Let's say
It's a SP.
SP.
Yes.
Or the new one called SP.
Yes.
The last generation called M.
Yes, can also. You can mix also, no problem.
Or can mix also.
Yes.
Okay.
Okay, you just click here. Just click on here. I want to see the distribution. Go down. Wait, you have to wait. Okay, Profinet, module, okay, just add here. Just drag it. Okay. Now you double click this. So this one have the interface module left, right? Okay. Now I add some DIDO. Same thing. DIDO.
Okay.
LED also can, no problem. Okay, wait Can you see this 323, right? This one is that input cards.
Okay.
That type of input cards, IO cards.
Okay.
That IO cards, these IO cards is meant for this 300 model.
Okay.
So because ET200 is this big. ET200, what is one? ET200M, right?
Right.
Is this big. ET200S is like this.
S is the big one.
The small one.
The small one.
This ET200S. This one is ET200M. So ET200M is using the 300 IO. ET200S is like this. So this one is still this generation. The new generation
This is still this generation.
the new generation called ET200 SP.
SP.
It's similar like this. Only the color is like that.
Oh.
The color, the green color.
Can they mix and match? Let's say the S and SP. The card can.
No, of course cannot. Oh, the SL cannot.
Cannot. If you use SP, all your card must be.
Or SP. Or
Must
SP.
SP.
Yes.
Okay, got it. Yeah.
I will share one incident yesterday. 2 days back, I had one. My old participant, he messaged me. He got some error suddenly. 9 o'clock.
Oh.
I was listening. Before that, suddenly messaged me. Then I was to reply. Because he's here. So I replied him. So what happened is, same ET200 SP, the IO card, okay, suddenly got error. Okay, it's an analog card. Okay, then it's called HART communication.
Hard
Communication, you know, right? Okay.
Yeah.
So what happened is that card, that particular module, will have a LED for analog and fault. For fault, F. So for one analog, they will have 2 LED. One is the analog, one is the fault.
Okay.
If it is good, the LED for analog will be green. If
Okay.
it is fault, then the LED for analog will be for the fault LED lah, the red color. Okay. Suddenly he messaged me. Then I also never used the module before. So what I do, I ask him to send a picture of the module. Okay. Then I go to the part number. I download the manual. In the manual, I go to the fault codes area. Okay. So there it shows the fault can be many fault like a wire break, short circuit. Okay, because they have 16 analog for that particular one module. They have 16 analog. Okay. I think 5 or 6 analog is red color.
Okay.
The others all green color.
Okay.
So it means the card is not spoiled.
Okay.
The card still can work.
Oh, you mean if it's spoiled then all red?
All red color.
Okay.
Okay. Then I go to the manual. Then I check what is the meaning of the F LED is blinking. So they show up. Okay, F LED blinking means it's in diagnose mode. Okay. Then I go to the error code. Okay. So it shows that what you need to do is okay. Maybe we can later I add here when we had the HRD, because when you do the HRD, that's still in my mind. So I just want to share with you. So there's one setting. In the setting, they can give you your one address. Okay, you know how analog works. IW, right? IW 60, for example, you will get the 27,000. Remember the 27648.
Oh, the number. Yes, the integer inside the
Integer
program. Yes.
inside the bit, yes, okay. So normally with analog card will have one address. So but this card, the HRD card will have of course normally will have one for analog. And later on you can add some additional address to read the error code.
So it has still a 27,000.
No, it's not 27,000. It still has a 27,000. That is the analog. Let's say IW10 for example. For that card, you can add additional what information you want to take from the card.
Different address.
Different address.
Oh, that's how the HRD works.
Yes. So different address. In the different address, you can choose what you want to, because there's a lot. So later we'll do one.
Yeah, very
Second,
interested
first time
in
I
this half communication because time to time I've seen this half
Yes,
communication.
yes. So later on when you have this issue, you can know where to find the
Right.
Then I send him, because in the YouTube I see one video. Then I send him the video, then I send him the PDF, what page. Then I ask him to go to the video and check what is the address.
And the hub is not only input only, you can also demonstrate out also.
Yes.
So it's I don't know lah. So then I'm very curious. So how you going to do with the PLC?
Yeah. Later we
Okay.
can add the module.
Okay.
Then one AI AO. Just add one AI AO. So this is one remote in IOR. You click here, go back to the network view. So you just connect from here to here. The internet, right?
Yes.
Yes. Add connection number. Just
Oh,
drag
just-
and yes,
Drag and drop.
drag and connect it.
Okay.
Okay. So this PLC you have some IO, right?
Yeah.
This address and this address are not same one. We'll have a different address.
Okay, two different IP address.
Not only the IP address, the IO address also.
IP address.
Yeah, because the CPU is one CPU only.
Oh.
This is like the expansion.
I get your point. Okay, understand.
Okay.
So this is you mean that this let's say this is we have a I0.0.
Yes.
This one also can have I0.0.
Cannot.
Cannot.
Cannot have.
Cannot have. Okay.
Because who controlling these two IO?
Oh.
One CPU only. So that might be tried.
Okay. So it cannot conflict. Okay.
You go here. We see what is the address we have. You open
This
the
one.
yeah.
Okay.
Open the PLC. You open here. What address? Okay. Until 9, the encoder. Okay. You go back to the remote IO.
Okay.
You double click here. Okay, go to this. Can you see start with 10? You try to put 2. You key in here. You try to change to 2. Yeah. Okay.
Oh, you automatic.
You see next one is the 10. Okay, right.
Okay.
Now, go here. Then the IP address. Click here. Yes. The show address here. Then you just can change the IP address and all the IP address.
Okay.
Okay? Now what we do, we had the ET200 SP. Go up. It's a newer model. No, not this one. ISP. Go up. SP here. Yes. Interface module, profile. Because the SP only have profile only.
Okay.
No profile because it's a new model, right? It's a no profile.
So profit bus is really officially obsoleted lah. Nobody use.
Yeah, it's a new models lah, right?
Siemens don't use lah.
Yes.
Also okay.
So wait, interface module for SP, the profile map, okay, 56 I/O modules. Can support up to 56 I/O modules. Means can support up to 56 module I/O.
Oh, okay.
The module like that.
If you want this 1005, go to ET and you can have 56
Yes.
card.
Yes, correct.
Wow.
You go there.
A small question.
Yes.
Just curious. For instance, let's say I really go to RIO, I'm really install 56 card. I don't know how big is 56 card. Probably one row cannot finish one. They really have to have 2-3 row probably.
Yeah, of course.
Then you only need one IM. But like you go to the end, then you because I don't know because you use this bracket and back to connect, right?
No. From here, okay, this one, let's say I have
I mean, let's say this is an ET lah. This is
oh,
an
ET, okay.
Yeah, then I mean, let's say this first rack is 1 to 15 already.
Okay.
And then your 16 to 30,
Ah.
you cannot fit into the same
Yeah, same one.
So you can have a, how do you going to connect? Of course, I don't think it's going to happen
Yeah,
in real life,
but,
I'm just curious.
but you must use another ET.
Must use another DT.
Yes.
You cannot like have a connector or something
No.
go to the next one.
No.
Okay.
I don't think so. Siemens have that. Other
smart.
models I know because they have this like ribbon cables for extension. But for ET200, I don't think so. They have.
But for sure, you go add a LIM, for sure it will work.
Yes.
Okay.
This one is connected using this. This connection. WinCC cards.
Just sort of
Just sort of. So this one, I put the M cap here. I put the M cap here. This one got the technique to take out. Yes. So if you want to remove these, you need to remove this. Then you can take it out. Let's say I want to remove this module. Okay, so I need to remove this from this first. Okay, then I want to remove this module means I need to press this and remove this. Then again.
Seems to be, how do you say? This stuff is better than that stuff, right?
Yeah,
Because
It's cheaper.
Cheaper.
cheaper because you know why? This one spoil because sometimes the terminal won't be spoiled, right?
Yeah,
This one
it's,
spoil.
your card spoil, you can only easily change the card like this.
Yes.
And that one is like, looks quite,
Expensive.
yeah, the terminal is at the top,
Yeah.
and the card is at the
Yes,
back.
yes, have different terminals, right?
Yeah.
So the card is here, so just remove the card. So what if the IO cards, right? Okay, let's say when you have so much, because I've done wiring diagram for this one. So what if this is the interface module,
Okay.
okay? Then this is the power module, you see?
Even interface module needs a power module.
So this is not power supply. This is the power module for these cards.
Must have a.
Yes.
Oh,
Then
yeah.
only these cards will have the power.
So always when you use
Yes.
RIO, you need two modules, one
Yes.
interface, one power.
Yes, one power for the ET200 S line, S and SP type. Because why? The IO card won't get straight power from the PLC. So must have a power module. Okay? This power module DC24. Okay.
Oh, you mean each of it doesn't have a 24 VDC go in? They
Mm.
actually come from the power module here straight away. I mean from the connection.
Yeah, to power up the modules. But still you need, like example, 2AI card. Of course, just plus minus, of course you have, but need to power up the module. This module. So like these modules okay, this guy will have their, so need to power up manually.
Yeah, that one need to power up. It has a wire to go in.
Yes, yes.
This one or the new SP
Then this,
module.
this also say, this one you see, the IO card don't need power.
No need to power.
Don't need to power. Just
Why that one is because that is not because that is not considered 1005 like card.
you take that module, then I will use
This one.
Yeah, yeah. Then you use this one. At the bottom you need to. Yeah. Okay. Yeah, let me check. I think this then is setting card. This one don't need power. Because why that one need power 24 volt? Because it's an analog card. Analog card normally will have a power supply for the card.
Oh.
Not to power up the module. The power supply is for your IO cards. Your input outputs.
Okay.
The module still use the PLC power to
You
on.
mean the analog is when you're using a 3 wire or 4 wire
Yeah,
kind of a
305,
power
yes,
supply.
yes.
It needs an additional power supply
Yes.
to give a 3-4 wire.
Yes. But this one also, can you see there's an M? The common is there.
Mm.
Ah.
Okay. So let's say there are 3-4 wire whatever. As long as it's an external card,
Yeah.
even if attached to the IM already have a 24 VDC,
Yes.
you still need a power supply.
Power supply card. And if it is more, when it is go more, let's say you have this, then you have DI card. So need to know lah this power, this one how many amps. I think not written there. To check the manual lah how many amps this one. Okay.
So let's say from the control panel, you go to one seat-top, right?
Mm.
And then the seat-top distribute the power.
Yes.
You go to the main control panel, it give all the power,
Yes.
and then they have to run the 24 VDC and COM plus minus all the way to the RI or
Not necessary.
not necessary.
Not necessary.
Oh, another seat-top here.
Yes, can also.
Okay.
Another power supply to power up this module because this is just to power up the module only.
Okay.
In case like at DI, we go to DI. Okay. You see the DI. For the DI is how many? 4 DI, right? Okay. So we have a L plus from here means you okay, is an input, correct? Input is number 1526 is the input.
Okay.
At number 3748 we have a, can you see? L plus.
Okay, this is a
Positive.
DI.
It's a DI. So where you get the 24 volt actually from here. Okay. So this one you will take out, go to the switch, from the switch and then come back to number 1.
Okay.
Okay. So I don't need additional power supply for this, for my instrument. So like this 2 AI. Okay. So number 1.
So you mean if I'm using only this one, I do not need a power supply.
Still need power supply.
I still need also.
To power up the particular module.
Okay. No
that's
matter
right.
it's a D or DIO.
Yeah, DIO. And if it is more, what happens sometimes? If it's more, so with this power supply, what happens, they will do like, okay, 1, 2, 3, 4, 5, 6, 7, 8. For example, after 8, they will add another power module.
So this is you have to do some calculation. This
Yes.
can support how many
Yes.
module.
Yes.
Okay, so
Because I've done that wirings, that's why I remember.
I know this is the old type. The new type
6.
because the communication bracket is at the back, right? What do you call the communication bracket?
Okay. Like this, the connector.
The connector is at the back, right? But the connector is only in charge for the
Okay.
signal only.
Okay, you need to know the difference between this CPU and this one.
Okay.
This one is an ED200.
Okay.
So latest ED200 SP also same thing like this.
Same
Same
design.
Yes, same design.
or same design like this
Yes,
one.
yes.
Not the big.
No.
Okay. So
Same design.
okay. So this is exactly the SP is exactly the same
Yes,
as this.
yes.
And there is no connector at the back.
No connector. It's just using these connections. You take the pause. No, that's me.
Oh, okay.
Use this one, these connections.
The next one.
This one. Because I want to remove this one, right?
Oh.
No. Okay. So, we use this one to communicate. These pins.
Okay.
Ah,
But this is only for signal communication.
signal and power supply.
Power supply also.
Yes, to power up the module.
Oh. Anyhow, this card can be stored in anywhere. It can be 1, 2, 3, 4 also can, and then all the card at the back.
No.
No,
Cannot.
You cannot do this.
Cannot do that.
Okay, you must have power supply, supply module. Power supply, supply module.
Yes. That's how it works.
That's how it works.
I think the positive negative is here.
The power.
I think so. Cable. I think this is the ground.
Oh.
Not sure, but I think so.
Okay. All it. And this is the communication.
Yes, this is how they call the bus bar lah.
bus bar. Oh, this is called the bus bar.
Yes. How they communicate, connected like this.
And the card is at the top.
Mm.
Okay, got it.
Okay.
Yeah. Yeah, okay.
Now,
But we don't have to, how you say, include the power supply card.
need to include.
Need to include.
Okay, we do here, but not for this model because this one is this model.
Ah, okay.
Now we want to add this model, that is the SP, right?
Okay.
Okay, you add here, just double click. Okay. Can you see how it looks? Okay, double click. Okay. Then SP.
Okay.
Go to SP. You go to the bus selector. Okay, this one is okay. You click here. You click here. Good.
Oh.
So first connect the connector. Okay, give it a name. Running the connector. Okay. You close. HMI. Okay. So here you have all the DI card. Okay.
Okay.
Okay. Okay, where is the power supply module? You click it. Wait, it's asking me another power supply module. Okay, close. The special. No, can't say power. Okay. Here, the PM. Yes. Click here.
Power module.
Yes.
Okay.
Yes. Can you see power module 0.8 M? Okay. Just add one. So this is the power module. Then I add the IO. Here, under the H area. So just add one DI, DO can. Okay, add. Okay, then AI. You see the HR. Yes, this is the one that they got problem for him. Yeah, just add later, try to see how it goes.
Okay.
Okay, then enough.
Okay.
For example, okay. So this analog also will, this digital also will have a different address. You open here. Okay, start with what number? 19 and 24. The DI card. So just now is what? Until 10, right? 10 and 11 I think, from the other module. So what we are doing here, maybe I can put it,
A quick question.
can you visualize it?
From it's just an open question, right?
Yep.
Maybe everyone do differently. Let's say the automation team they finish the whole program already. They all the actually it's the first thing I want to go back to ask this again.
Yes.
Who is the one deciding what is the IO should be used? Let's say I think last week
Yes, the project team lah. The team must decide what modules they want.
you say the electrical team, right?
No, okay. Of course, electrical team. Okay, okay. Of course, electrical team will design the electrical panels.
Yeah, the E-plan, they do the
E-plan, okay.
They choose the model also.
Okay, because they need to choose in the E-plan, they need to choose the model also.
Oh,
Because then only in the E-plan you can see the model and part number is important in the wiring diagram. Okay.
Yeah.
Okay. Then these guys, the PLC guys, will do the configuration and do the program.
Because I was just curious and thinking, do the electrical guy has so much knowledge, know what to choose, what to do?
No need.
He don't need?
No.
Because he probably doesn't know, oh, what is the difference between this card and this card.
Yes.
Yeah, and then he
Yes.
yeah.
Because let's say whenever you take a project, first you need to decide first what type of hardware you're going to use.
Okay.
So let's say it's a big project.
Mm.
So must have one PLC control panel, some then others all remote I/O.
Mm.
Now, so let's say like this lah, for example. So we use 1500 CPU will be in your control room.
Mm.
Then the other remote I/O will be near to your machine. Okay. Now you decide what type of remote I/O you want to use. Want to use the 8200 SP, the smaller one, or 8200M, the bigger one. Okay. Then you will decide. Okay. Then only you need to give this information to the PLC programmer.
Who? You mean the
Project team lah.
project team?
Yes.
Okay.
Okay. Because later I will go through the flow because you will have the FDS, SDS, HDS. Okay, correct. Okay.
Right.
First you will check the function design. Okay, what are the functions? Correct. Okay. Then you will do the HDS actually, hardware design specification. In the HDS, then only you decide okay what type of hardware, how many I/O you needed, everything you design. Then only the SDS, the software development. Okay. Then only from the software development, this information you need to send to your who designed the wiring diagram. What addresses? I mean not addresses. The part number.
I think I got your point. You say when you say project team, it's a control automation project team lah.
Yeah.
Which is separated from programmer lah in the sense of
Yes, because
their
they
role is different to the programmer lah.
Yes.
Okay, they choose the hardware, they organize the I/O properly, then they pass to you.
Yes.
Okay. Yeah.
So then only after this only, I send this data. What are the configuration? I send this configuration data to the who design the wiring diagram.
You are the one set the address for the
Yes.
for everything.
Yes.
Because probably I imagine because I try to imagine from the very beginning
Yes.
Say a project start new project they start with a design consultant first. The design consultant know nothing about programming at all.
Yes, of course.
And then he only know that I'm going to design, here is a tank, it goes to the pump, and then the pump has a discharge pressure, it has a VFD control or whatever, and then the control philosophy is when the level is low, pump stop,
Yes.
level high, whatever. Okay, he have this already. And from this design, this is a P&ID come out.
Yes.
Okay, P&ID come out. And I have control philosophy also.
Yes.
I have a instrument list also.
Yes.
I have instrument list, I have a PT101, this is a P101 and so on.
Yes.
That's it.
Yes.
You don't have anything further than this already.
Yeah.
Then he passed to the control team.
Mm.
The control contractor.
Yes.
Please do your work here.
Yes.
Fine,
Because you
okay,
already
fine.
have all the instrument list you want to use.
Yeah, I have instrument list, I have an equipment list,
Yes.
I have a control philosophy, I have
Yes.
a P&ID.
Yes.
That's it I have.
Yes.
I don't have any further information.
Yes. Correct.
So from there, this contractor for the automation,
Yes.
what is he going to do? That's the question.
Okay.
So I was just wondering, okay, IO list, is it the IO list is coming out from the contractor? If the IO list is coming out, so he have to include in the IO list, he have to include all this information, every single IO point,
Yes.
from which rack, from which slot, from which address.
Not necessary first.
First is not necessary,
First
but
not
he give to
necessary.
you, right?
Yes, because okay, let's say once you give all the from the designer. Let's say design is one thing. One from the design you have the PNID, the control philosophy, all the data. Then you give to me. Now I pick the instrument list. Now I come up with the IO. How many IO I needed? Okay, because from the control they will tell okay. We use this inverter. Let's say this is the inverter to control the pump. Okay. they say it's not using communication, it's using the analog. Okay, this data I will get from them. Now what I do, I need to go and need to know what type of inverter I'm going to use.
Then you decide on how many I/O is there.
Yes, how
so
many
on.
I/O is there. Then in this inverter, how to control.
So you mean more makes sense is, let's say the programmer more makes sense is programmer in the end based on all the information come out a master list of I/O.
Yes.
More makes sense is control is a programmer come out.
Yeah, of course.
Because automation, yeah, probably there's a lot of way to do.
Because automation is already wide. It's not a programmer yet. Automation, because inside automation engineer, let's say the automation engineer job is what? To design the automation system, and the programmer is one part of the automation.
Right. Yeah, I know. I try to deep dive into it.
Yes,
to
yes,
know
yes.
that who actually come up with all this information, who decide all this information.
Okay, let's say for example, when you give me a project. Okay.
Right.
Okay. So first thing is, I will ask you because I share with you. There's one company in Singapore. They request for this for a panel.
Okay.
They asked me to design a panel, all the I/O, and do some programming.
Okay.
So what is thing I ask is, how many input outputs?
You ask them to give you.
Yes.
Oh, okay.
Yes, because I need to know how many inputs.
Right.
So they tell me, okay, I have push button for start, push button for stop, one selector switch. Then I'm using this VFD, this VFD, this VFD, everything.
Equipment, but they give you
Equipment,
equipment, but they don't know exactly. This BFD actually has how many
Yes,
I/O,
no.
they don't know. Yeah.
Okay, so they give me already. So from there, what I did is, okay, then I expand the I/O, then I check, okay, so okay, they will already give me, this is the analog, okay. So because they will tell you, okay, I'm using a temperature sensor, okay, temperature sensor, temperature transmitter, okay. Then I need to know what type of temperature transmitter you are using, because then only when if I want to design the electrical, then only I know how many terminals I need to give.
Okay.
Okay. So all the list I take up, then I come up with my new list. How many I/O I need to use. From there only I can design what PLC I can use, how many I/O I want to use.
Not even go into the programming part yet.
No.
Only designing.
Yes.
Yeah. All the hardware part.
Yes, hardware part only. So from the I/O list, okay, I come up with all. So I need to calculate how many input, how many output, because I need to give some spare also.
Now I get your point.
Mm.
Now I get your point. And when you're doing the designing of the hardware part,
Yes.
actually more or less you can come up your I/O list. You can come up with the rack, the slot already.
Yeah, of course.
But I don't know, I/O address, all this, you have to decide that point or no need. Actually, no need also, is it? Or you can decide that time. Because you're not
I
a
can decide
programmer.
Yeah.
It's a programmer.
This is the programmer job.
Programmer job to decide, oh, I don't like to use 19, I like to use 29.
Yes, correct.
Okay. But definitely hardware part is his job to decide how many rack, what is the rack number,
Yes.
what is the slot number.
What is this one? Yes.
Okay.
Okay.
Yeah, okay.
From here only, once I get all this data, from here only I give this data to the who designed the wiring diagram.
The I/O, you mean the I/O address?
Yes, I/O address and also the part number.
The part number.
Yes, because why?
Isn't this one choose by the hardware team, like?
Yeah, okay, of course they will choose.
No, I don't know lah.
Yeah, of course.
Yeah.
Like you ask me, because I'm doing all the job together, because
Yeah.
I'm doing a small
Yeah,
panel.
yeah.
But if you ask me to separate my job, is okay, of course. First I will design. I come up with the I/O list first, so it's another guy's job.
Yeah.
Then what I do is once I get all the IOs, then I will decide, okay, what hardware I want to use. Okay, then only once I know, then it become a programmer.
Right.
Programmer job. Okay, open the software, because only the programmer know how to operate the software. Right or not?
Probably in
Yeah.
general is one person really do everything lah.
Yeah, of course lah. Won't be one person do everything. Maybe one person is master in configuration, everything. One person is master in doing the control programming. One person is master in doing the analog programming. It cannot be one person do all the programming.
But for sure, I/O is always coming out from the control
Yes,
chip,
yes.
not from the
Wiring or
yeah.
anyone.
Okay. Yeah. Okay.
Alright.
So
Now, okay, so we got all the addresses lah. So I want to adjust the address, can adjust. Okay, click here. Just click. Just put 10.
10.
Yeah. I want to see what is the last number. Okay. Oh, starting with from the 19 only. Oh, okay. Okay, I just want to check. Okay. So it's not jumping like just following the number.
Okay.
So once done, okay, you go here. Okay, it's already added in the network. So this one will be in your control room. This one will be in your different panels. So maybe this panel is controlling, like you said, tank. Okay, is controlling the tank. All the tank I/O, input, output, the analog, everything will be going.
Okay.
Then after the tank, I process, I go into like a filling machine, for example. Then all the filling machine data, all that will be controlled by here.
Okay.
But who is holding the program? Is your CPU.
Okay.
It's just a distributed I/O, like an extend I/O. That's all.
Okay.
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 Now we go back. So this one understand?
This one understand.
Okay. So same concept like that one. So later we try that one. Okay. Now I want to show you the HRD system. Double click here. You close this one. Actually, you can zoom. Zoom to this card. Can you zoom on some? Full zoom. Okay, then you just move it. Okay. No, this is the second card. I want to see the second card. Because I want to show. Okay, next card. The next card. Because this is a 16D IDO. I want to go to the AI 16. Yes. Okay, can you see got two lamps? Diagnostic and maintenance. So if it is error or diagnostic, lamp is blinking. Okay, this is the element. I'll show you the picture.
Diagnostic maintenance. Maintenance is only happen when I force signal.
This is the chart.
Oh, okay.
This is the chart. Okay. So can you see? There's the problem right there. You see, some is okay, some is red color.
Right.
So diagnostic means some error lah.
Okay.
Okay. Maintenance means if you do some forcing on this card, we'll have a maintenance. Okay. Then can you see each analog will have an analog and also fault.
Okay.
AI0, F0, AI1, F1.
Okay.
So for AI6, the green lamp is not there. The fault lamp is there. Okay. So I show you how to take the data.
Okay.
Okay. The fault data. Okay. Now what you do? Can make it smaller. Smaller bit.
Okay.
The center. Okay. You just click here. Properties, right click property. Okay, so bring it up. Bring it up. Okay. Go to the module parameter. Inputs. Okay, so what are the diagnostic you want to read? You need to enable here first. Okay, so short circuit, overflow, underflow, wire break, sensor supply, HRD communication. If it is lost, then it will give you the what? Error. The
To
diagnostic
be honest,
level.
other than the wire break, everything else at number one. What is it? Just
Short circuit to the L plus means you don't get the proper L plus is to 24 volt.
so how he know it's a short circuit? Okay, I just curious. If you see this short circuit is diagnostic, let's say everything I uncheck, I check this one, and then give an alarm. So it give a fault. I don't have a false code, the code of the false, right?
Okay.
The fault. I only know this, but since I only take this one, it's a short circuit.
Yeah, of course.
Then I come to here and see.
And you need to check the L plus, means the 24 volt. 24 volt is there. If the 24 volt is not there, then means is the supply is not there.
Oh, this is mean the supply, something wrong with supply.
Yes.
Probably it's not there.
Yes.
Okay, got it.
Okay.
But this one is
This type, yeah.
yeah, it's something to do with the power supply lah.
I have to do with the power
But
supply.
in the end, most likely is you have to change the card itself lah. Not the card, the base itself lah, probably.
No, first you need to check from where I get the 24 volt.
Oh,
This one is not the 24 volt from the PME, it's an external 24 volt.
this one the power supply is really you get from all the.
Yeah, but for this module we will get an external 24 volt.
Oh, this.
For this
You know
module.
this is a IO card.
Yes.
It needs additional.
Additional to, because
power.
additional power supply. Why additional power supply? This power supply must be the same power supply to power up your sensors.
Oh, you mean not the power supply go to the card, but the power supply going out to the sensor?
No, because it's just 2 wire only. So 2 wire means it's just from there only. Okay, what I mean is this 24 volt I connect here, right, must be the same power supply, that is I power up my sensors.
Okay.
Must be the same power supply because must be in the same loop one.
Oh. So probably you say that probably okay. This is not a fault to the module itself.
No.
It's a fault to the outside,
Yes.
the sensor fault.
Yes.
Okay, got it.
Okay.
Overflow is a
The
negative
value lah.
27,000 lah.
Yes. Okay, the value wire break is okay.
Sensor supply?
If there's no supply in the sensor.
Supply.
Yes,
What do you
sensor
mean
power,
by-
sensor power supply.
A power supply.
Power supply
This
because
this
it's
two
a
also
sensor.
something.
Yes, it's a sensor. Okay, let's say because some sensor will have 4 wire.
Right.
They have active and also passive.
Okay.
Right.
Yeah.
So passive means I think it's together you will get the voltage and also I think no active I think is voltage then only. I mean it's together lah.
Okay.
Passive means you have an external power supply to power
Okay.
up your sensor.
Okay.
If the sensor is not power on, how am I going to get the value?
Okay.
The signal, the analog signal. So that is the sensor supply.
It's essentially it means sensor power supply.
Yes.
Okay. Okay. At least I got it. So this is a sensor blackout lah.
Yes.
Okay.
Now go down. So of course this is 2 wire, okay, HRD, okay, all this. Now you go to the AI configuration.
Okay.
Where you still sorry, okay, you go to the input here. This is where the setting. Okay. Input setting, input here. Okay, before that we go to the IO tag. Okay. Is the IW25 until 53.
Okay. This is for this card.
Okay.
Okay.
Okay, because this one is a boolean also.
So this is a
AI system.
but it also have a boolean
Yes, because
inside.
the statuses.
This is normal. Every AI always
Not all AI. All AI, normal AI just have the analog value. No need boolean.
don't have a boolean.
Because this is the H.
Only
the hard
because this is a
system.
hard. This
Yes.
has a boolean.
Boolean. But I'm not sure boolean is for what. You
Okay.
can check in the manual lah.
Okay.
What I get in the manual, go back to the general. Go to the general.
Okay. Wait. So
Yes.
I say this okay, don't have half again, but this is the AI card. From the AI card, this is the hard. How is the each always AIA or one address, it give you 4 ports, is it?
One address
It give you how many ports normally?
to do the wiring.
Yeah, to do the wiring to terminate.
2 or 4?
2 or 4.
If 2 wire is 2, 4 wire is 4.
Or you have to choose the kind. It's not like
Yes.
every time I give you AI card for sure, it spare you 4 ports like there. Sometimes it give you 2, sometimes it give
Depend
you
on the card I choose. Some is 2 wire AI card, some is 4 wire AI card.
Okay, so let's say I choose 4, but it's still a standard 4, right? It's this is a 0 to 10, 0 to 4 to 20. I mean the in and out signal, and then it's a plus and minus power.
Yes.
So here this
This one is a 2 wire only.
this is a 2 wire.
Can you see?
Oh,
2 wire.
oh, okay.
Ah.
So here show 2 wire. So each of it has a 2 port, 2 port, 2 port.
Yes.
And actually there is no additional DI
For DI,
for the
no,
boolean.
no.
But it has a DI, it's a
DI.
boolean address.
Because it's based on the signal I receive.
Based on the 2 wire,
Yeah, based
you
on
can
the 2
split
wire.
the signal into
Yes.
analog and boolean.
Yes.
Okay, got it. But the physical, actually there is no additional physical.
No, no, no.
Okay, got it.
Okay, you go to general. Okay, go to the hard setting. Okay. Now, okay, first I choose what type I want to use. Okay, hard.
What I mean by this one?
Okay. Wait, I'll show you one. Then, so channel 0, you click here. This one I can choose from channel 0 until go down. Go down. How many channels? 16 channels I will have.
So this is
Okay.
depending on the device.
Okay, no, not depend on the device.
Okay.
Okay, first, now, from each channel, I can take 1, 2, 3, 4 data.
Each channel can take 4 data.
From
Okay.
each channel, I can take 4 data. Okay. But I need to check what is the primary variable and everything. Okay. But what I know is in the secondary variables, according to the manual, this is where you get the fault code. Okay. If it is fault, you want to know what is the fault, right? This is where you get the fault code. Okay, let's say you click the secondary channel 0 secondary data. Okay, click there.
This one.
Secondary data. Okay. So what is the address?
59.
59. Okay. So what happens is if I key in, go to the watch table, and if I key in IW59, if there is an error, I will get an error. So okay, what I do is you go back to the IO tag. Okay. The boolean I'm not sure. You go to the boolean, I'm not sure what is.
So
the
you
boolean
see
is for.
here IW is only 25 to 55, right?
Yes.
Until 56.
Mm.
Just now what we choose is IW 59.
59.
I think what I get is okay.
The channel 0, right? Okay. The analog value is at IW 25.
25, yes.
Okay.
This seat I already booked by it already.
Yes.
Okay.
Okay. And if I enable the setting just now,
Oh, that one is not enabled, but if I manually go to enable it,
enable channel 0, okay, what I want to do, the secondary value. Okay. So the fault value, fault code will be in IW 50.
so
IW or IB, I'm not sure. We need to check the manual because we need to know whether it's in word or byte.
okay.
Because they didn't mention it's IW or IB. They just give you the value 59 only. I know the address is 59.
Yeah. Okay. So, but essentially what you're saying is now this seat 59 also booked already if I choose here.
Yeah.
But the question is, what is this doing?
What here?
Yeah, what is secondary variable is
Okay,
doing?
secondary variable we store the fault values, fault data.
Fault data.
Fault, actually the code,
Okay.
fault code. So in the code, you have different fault, different values.
But I have one IO card only. So let's say this IO card, just now I say I random say that 8 there is a hard device I connected to it. Or use I have 8 temperature transmitter all
Yes.
using hard. Go to this card here.
Yes.
So the fault is shared by the 8. Any one of the 8 has a problem.
No, the channel 0. Can you see channel 0?
Oh.
I have all the 15 channels from
Okay,
here.
it's only for the channel 0
Yes, it's
device
the
only.
59.
Oh, okay, I get your point.
Ah,
So let's say my channel 0 is from TT101.
yes.
So what I'm saying here is I can choose to hook the seat 59 to see some additional value from the TT.
Yes.
Say I want to see the primary variable, then choose the primary variable.
Yes.
So this seat will hook to log in the data or the information about the TT101 which go to the channel 0
Yes.
primary variable.
Primary value. So you need to know in the primary value what I get.
Oh, but
In the
one
secondary value what I get.
card is only maximum. Oh, not necessary because I choose 8 hard. That's why I have an 8 variable here.
Yes.
Okay, I got it.
Okay. Now,
So I can hook
What
8
I-
seat for 8.
yes,
Yeah.
what I do with this one. With the IW, I do the scaling. Right?
25.
Norm X and the scale, right?
Yes, this is from the IW25.
Yes.
Okay.
So IW25 convert to maybe MD10. This
Okay.
is where you get the temperature.
Okay, yes.
Temperature, let's say that TT1.
Okay.
Now, here you will get the fault code. Okay? So what I do with this fault code? Okay. This is just for example. I can't remember the fault code. Okay? I do a comparison equal because I'm not sure whether it's a word or integer. Let's say because normally it's if it is code, normally it will be word hexadecimal. Okay? IW59. Let's say the code is 16 hashtag 8F for example. Okay? This number you need to get from the manual.
Device.
From the manual, the
Okay.
hardware manual.
Okay, okay.
In the manual, they will say, okay, if this number, if this value, okay, this is the fault. If this value, it is overflow. If this value is underflow. If this value is short, violent. Okay. This is just the example. I can't remember what number.
Okay.
Then you create the alarm. The alarm is TT1. Let's say wire break.
I understand what you say. So you are saying, let's say I say this is a temperature transmitter,
Yes.
I go primary variable, this is the list of code. Secondary variable, this
Yes.
is the list of code.
Yes.
So if I want to get some information from the secondary variable, this one, I choose secondary variable.
Yes.
So when I receive this code here, then I do a comparison.
Yes.
If this code equals to 16 hash
Yes.
8F, then I show alarm this name.
Yes.
Of course, we are saying that this is receiving signal.
Yes.
Okay, I got it.
Mm.
Actually, we have the possibility to send out signal as well, but that's another thing already.
Yeah, that's another thing.
Okay, but here is for the hard card, you have an
Additional
additional option
setting.
here.
Yes.
You can choose. But why is only can choose 8? This one I'm curious.
I'm not sure.
Because let's say I mean practically. If I have a 15 channel here,
15 should be 15, but I'm not sure why.
theoretically I want to choose more than that. I want to
Yes.
choose.
One keypad.
Yeah, okay, never mind.
I
Okay,
think it's only available for 8 only.
yeah, so maximum I can use up to 8 function from the hard.
Yes.
Okay, got it. I got what you say.
Yeah.
Okay.
So this one also I never used before. This one also that day he sent the error. That time when I go to manual and this is what I asked him to check to know what is the error.
Got it.
Then only he can solve the issue.
You mean you asked him to program something? to
No,
see the
I
error code?
didn't ask him to program. What I say is you open up your program, you go to your hardware configuration, you go to the setting and you check here if they enable or not. If they enable, what you can do is you go to your wash table, just key in this one and you can see what is the value there.
Okay. But of course, if I disable everything here, then I don't have any hard fault.
Information, yes.
Yeah, then I will not get a fault from the hard
Yes.
if I disable everything.
Or just not the what input. Yeah, here. This what you mean this one, right?
Yeah, I mean this hard is because I enable something from the hard here, right?
Yes.
If I click here, but I mean I just imagine and then I select nothing here. I say none here.
Yes.
But right, I don't get any hard kind of fault here.
Yes.
Okay. Yeah, I got it. But this is for I/O card for hard. There is a special setting.
Special settings.
This is where you use it and where you do the program.
Do the program, or if you don't want to do the program, still can. But this you can use this program because I think this one they do this program
They did this program.
because they later part is send me the another what. Another image shows the alarm list lah in the SCADA. So it shows that it shows the correct module lah. The module, error channel, wire break. So means they created the alarm.
From the hard.
Yes.
Okay.
Because in the alarm list it shows that channel 13, channel 9, channel 12, channel 8, all wire break.
So probably this is something sent out from the hard module itself.
Yes. Means in the machine, in the system, they enable the function.
Interestingly, this is a very interesting function from the hard module, right?
Yeah.
Just now we choose the card. We enable the 59 here, the 59. But here doesn't show that we occupy the 59 here.
No. You go up. Because that one is a slot. The number just now you see is a slot number.
Okay, this is representing the hardware, you mean?
Okay. Can you see? I put it here. AI something right. At 16 right. It shows what? From 29 until 98 I'm using.
Really? Oh, it's not only occupied until 50 something.
No, it's already set. This one is already occupied until.
Oh, okay. So from the 50 something until 98, all are already spare.
Already some can use for some data. So the next one I want to use must be after 99.
Okay.
That's why this
okay.
addressing here, you double click here. Can you see can go up to how much? 32,000. The address.
Okay. So actually, hard AI use up a lot of
Address.
address. Okay, to spare for all these variable here. Okay, got it.
Got it?
Yeah. Okay.
Okay. Any question? This what? Actually, this hard is because I just that day I troubleshoot. That's why I want to share with you.
Yeah, very interesting. Yeah.
Okay, you go
Okay.
here. So any question on this?
So far, no.
So far, no.
Okay. Okay. Yes.
Okay. Profinet, that is Profibus.
Okay. Just change the color.
Yes, because thereby I can teach you about the OB, organization work.
Okay.
If error means whatever or that.
Okay. Okay.
Okay.
Got it. Yeah.
This thing so small, it's converting AC to DC. Oh no, this is only AC, is it?
No, it's a relay.
This is a relay.
Yes.
Oh, this power supply 3,
Okay, you see, this is the relay. Means this is your coil. This is the contact.
Oh,
So the live here, when I connect the live here will go here and standby to go back to here.
oh, it's just.
The contact is normally open contact. So your PLC will enable this coil. Then only the live will go. This one they call solid state relay.
Solid state relay. The in and out has to use what?
Which one?
To activate this relay.
24 VDC.
Use a 24 VDC to activate.
Activate the relay. Like so normal relay that day we use the normal relay, right?
But the relay we use, oh, okay, it's a 24 VDC. It's a DIDO. So
yes.
I can use a DIDO to activate
Yes,
this.
yes, the DO here.
Okay, okay.
This one is the normally open contact. Just connect. Why? Very simple. This one inside here got coil. The metal rod, right?
Yes.
So this is the one going to heat up the hour inside here.
This is.
I think we just modify. Normally whatever, this one will open, this one will timer run, then shut off, right?
When you say modify, you open up inside and
Yeah.
change the wiring inside.
Change the wiring, just remove this one.
Okay, okay.
Because earlier, this is the one control the temperature and the timer. After that, it will cut off.
Okay.
Right. So now what we did is, we take out this one. This one is still using, I'm not sure. I think the timer not using. Okay? So just to on it. Okay? It's on. Power on. Then when PLC on this one, the light will go inside and on the coil. So we'll heat up.
Gosh, I'm really interested. So because you modify it, right? Inside got some electronic
Not
board.
components. No,
Nothing.
no board, just a timer and the on.
All hard wire only inside.
There's no board inside.
Oh, that's why it's selling so cheap.
Yeah.
Or inside all hard wire go to this hardware,
Yeah.
and then the element is this
That's the
heating
heating element. So what happened? So when you put to like 100, right? So what happened? But if you don't have the temperature sensor to measure, actually.
This is a potentiometer.
Yes.
Okay.
So just on, and here is the timer. So it just maintain up to 100 degree.
Now you bypass this one, or you did not bypass this one.
This one I just make it like on off only.
Or you make it on.
So because if the temperature, this one won't control the temperature.
Okay.
So the timer won't work. So
Okay.
now this one will on and control the temperature. So we'll on up. This guy will measure, give the data to here. Then I do the PID settings to control my relay here. So this is what we're going to learn later. PID control. Now very simple.
I know what you say,
The concept very simple.
but this is slightly different to what is typical PID. Because a typical PID output is
Analog also.
analog also.
Oh, can be
Yeah.
analog, can be digital. It's, let's say for example.
PID can do output digital.
Yes, of course.
Okay.
Okay, let's say for example, this is the analog input. I get a temperature. Let's say inside here I put a cooling fan.
Mm.
I want to control the speed of the fan.
Right, right.
Then my output will be go to here analog.
Yes, yes.
Now I just want to on off the what the coil then. So the coil you cannot control like analog. Coil like just like normal positive negative only. So just can on and off only.
It sounds like a comparison, but I see, yeah.
Similar.
Similar.
To comparison. But why I do PID? Because PID will know when to on, when to off. If you take the data, then it will know when to on, when to off.
Okay, yeah. Hello? Hey, okay, Kevin, yes, sure. Okay. Okay, today you can do that. So you okay, but you say today I give you the information lah. Okay, 70%. Okay lah, yeah, I think it's okay. Yeah. Sorry? Yeah, I'm going to start work in September. Yeah, I see there is another course is interested lah, but that will happen in October and it's also in Penang, so yeah. Right, yeah. Yeah, now I'm in KL. Yeah. Okay, thank you. Bye bye. Okay, thank you. Bye bye.
Okay, so now need to power up. All power supply cable. All good. This one is the power supply lah. Siemens power supply.
Oh, this is the power supply.
Yes, yes.
Okay, okay.
So PLC S7-1200. It is connected to all these.
I want to ask, in Malaysia, is this center face is standard? It's always, I don't know, green is always the ground one.
Yes.
And then now black, if black is you go to the line, right?
Yes.
And white
Yes.
would it be other cable they show other color?
Yeah.
So
But this one is not the Malaysian standard. This color.
Is a what standard? Is a
I'm not sure this one was standard, but Malaysian one is this one. The normal single phase is
Brown.
brown, blue, but brown is light, blue is the neutral, and green.
okay, green.
But in housing normally because you have a three phase single phase, right?
Got three ways as well. I
Yes.
don't know.
Yeah.
Okay,
So
okay.
what is good? So will be any color. So the color will RY2, red, yellow, blue.
Yeah.
So this color will be the light, black will be the neutral.
Okay, so housing black become neutral.
Housing black is neutral.
But here black is light.
Yes.
Why are you asked? I mean, how you are so confident that this black is a light, not neutral? Yes.
No, if it is this color, this color, this one, right?
Yeah.
So white is neutral.
How you are so confident? Because in housing sometimes the black they use as a
No white color.
because they see that if you combine black, white, green, then
It's a
maybe
different black
is a-
and different color. Then the different color is the neutral. Other than the red, yellow, blue.
other than red yellow.
Yes.
So if there is a red yellow, then red yellow is a light.
Light.
If there is no red yellow, black is a light.
Yes.
There's a sort of rule.
Yeah.
Because this one is always something that always scared me.
Yeah.
I see the color, all the time changing, I don't know which is light.
Yeah, because different machines you buy. Because if you use German style, black is the light, dark blue. No, light blue is the neutral.
Okay.
Then they use not only green, they use yellow green. Yellow green mixed cable.
Yellow, green as a neutral.
Yes. No, as a earth.
As an earth, okay.
Earth
Okay,
always green or yellow lah.
okay. Okay.
Yellow green.
Oh, yellow, green, the stripe lah.
Yeah, like this.
Okay, okay. There's the stripe yellow,
Yeah,
green. Okay, okay.
Fault because this one is not selected. No fault, huh? Okay. This system fault because you just forget about this because this is the analog card. So for analog card you need to supply 24 volt. Remember that our analog card we supply 24 volt to power.
Okay. For this kind, you don't need an additional wire because you have this one.
Yes, yes.
For this one, you need to have additional
Yes.
wire.
To power up. To send the signal they're using this one. To send the signal here, okay? But to power the module, so you need the 24 volt. That's why the error here. Okay?
Okay.
So we just give it the error.
Okay.
Here we got error. Can you see it's got system fault, bus fault. Bus fault means the communication error.
Oh, passport incoming.
The bus fault. Okay, system fault means the system error. Okay?
System means the
System.
module itself.
Module is, let's say if I take out this, then we'll have a system error. Because for this module, I already configured this one. Okay? Now what we can do, actually we can use TIA portal to program this also.
Okay. Okay.
Yeah.
But the power supply no need to connect first.
No need lah. If I want to use, because
Oh.
we just That's
because
why
we want to only configure the module.
only
not
see the
client.
configuration only.
Okay, okay. So,
So-
I start a new project or
Yeah, you can save this project
okay.
and create a new project.
A4
Yeah, you put A for S7-300.
S7-300.
Yeah.
So I pick this model, right?
Yes, okay, I will show you.
I see.
Yeah, no problem. Okay. It's a 315 2 PND. This one you can see there. On top of
Right, 2 PNDP.
yes. So which is the part number? I think it's a EH30. Just click, okay. You click this one. Okay, mine is this one.
Okay.
Okay, wait. 216. Okay, okay. Okay, now actually inside there is a SIMATIC manager program is inside there.
Okay. Already inside.
Already inside. But I cannot back up because it's SIMATIC manager. I cannot use the
Oh, okay, okay, okay.
So that's why I just asked you to do a
Can
new project.
configure, cannot
I can do new project and can download
Ah.
using TI portal. So what happened? The 300 become TI portal.
okay.
Now it's SIMATIC manager.
Okay.
After I download, it becomes TI portal.
Oh, haven't back up yet.
So don't need to back up.
Okay.
Because actually tomorrow, Monday I have 1 day training for this one. Actually they are programmers.
They want to learn 300.
Yeah, they buy the software. So they ask me to show how to install and how to communicate with me. Because they are programmers, so they just want to know how to communicate or that. That's all.
Oh, even they are programmer, they need to learn this basic thing.
Yeah, because sometimes they don't have time to this one. I'm not sure lah how maybe because sometimes what they say,
They already
maybe
use
they are
that one
commissioning
model.
team.
Ah,
Maybe they are commissioning team.
okay.
Do commissioning, not a
Not the
actual
configuration
programmer.
also.
Not the actual programmer. That's why Monday only I know.
Okay,
They are
okay.
programmers or
Okay, okay, got it, got it.
okay. So now for that I have a power supply in front, right? The
Yes.
first module is the power supply, right?
Yes, yes.
No, this one.
Oh, this one?
Yes. So it's up to me. I want to add the power supply also can, without the power supply also can in the configuration.
Okay,
Okay. Just leave it no power supply.
okay,
We don't need to add any power supply. Okay.
okay.
So the next card is, I think it's a DIDO. You can see the card on top.
Oh, this one.
On top you can see.
SN321 Ti.
DI card, DI32. Okay. You look for DI32.
Yeah, 32, 24.
Yeah.
4V.
24, yeah. Open. Wait, 1BL00. You can see the one number. CP1 1BL00.
Okay, this is the one.
Just add. Okay, finish.
Okay.
Then we go back to this. Yes. Okay. Distributor IO. This one is a PT200M. Interface module. Profibus. Yes. So ours is 153-1.
This one I choose Profinet or Profibus. Actually, the hardware itself is the same.
No, because this is the Profibus hardware.
You cannot use a Profinet at all here.
No, because no connection for Ethernet port.
Oh.
This is a Profibus.
How you decide you want to use what?
Yes, yes, yes. That's why the configuration is very important before you buy it. Actually.
Okay.
Okay. Then the 15-1, the first one. Okay. Go down. What is about 1AA03? 1AA03. Yeah. Okay. That's the one.
Okay.
Okay. You add 2. Okay. Add another one. Okay. So the first one you click here. Okay. So the first one, this card is what? 331KF. Okay. Analog card. Analog input. AI. I think it's an 8 AI 12 bit.
Oh, okay.
I don't know the cover, I don't know. Yeah. 3317KF02, the part number at the side. 7KF02.
Oh, okay.
So actually from the part number, the front one, right, actually you can know what is the module.
Okay.
I'll show you, I will, that's a trick.
Okay.
I will tell you how. Okay, that's one. Okay, then you go to the second, this BIS. For this one is analog output. Here is
Oh, okay. 416.
A04 16 bit. A04 16 bit, yes, 7ND0. Okay, done.
Okay.
Now go back here. Okay. Now you connect the beside that. Yes.
Oh,
Okay. First for this module, you double click. You click here. Yeah. Properties. Okay. The MPI address, right? Okay. You click here.
MPI is Profinet, Profit Pass.
No. Okay. When you bring it up. Actually, this port, right? We call it as a MPI or DP. Can you see?
Okay, or DP.
MPI is multi-point interface, which is communication between laptop to here, just to download, upload using this cable.
You say in
It's just downloading, uploading.
the last generation, people have used MPI to connect.
Yes, MPI to connect. Okay.
Okay.
The same port you can choose as a DP, which is Profibus. If I want to do this networking, I need to choose the port Profibus.
I have to convert to
Yes.
Profibus.
Yes. Okay.
Okay, convert first at the PLC.
Then is a Profibus address too. Like IP address, they will have an address.
So Profibus using a different name for the address.
Address.
Unlimited 126.
126.
Okay, so maximum in the one network you have 126.
26 device you can connect using Profibus.
Got it.
Okay.
Okay.
Now go back here.
The way of connection,
Hmm.
because PLC is starting point only at one port, right?
Hmm.
And then it goes to every device. Every device also have
In and out.
in and out.
Hmm. So from here.
Oh, here actually also have in and out here.
Yeah, of course.
Oh,
Hmm.
so how you say, the sequence doesn't matter. The PLC can be at the middle, can be at the second, can be at the last.
No, secret, no problem.
No problem. And it can be an open loop, a serial from the beginning to the end, and also can be a closed loop.
Yes,
string.
yes.
Oh,
Okay,
okay.
so the configuration, nothing to do with the configuration.
Nothing to do.
Yeah,
This
because
is
the
something
configuration, in the configuration, he don't know where is the position. He just give you okay, from here to here.
as long as they are connected in some
Yes,
way. Okay,
yes.
got it.
Okay, then you go back to here. Okay, now can you see now become
Purple color.
Okay, now from here to here you connect. Yes. Cannot easy. Cannot connect, no problem. Then we can connect. Okay.
Go here.
Yes. Okay.
Okay.
Then you click on the address here. Okay. So the address here is 2, Profibus address. This one is 3, this one is 4. Right?
Yes.
So this one 2 because we can download here. Lah. We can change any number, can download here. But this one, how to change? That's where the deep switch is here. For the address.
You cannot configure here.
Can configure, but here I must change
Okay.
according to my configuration.
Redundant. You have to do double job here.
Yes.
Here you have to change again.
Yes. Okay, so let's say I follow this. Oh, now the first one is 4, the second one is what number? 5. Plus 4 and 1 is 1. You see, this one only the 4 is 1. If you on all, you will get 128.
I got your point.
Yeah, if you on all, you will get 127 and 8. Yeah.
Okay, I got your point. So you have to add up lah.
Yeah. So 4 and 5. This one is in binary lah, binary convert.
Okay.
Okay. So this is 4, this is 5.
Okay.
So you change this to 4, this is 5.
5. Okay, okay.
5. Okay, and this is 4. Just one click now.
Oh.
Okay. Okay. Good.
Okay.
Yes.
2, 4, 5.
Yes. Now go to program block. V1, yes.
To activate this IM, you need additional program block.
No need.
No need.
The additional program block is later. I will show you why. Why I need the additional program.
Okay.
Okay, first what we do a simple program. Just one input, one output enough. We're not going to test. But what is the address? Address also same like the one we do there lah, right? We need to check the address. The same thing. Just I0.0, Q0.0. That one no need. Okay. Now what I will do? Click here. No, PLC. Just download. Yes. Okay. Start search. I can use PNIE, I can use internet, or I can use the MPI cable also to download.
If I direct connect to the MPI,
Yes.
then I choose MPI here.
Yes, correct.
Okay, okay. Oh, okay. No problem.
It won't be an error. Okay, what compile now? Okay, cancel. You know what compile problem? No, this one bring it up. No, this one. Yeah, for compile error. Password was not okay.
Oh.
Click here. Protection. Go up. No protection. Okay. Download again. Select the PLC, download. Load. Okay, finish. See, very simple. It's a SIMATIC manager inside actually, right?
Right.
Means I earlier I use SIMATIC manager to download the program. Once I download KTP400, can you see it doesn't show any message that
Can I use?
no, it's not cannot use. It can use.
Can use.
But it didn't show you that earlier this is a
Oh.
it won't show you.
So it's
Just download.
compatible.
Yes.
Okay.
Hey, no. Why it shows actually cancelled before? Oh, this one earlier message, is it?
Okay,
I
okay.
think so. Okay, click here the CPU. Go online. Open log me. Okay. Open log is there. Okay, no problem. You click, click here. No, just click. Okay, good. Now. Okay, can you see there is an on-off switch here?
Okay, yes.
Okay, here also got. Here
This
also
one
got.
is special, this one.
No, got.
Oh, okay, okay, okay.
Here.
Okay.
On-off switch is if it is I'm coming and going out, right? Then I need to off. If coming only, I must on. Okay, on, can you see R? R means resistor. Earlier days, what they do, if let's to show this is the last one, this is the first one, okay? Because inside got loop, right? To show this is the last module, this is the first module. Earlier, they will use a terminating resistor.
Oh,
Have you heard about that terminating
No,
resistor?
I
Normally they
never-
will, because it's a 9-pin, right? They will inside here, they will do some terminating resistor. So now the new modules, they are just on off the resistor switch to tell this is my last.
Okay.
Here also same, here also I on. Means normally the first one and the last one always use the in only. Even though this is the PLC, it's not like out, no? Must be in only. Okay, the first one and the last one always must be in the middle will be in out.
Okay.
Okay. Now you see the moment I take out this, got bus fault and PLC go to stop. Okay. This is what we want to solve. Like I said, if you download the special OB, it won't go to stop. But if you show bus fault and error, PLC still can run.
Okay.
Okay? Then after I connect that,
This kind of incident only happened with the bus, but not the Profinet.
profile is the same.
Oh,
I mean the
on-off.
switch.
Yeah,
the
this
switch.
on-off is only the
No,
Profinet.
the profile.
But this password is universal lah.
Universal both for both.
Okay,
And then
anything
able to
lost
take
communication.
lost communication of course.
Okay.
Now the communication is back. Okay? But you see still shows stop, not automatic run. So I need to manually stop it run. Correct? So in this one you cannot do like this, correct? Because if suddenly this one is some power trip or something, suddenly power loss and come back, then you will go to manually go and stop and run.
Then you will reset everything.
Reset everything. Not just stop. If you MRES, then only is reset.
Oh.
Okay. Okay. Now what happened
If
is
you stop, the TV, everything will still remain the.
yeah, of course. The value, everything will be there.
Oh, okay.
Okay. Now. So now what I want to do, I want to even this one, if I off, off right. If I on means what happened? In this signal, the signal won't go to here.
Okay.
Got error also.
Why?
Because-
the tree.
Yeah, because this guy already disconnect this guy. Can you see here bus fault?
Yes.
Here no bus fault. Because this one, this can still can see this module, but cannot see this module. Okay. Then this one normally in industry that last time I do troubleshooting everything. They say you come and simply sometimes got error, right? They don't know what to do. Just on off, change these values. Yes. Don't know what is the meaning of this, what is the meaning of on off. Sometimes happen like that. Then suddenly
Okay.
problem. Then morning the engineer come and see all different. Then you need to change back.
if there is not a control card.
Yes, of course. That's why you must make sure if it is, you know, if it is, you don't know how to do, don't touch.
Yeah.
You know that like last week I have one uncle lah. He's very old. I think he's 72 years. Want to come and learn PLC.
Huh.
Because he doing projects. So for his project he need a PLC. But he say he want to understand how the PLC works. So then he can hire a guy to do the programming and everything.
Right. What kind of project is it?
It's a filling machine, sauce filling machine.
Oh, you run a project manager.
No, it's they are building machines.
Oh, I see.
So normally he'll build a machine using like hard wire, all relays, everything.
Oh.
So in this case, he want to run conveyor, automatically run the servo, everything. So you need to use the PLC.
You have to contract this out, but you have to know the basic first.
Yeah. So because he's designing the machine, everything. The PLC side you want to give to others lah. So you want to know how it goes. So then only you know what PLC you want to use, everything. Just want to know. So he told me there's one machine. So he showed me the picture. There's one machine. It's using Panasonic or servo machine. It's an automatic screw machine. We have some plate. There's one servo motor come, take the screw and go and screw. Okay. That one, he take picture and send to me. The panel is this big. On top is the machine, down is the panel. The wiring, all like this, boring. The wiring. You know who do the troubleshooting? He said one Myanmar guy. He's operator, it's not even a technician. So when he go and see, he said, he told me that, he told the company, I cannot troubleshoot this one here, I need to bring back the machine. Machine is very small, I mean this big one. He said, I only can bring back the machine, then only I can repair it. He said, okay, then I will bring. So now he's in this company. Yes, now.
Okay.
Now we see when the communication is not, my PLC go to stop. Okay? Okay. You off the second one? Yeah. Off or on? On. Yeah.
Okay, fault already.
Fault already. Okay, leave it fault. We see what is the message. Okay. Got fault, right? Okay. So whenever I have a fault, I can go to online and diagnostic.
Okay.
Yes. The main thing, whenever you have fault like this, you need to know where to get what is the fault.
Okay.
So in PLC, if you PLC or VFD, later when we do VFD I show you, whenever I have a fault like this, you go to the online diagnostic and diagnostic platform. Yes. So it will show you what is the error.
This is sort of like an alarm.
Yes, it's an internal alarm, internal alarm status.
Okay.
So when you able to understand, read and understand, you can solve the issue. Or you can open the manual and solve the issue. Do you face this type of alarms when you do commissioning? Suddenly the VFD not communicating, show you fault code.
Actually, it's rare. If it's
Rare
already running,
Already running is rare lah. Okay.
Yeah. But it's a good thing to know.
Yeah, of course.
Because during initial setup, definitely it's always a lot of problems.
Definitely, but you can use the same concept to solve other issues also.
Okay.
Now error stop. What is the error stop caused by a rack failure? Rack failure means my PLC cannot detect the last rack. Right now.
Right.
Actually, there also you can find out which rack is the failure. Okay. Because you see, like just now we discussed, this CPU will be in the main panel. The other two one will be in the different panels.
Right.
So how to know which one is the fault? Let's say you have 20 of them plus your VFD everything. So how to know which one is the fault? Because here it shows the OB not loaded only. Okay. Okay. This one can bring it up. Okay. So it shows the OB not for this one. Okay. Okay. Go down. distribution I/O station failure. Yes. Go down here. Okay. You see, okay. Actually, this is where all the data is here. Okay, you see, distributor I/O station failure address is number 5. The Profibus address number 5. Okay, and requested OB. Can you see? OB86. Okay, so I will tell you what is that. Okay, first, it will show you the address number 5 lah. Okay. At the same time, we go to the device and network. Here also it will show which one is not communicating. Can you see?
Okay, so this is not communicating.
Yes, number 5. So when you go and check number 5, is number 5 actually still okay? The problem is at number 4, the connector.
Right. Okay, people doesn't know.
Yes.
They don't know you have to switch from number 4.
Yes, because it will show number 5 here, right? So what do you think? What do you think? You will go to number 5, right?
Right.
Okay, then you check number 5, everything. You look like okay. So what you do? You open up your wiring diagram. You need to check because in the wiring diagram normally they will do this configuration from which Profibus they do. Then you need to come up to number 4 and check.
I know what you mean. I get the picture here. The picture is if this, I mean like if a new project is done by the automation team then this kind of incident is very rare because
because
they know very well how to configure this. Yeah.
Normally what happen, actually this is the first stage of when they come and do commissioning on the hardware side, software side, this is the first stage. Means they will check all the configuration.
Yeah, they know inside out or this one happen like this. Definitely the switch is wrong if it's using a Profibus.
Yeah.
But when they hand over to the client, and the client probably have a lower skill level,
Yes.
then he don't know how to troubleshoot
Yes,
this one.
that's the thing.
Yeah.
So that's why normally I will teach to guys whenever I teach this one, but this one is also very rare I teach. Because you know why?
Yeah.
Don't have time sometimes. So when they have no only basic knowledge, so sometimes don't have time. So I don't have time to teach all.
But this is a very useful for
Troubleshooting on the hardware side.
for the existing
Yes.
operator.
Operators, yes,
Yeah.
because you know why? This is the common problem.
Because they will always see this kind of problem and they don't know who flipped the switch.
This one.
Yeah.
And another thing is, this one the common problem is with the connector. The head sometimes if let's say the last morning power trip, okay, sometimes what happen, the head will be affected, the connector.
Right.
So what you need to do is, you take out the connector. It's a 2 cable only, like cut the cable, reconnect it. Then can go. You know what happened? Like last time I give training for Casper in Shala. I give training for TI portal. Okay. So that time they told me they have an issue with this Profibus, always Profibus error. Okay. So they use there's a 2 type of the connector. One is you put and screw. Other one is like a slot in like this, like a cover, like a connect, like this only. So it's like, so how it works is they have like 2 metal like this. When you put the cable inside, then this one go inside like this, like a knife lah. This one.
Okay.
This one will cut through the insulation, will touch the copper inside.
Okay.
There's one type of connector that is like a slot in line. There's another connector is you need to strip the cable and you need to screw.
Okay.
Earlier they used the connect one. Okay, always problem. So one by one they change to the screw type. That one also is one problem because the new stock they buy is a screw type. This one problem they try to solve cannot. Okay, they throw the one, they connect it. Then after they say, because this one happened for like 6 months on and off problem. After they almost change everything and then only they get to know that the connector is the one problem. It's power trip the connector problem. Power loss connector problem. So then what happened, I think they have another 6 or 7. Okay? So they one shot change everything. Then after that no problem. The connector.
So this Profibus connector is not the best thing. Yeah. Can choose the Ethernet.
Ethernet of course lah. Ethernet is the best one.
Okay.
Okay. Now, so now we know what is that. Okay, just enable that on off that. Okay. Okay. So get back to the connection area.
Okay.
But the error is still there lah.
Okay.
Yeah. What do? You stop and run.
Oh, so refresh is stop and run.
Yeah.
Okay.
Okay. Now you go offline. So now we know already.
This stop and run must do from the hardware, cannot do from the TIF also.
Can.
Or can also.
Okay.
Or you can manually like from here stop and run.
Yeah. This is the one.
Oh, okay.
Okay. Now. So now the problem is we know actually this one we can do with this one, but I don't have the modules, the interface module using Ethernet. I only have
because this is Ethernet only.
yes, the
okay.
I don't have with the Ethernet.
Okay.
That's why I'm showing with that one.
Okay.
The concept is still same lah, right?
Okay.
Now the problem is when one of the this one problem got error, right? Got error and PLC go to stop. Okay, why stop? Okay, according to the message just now, it shows that station failure, right? Rack failure. Okay, and it shows that OB86 is not loaded.
Mm.
Okay, why? Okay. So we need OB86 is similar to your OB1, correct?
Yes.
Okay. And OB1 you know, right? Normally
Main
normally in the main OB we don't do any programming. Normally we do programming in the FC, FP, then in the main OB just call only, correct? Okay. And OB1 is the main organization block.
Mm.
So what happened? So I have OB1. So when the station is failure, so it is a alarm, it's a fault. So there is a fault code I need to send to my program. It means the concept is I have a fault at the hardware. I need to tell this information to my program.
Mm.
Okay, so the code will find for OB86,
Mm.
the fault. If the OB86 is not there, what happens? The code will go to your OB1.
Okay.
Okay, that is the concept. That's how it goes.
Okay.
We go to the OB1. When it go to the OB1, what happens? It will interrupt your program. It will interrupt your cycle. That is why the PLC goes to stop. Okay.
Mm.
If it is OB86 is there, this is the fault. Okay. When the fault happens, the fault will look for OB86, send the fault value, like just now we discussed about the HRD, the concept. Send the fault data to my OB86.
You mean in a PLC, any fault actually
Not any fault, the rack station fault.
rack station fault?
Yes.
Okay.
Why? Because OB86 for the rack and station fault.
Rack station fault means cover what? Cover all the bus communication.
Yes.
Okay.
Ah.
A bus communication fault is rack station fault.
Yes.
Okay.
So what happened is, so the fault will go here, so it won't disturb my OB1.
Mm.
When OB1 is not disturbed, so the PLC still can run.
Mm.
Only thing is that particular remote I/O cannot work.
So we can have an option to choose
Yes,
non-critical.
normally they will do this
Mm.
because they don't want to stop your system. Of course, from here you can create an alarm, everything. Okay, so that's what we want to do. Go offline. We go to add new block. OB. Okay, time hardware interrupt. Okay, no. Fault interrupt. Okay, here. Right fault. So add this and download this to my PLC. That's all.
So you mean if I do this, in future all the rack station fault will not stop the main, but it will accumulate in the OB86.
Yes.
If I don't have this additional OB86,
Yes.
everything will
Goes to
send to
my
the main
yes,
OB.
OB1.
Can I ask more about
Can.
this OB? Let's say I just try to because I think we covered quite a lot about these three.
Yeah, that's why I just.
But because all the time we are assuming OB has only one OB because it's like a main programming page, right? The OB.
Yes.
So, but actually you can have a lot of OB also.
OB, yes.
So what does it means by having a lot of OB? Meaning
Okay,
to
it
say,
depend on certain type of program, then we use certain type of OB.
okay,
Okay? Okay. For now, we use the fault interrupt OB. Correct?
right,
Okay, you open the fault interrupt, we see what are the faults available. This one is a intricate cyclic fault. Not showing here.
select OB, or I can change the number if I want.
But I think it's normally this is standard lah. But this one you need to open the manual to get what is the meaning lah. But commonly I use the where's the OB86? Oh, already used, right? That's why it's not here.
Yeah, but what is the concept of this one? Let's say the main
Okay, that's
OB
a
is
communication fault.
Yeah, it's a
Okay.
Let's say this one.
Okay, but for this they have a meaning. Why? Which fault it can stop?
Okay.
Not all the fault it can stop.
So the fault interruption mainly it interrupt the fault.
Yes.
Don't let
Don't
the
go
fault stop the.
go to OB1.
But how about all the rest? We have
Okay.
alarm, we have
Yes.
startup.
Okay, actually everything is got a meaning. Okay, you go to hardware interrupt.
Okay.
For hardware interrupt, I think is the OB40. OB40 is it's similar concept like OB86, but need to know what hardware lah.
So all these OB here, you don't do any programming inside. You
No,
just
no.
add this
Some program need to do.
some programming.
Okay, I will tell you what.
Okay.
Like this cyclic, we go to the cyclic. Okay. Cyclic is okay. OB1. Okay. See, like OB1. How the OB1 works? Like it's a main program,
Mm.
correct? Okay. So they have the what? A
Scanning.
constant scaling time,
Yeah.
scanning time.
Right.
Okay. Cyclic means you can decide the timing
Okay.
when to scan. Okay. So some special programming need to do inside here.
Okay.
That is later when we do PID block, the PID block we will be doing in the cyclic interrupt.
Mm.
So later we will do that.
If I imagine correctly,
Yes.
I try to I'm not how is it? I try to get the overall concept first
Yes.
because the main OB when you do the main OB essentially we are imagining we are converting the hardwire
Yes.
to the PLC, right?
Yes.
Imagining inside have a hardwire
Yes, correct.
wiring diagram, and this is how we do the wiring to give that function. Doing all this additional OB, there is no such thing as a hardwire to represent all this.
Yeah.
So this is like it's a really a programming. This is
Yes.
this is a really programming.
Yes.
You do this, you add this because you want to get some function.
Data, some data from these two, whatever we connected, some data from them.
Okay, it's not doing a logic. It's not
Doing a
doing
logic, no.
Not doing a logic here.
Not doing logic. Okay. Some we need to do logic. That also is a special logic. That's all. Like you want to do a PID. So
Okay.
PID will have a special block. So
Okay.
if because sometimes the PID can only because because PID is based on the timing, right?
Right.
Correct. PID involves timing everything. So I need to put inside a particular block. Then only can go properly the value. If it is you use in the main OP or in the FC, it won't work.
Question.
Yes.
Because you work for this so long already. Is it an old, very old PLC from Siemens? Don't have the PID block.
What?
All the time also have.
What? I think before this I don't think so. I mean the S5 lah.
Or before the
The 300.
Before the 300 don't have.
I'm very not sure.
Okay.
I don't think so because even I see the programming also very difficult to program. It's just normally there's a basic programming like how you open, how you close, output,
Just
timer,
monitor.
counter.
Okay.
It's basic, very basic programming. Not like now the latest programming. The latest PLCs are for so many functions can do.
Okay.
So starting from this all you have the PID blocks.
Okay, got it. Okay, understand.
Okay.
Yeah.
So like I said, some like this one the fault interrupt, hardware interrupt is to store the fault values.
Okay, to store
Like,
the fault
yes.
value.
Like time of day, time delay, recycling, or in the alarming, startup, all that is like a special programming blocks. Only if you want to use the special blocks, then only you can use this.
Okay. And then if I have a function block I want to use, I cannot just throw it to the main
Yes,
block.
correct.
Okay, got it.
Okay. Now, OB86 is there. So later on, we will be using the one OB for this PID block.
Okay.
So you can understand better. Okay. Cancel. Okay. Now I don't. Okay. Now you download this. You just click here.
PLC.
Yeah. Finish. Okay. Now done already, right?
Yeah.
Now you do again. You see the PLC go to stop.
I have a passport here.
Bus for there. Is it PLC stop?
And I have to check back to here, right? Oh.
Go online. Actually, you can go online lah. You can see. Okay, you click here the PLC. You go online.
Oh, I have to click on.
Yeah. Okay. But the PLC go to stop or not? Is it a stop LED is on? No, right. The run only on.
Which one is the stop? Oh, okay, the run is on. Yes,
Yes.
the run is on.
The stop is not on, right?
Right, the stop is not on.
Earlier the stop is on.
Okay.
Now you see, now I solve the issue. So I don't know what is the issue. Solve the issue.
Okay. So this is one way to use the OB to absorb the fault.
Yes. Okay. Now go to the right fault. Now where the right key. Inside here you can see got something like event class, fault ID, OB number. Okay. Actually, all these are, you know what is this? The internal variables, right? You know, like FC, FB, we do the internal variables,
Yes.
similar thing, but all temporary only, lah. Okay? If there's a fault, this data, you send the data here. Okay?
This is a list of the fault it received.
Yeah. So each one. So here it will store the fault. If the value is 38, means no fault. If the value is 39, means it's a fault.
Okay, not only 1 and 0.
No.
Okay.
Okay. Then in the fault ID, it will show C1, C4, C5 lah. Forget already what is that. You need to check the if you want to know what is this, you need to do the OB86 manual. But there's no manual for OB86. There's the manual for the 300 Inside there you need to go to WinCC. Okay. Here, here you can know the rack number. What is the number? I think here base address of the I module are. This is where you can get the what error. Actually, you can click here. Cannot monitor. Okay, monitor. I see can monitor.
This is the variable, but there is no address here.
No address. You remember the what?
Because there is no DB, no MD,
No,
nothing here.
nothing.
Nothing here.
What you can do? Okay, maybe we can try one. You open it. Maybe we can find out. Okay, you click here. You put a compact. This equal. Yeah. On top, I double click. You click here. Okay, we use this. Okay. Event class. Yeah. Okay. Here you put hashtag. 16 hashtag 39. 16 hashtag 39.
Okay, just down the value.
Yeah.
16.
Hashtag 39. Yeah. Because why 16? Because this one is in hexadecimal lah. If decimal means just 39 enough. Okay, enter. Then just put one output here. Okay, just put M10.0 lah. For example.
M0.0.
Okay, M0.0, 10.0 and
Oh.
download.
Okay.
Just want to know. Okay, download this. Yes. Okay, monitor. Here.
Okay, now it's running.
Okay.
So if I switch it, probably it will go to green.
Okay.
Nothing. But if I switch it, I see the value just now. I can see some value with default it, because I have to go to the watch table.
No, here cannot see.
Can I see?
Cannot see.
But if
Wait. I forget one thing. Maybe which one I forget. Because this is how we do program. Okay, now when you open. Why is not showing? Okay, go offline. Okay, you go to watch table. Okay, what do? You click here.
here,
You add one block here, maybe here. You click here. You go to instruction. Move. Yes. Take the move function. Yeah, put it here. Move is from one data to another data. So you take this, you put it here. There will be the same tag. Yeah, the first one. Okay. Move to MB because it's a byte, right? Can you see it's a byte? Huh? Okay, MB 1. Okay, you download this. I want to see where it's stored. It's not showing value here, no problem. Go to watch table. Add new watch table. MB1. Okay, monitor. You make it smaller. Okay, you close this. Wait, no, not close. I mean, make it smaller from top. Yeah. Okay, enough. I know it. Okay, you called the OB86 in main.
I was thinking there must be some way. I don't know whether it's true here or not. Like from your SCADA, you get the diagnostic information.
Mm-hmm.
It's possible, right? Like from the SCADA, you get the diagnostic information of, or you have this hardware I/O card at the rack 14 is not working. So the SCADA show that there is a problem here.
Yeah. That is what
That's where this is doing.
Yes, we doing here.
Oh,
So
okay.
here we can know, because here I can know there's a fault. Then there's so many temporary tags, right? One of the tag will show the which Profibus is the error.
Okay. Okay.
Yeah, because I want to see.
Go to the toilet first.
Yeah, sure. You go back now.
It's running. This is on, but there's no passport. This is passport.
Okay, you off. Then you on.
On again. You mean switch again
Yeah.
to make a passport here?
No need passport.
Okay.
You know passport, huh? Then why is not updating? It still show error. Is the error is there? In the
Now it's blinking. I just saw it's
the error.
the area.
That's
Yeah.
Okay.
But there's no cross here.
Because this one need to be.
Okay. Which one is on? On is a terminate, right?
This
Yeah,
one
on.
this one.
Oh.
That's the problem with this one.
Oh, it's not high, right?
Mhm. There's a problem with this connector. Take out, you put on, I'm done.
Doing connecting all these connector is a installer job.
Yes, yes, yes.
When they buy a whole row of the
Yes,
either
yes.
it's a coffee bus or
Overhead connector separately.
then they cut it and they connect by
Yes,
themselves.
connect. Because need to know what is the distance, everything, right? Other thing is, if you're using this one, it's more than 100 meter, from this to this or from this to this, you must use repeater.
Repeater.
Yes.
Repeater is like for profit bus only or for anything.
Profibus,
Profinet?
Profinet also got, but Profinet normally because Ethernet cable can go
Longer.
1 kilometer, I think can go. Above that also you must use repeater.
Profinet inside is also like this is a 2 wire.
No. Profinet is actually Ethernet cable.
How many wire inside?
8 wires.
8 wire.
Yeah.
So you're connecting the Profinet cable to the connector. It's actually real time consuming.
No, not time consuming. Because what happened is because to cut this Ethernet cable they have their own cutter for it.
Okay.
So just cut, need to strip
Okay.
all the 8 cables, right?
Okay.
Just you put inside, there's the screen for me. I have this.
Normally, do you know how to do it? Can you teach me that?
Okay, but I don't have the Profinet. For the Profinet one, I don't know. I have
I
the.
just like want to know for installing how long this kind of work will take. For doing let's say imagine we have a lot of Profinet, not to say Profinet, Ethernet cable. Then how
Of course, I'm sure they will have different tools, but tool I have this one. I show you.
this is specially for the
Ethernet port.
Ethernet.
Yes.
Oh, you need to use a special tool like this.
Yes.
Okay.
What is this?
Okay. But if you want to do the simulation, we can sort of exclude this logic, is it?
Yeah.
And then you just simulate this
Yes.
to fault this one.
Yes.
Up is terminal. Down is continue two-way.
Yeah, yes, yes.
Terminal two-way. Terminal.
This is the problem. This one is going on for me to keep signaling.
So they can change this too. This one to here, this one to here.
Still doing the same thing. Okay, so. Off. You see, this is the one that I said, the slotting one.
Oh.
This one is not screw type, right? This is the slotting. This is the one always give problem. See, this one is in working, out is not working. How to? Because this one can communicate, but this one cannot communicate. Means it's the out. That's running on 5 volt. One process, I mean, one short lab. This one.
Communication. How many M inside there?
I mean, this cable,
This cable.
very low. This one is at 5 volt. So it's just bringing communication data, transmit, receive. So I think the M is okay. This one just 5 volt. Okay, running on 5 volt. The one is why I know because there's one training. He asked me this question: how many volt? I also don't know. That's why people will check.
Oh,
So they say the profitable cable is 5 volt. How is that so? Okay. Now I got the number. Can you see 39?
Okay. Also, we successfully exported the fault to
The
a
fault.
to a memory.
Yes. So if no fault, it becomes 39.
Okay.
But this one, cable. Need to cut the cable, need to connect again, then only cable.
Okay. Go ahead.
But this one, you get the idea,
I
right?
get the idea. I get
So
the
this
idea.
one is from one, because inside there got so many data. From one of the data, you extract the value already. 39. 39 means is Profibus error. 38 means no error. So you can do the comparison. Below, you bring it down, the wash table. There's the wash table. You bring it down.
You can open it, right?
I want an additional one more line. Okay, you put it here M0.0. M0.0 just now. We compare the one on a memory.
Yeah, M0.0.
Okay, you put it here M0.0.
True. True is meaning to say is really fault.
Oh,
I get what it is,
yes.
and then because we have only one OB86 here.
Yep.
Imagine
It will just okay. This true is just to show there is a Profibus error. That's all. It won't show which Profibus.
right.
Okay, you go to Redford. Okay, now can you see it's on? Because it will. This one will be. Like just now it's not green color, right?
Right.
Okay, but why? Because this OB will activate when there is a fault only. When there is no fault, it won't activate.
I have a question. Maybe we don't have to do programming, but just a concept
Mm.
wise. I normally have seen the SCADA. They have a hardware diagnostic page. And
Okay.
then you click to the hardware diagnostic page. You have the PLC, IM, card, all this, and then you have all the LED button there on the screen, on the computer screen. And then anything goes wrong, we just go to the diagnostic page. Then we see, this I/O card is a red color. The PLC is still good, it's a green color and so on. It can very clearly indicate this one.
Yes.
So this is done through this
This?
red fault here.
Red fault here, but in the red fault, okay, this because why I using the move function because I want to see the 39 just now cannot write. That's right. Actually, this one only, this one enough already. So M0.0 it means there's a Profibus error. It's not which rack.
Right. So
Okay.
we can't tell which card has a problem.
Can. That is you minimize here. No, okay. Go back to the record. You open this. It's from the right ID. If not mistaken. If this one or this one, I also forget. Need to check which one you. Or okay, I think this one.
You can specify.
The word. I think
You can specify this one.
like this. Like this.
No, not this one. How do you specify?
Like you go down. We check. We try to check. You go down here. No, here. You add one more move function. Go to instruction, you take one more move function. Okay, you click here. Click here. Yeah.
Oh, you mean click the selection. Okay.
Yeah,
okay,
selection. Okay. This one, base address. I think this is the one. Not mistake. Okay. Yeah, click that. Okay, you put word MW2. Okay. Then you download. Okay. Now because no error, I mean there is an error, but it's already the error is happened, right? So what I have to do, I have to stop and run again. Okay, you go to the wash table. Okay, you add MW to here. It's not showing. Show the value.
But there is some way, like, there is some way that.
No, in this one in the MDL address, right? Here it will show what is the address. Which is 4 means 4, 5 means 5.
Oh.
Okay. To show the addresses, to show the value here. Now why is that? So the cable need to read this way. You go offline. Offline the PLC.
Offline.
Finally.
Yes.
Okay, no fault. Okay. No fault, huh? You go to wash table. Make it smaller. Just 3 line. Okay, now you go online. Monitor. And this one also monitor. The wash table also monitor. Okay. This one is the earlier message. The earlier message is true. Okay. Now this. Can you see?
Oh, it's triggered.
7FF.
So 7FF is the hexa number.
Yes, I will.
So like a convert, then you get something like 5000.
Yeah. Okay, let me. Can you see? Become 38 false. Is it? So 7FF, and it's not that address. Which address? Okay, you go back to minimize this. You click here. Right fault ID, click here. No, wait. Yeah. From here, where's the plus 31 right fault. You click here, just give me like 1 minute.
Probably this is specify
Which rack
like
is
0 to 31.
Which rack is the problem, right? Yeah.
Right. 0 to 31 also quite not a lot.
32.
32.
Yes.
Oh, so there's 32 racks side after you can have the green light.
Okay, first time I did. It's making me what
Definitely, this is where we do this kind of
yeah,
function.
programming lah.
Right. So
7
to show the
you go
SCADA.
to calculator, you convert as 7 right?
Not calculated.
The computer calculator. Yes. Hexadecimal 7
3000 decimal 2047.
So 2047. Slave interesting. No. What is the name? What? What do you do? You close. Which one is a 32 boolean, right? Usually you can move also. Take another move. Move function. Because 32 boolean is one word, correct?
So one
Double word. One double word.
Isn't it a boolean? So this is a 1 and 0 only.
Yeah.
So this is like one and only.
No, you click there.
Okay.
Double click. Take the arrow. Choose the
For ID.
what ID. Which one is that?
Right. Oh, it is
For-
right. For
TD or okay. actually because it's 32, I can move to a double word. Because double word is also 32 people.
Right. Okay.
Okay. Okay, never mind.
Okay.
Close this.
You did it.
This is where I can read the address. Which address is, because it shows it's right in the spot.
Have some
The
little
OB
export.
same OB86, if I use in SIMATIC Manager, it's different. So in SIMATIC Manager, there is one, what they call, one variable to show the value. They call what actually?
But this is a correct place. Just have
This is
to
the correct place, just need to know which one.
how to get this information out to the memory.
Oh, okay. This is the one. Okay, we click here. Use move function. Move. Okay, wait. What is the number? Okay, you put LB. 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 0, 1, 2, 3, 6, 8, 10. You close this first. Okay, the address. Okay, go up. Go first. Go up. Okay, let's say this is the byte 0 lah, 0 1. 0, 1, 2, 3, 4, 5. This is 6. This is start with the 8. LB 11. Put LB 11. Okay. Then this one is the, it's not occupied by the time. Put them in, you try and see it. You put or hashtag LB. Put them in. You put it here. MB 4. Yes. Okay, you try to download this and see. Okay, yeah. Add MB4. Okay, you create the alarm.
Sorry.
Create the alarm. Yes. Address number 5. Okay, but LB11 I will tell you how I get LB11.
So now it is telling me that
The address number 5.
address number 5 is getting a problem. If I use a profit net, then my address will be a long
Yes.
4 number already, it's not a 5 already.
Yeah. I think it will show the last number.
Okay.
The IP address is the last number.
Okay.
Where is my organization block?
But the concept is this is a place that so
You get the data.
you get the data for the diagnostic to show on the SCADA.
Yes, that's it. Okay, why LB 11? Why? Because here you can see the value. If it is what? SIMATIC manager, here it will show the address. Means not the address, the data. This is the first one, is it? No, go up. So it starts with byte 0. You make it bigger. So you start with byte 0, right? This is byte 0, correct? And byte 1, byte 2, byte 3, byte 4, byte 5, okay? And this one will start with 6, correct? And 6 and 7, correct? Because it's a word. And this one start with the 8. And this is 32 bit, right? So it's a 8, 9, 10, 11. Okay? 11. Then the last one will start with the 12 lah. Okay? So why LB11 is the 11th byte? Means it is stored in the right fault ID.
So each of this OB actually is a LB itself.
Yes.
LB is a stand for what? Long block or
No. Not byte. Local byte.
local byte.
Yes.
Or DB is a
DB is a data block lah.
other block.
Yes. So LB is the byte number.
You mean anything like FC or FB or OB? I also can use this LB. No.
Yeah, I think so. I'm not. Can.
Not people don't do this lah.
Don't do this because you can use that.
I can use
Because
that.
why? Not only okay. Why for the particular this one I need to use the LB. The others all no need. You go up and close. Okay, like go up. Go up. You see, for this I don't need because for this I already have the tag there.
Right.
But for the rack address I don't have the tag. The tag is the tag byte number 11, which is where you store the values.
Got it.
So that's why. So inside here got 32 bit, right? Starting from 8.0 until 11.7. So the last byte is the where it stores.
Okay.
Okay?
Okay. Yeah.
Another thing is here. Okay. Actually, I think you can understand this better. Okay, first, why? You can ask me question. Okay, OB 86, the racks for okay. They say array. Array means a set of data.
Right.
Array. They say how much? 0 to 31, right?
Yes.
Okay. And it's a boolean, correct?
Yes.
Okay. So if we put numbers, right?
Yeah.
If we put a number from the top, right? Because the first one is the byte 0, byte 1, byte 2, byte 3, byte 4, byte 5. This one is 6. 6 is which one? The OB86 MDL, the address, okay? Okay? If I put the byte number here, right? Okay, so 0,
0, 1, 2, 3, 4, 5,
this one will be 6,
7,
6, 7. This one will start with the
8.
8.
Yes.
Okay. 8. So inside here is 8, 9, 10, 11, correct?
Yes.
32.
Yes.
But why is LB 11 not 8?
Okay. No idea.
Okay. Why? Because remember any double word, let's say MD, yeah, 10. Inside here, MB10, MB11, and I put 8 lah, easier. 8 means inside here got 4 bytes, correct?
Yes.
Okay, inside MD8 I have 4 bytes. So this is considered an MD8, correct? 32-bit. Now inside here, which is the first byte?
MD8.
No.
Oh, because it's always start from the last.
Yes. That's why the data is from there.
So when we want to call when we want to
know the address, we use this byte number. This is the first byte,
yeah, this is
second byte, third byte, fourth byte.
I think last time you have said if this is this MD is a IP address, the 192 is stored at the MB8 first, the MB11 first, from the last to the beginning. But when we call, also have a call from the last.
Yes. So in this case, I'm not sure if it is using Profinet. Maybe I can use the 4 data. Since it's a Profibus, that's why I'm using 1 data.
But now we say if we want to call this array, we have to call by the name of 11.
Yes,
Let's say if now I'm not calling this
11.
I'm calling this one. Just now we say this is a 6-7, right? So I have to call it by LB6 or LB7?
LW, because I want to use as a word. If this one you want to call, you can call 5.
So just now I use the LB, L is local, B is
It's
actually
the byte.
calling the byte.
Yes, we call
But
it.
if I'm calling a double word, I call LD,
LD.
then I LD8. Then if you show
Yes,
the
correct.
complete byte, the complete 4 byte.
Yes, correct. If you call LD8, you call all the bytes.
The reason I use 11 because you call the byte, not call the
Byte.
whole
Yes, I
array.
just want to call the byte. So because the first byte is the keeping the value.
Right. So there is a function called, there's a thing called L here.
Yeah,
Meaning to say
local. Yes.
local is particularly useful for all this OB because all
OB
this
is
special OB.
particular because OB is there. Even you want to use in your own FB also can.
Also can,
Yes.
as long as this is listed in the
Listed.
variable list, yeah.
Like this, 2 bytes. You want to see. Let's say it's a word. You want to read just the byte value only from the word. Then you can use this method.
And this is in the sequential order, I will count from the beginning.
Yes, but I'm not sure why it's not showing the number
Address,
address because the SIMATIC manager can show the number.
Okay, got this.
Got it?
So this is the way to do this. Okay.
Because I know the right in for can you see the last before the last one. And also you can use the date and time when it started.
Right.
So all this data you can extract from this OB, but you only can move inside the OB only. Because why? You go up, this one this one close?
Sorry.
No, you close this one. Okay. This one right only can use inside this OB, That's why I move to here. So this one I can use anywhere. So whatever data I want to take from here, I just move. Later on I can use.
I know what you're saying. It's just different from our original imagination. It sounds like very inefficient in getting the diagnostic information. Because that's correct also. Because in the beginning, this is a way to extract from which address, let's say which IP address having a problem, right?
Yes.
Yeah, you can't from the beginning, then you they list down 1 to 255,
Yes.
every single thing, this is on, off or whatever. Because I'm thinking, let's say it should be 32, all the time it should be feeding the PLC. I scan one time, 32, all the information is off, on, for, off, on.
Oh, okay,
Yeah,
okay.
but this is not working this way. This is whichever has a problem, then only it give you an address. If there is no problem, I can't get anything here.
Yes.
I just assume this is okay only.
Yes, yes.
Yeah.
But in TI, I think for 1500, 1200 is there's a different function.
So we have a special OB.
There's one function called get diagnostic. Can use that as well. Actually, there's some things here, but need to explore. I've never done before. Go to what? No, OB1. You go to you click on the extended instruction. I'm bringing up yeah. Okay. Go to distributor IO. Yeah. So I think now this one you can use some of the functions here. I need to check which one is to read the data of the particular
Address or something.
address or something. Go down, distribute IO. Go to interrupts. Time. Okay, this one is timing interrupt. Okay, you go up. Close. Go to diagnostic. Okay, go down. Here I put, for 1002, 1005, they have a function called under diagnostic. This one I don't use so much. They call one function called device state. The instruction reads certain status information configured, faulty, disabled, available for all modules within Profinet IO or DB master.
Okay.
There's a block for that. So you can read the data.
For the diagnostic.
Hmm.
Okay, so this is something to do, include into this.
No need. Now I can exclude.
Okay, so can generate anyway lah.
Yes, can
And
generate.
then to save it to memory and
Yes.
transfer to the SCADA.
Hmm.
Okay, okay.
So many. separate the hardware side, okay.
Hardware side, okay, yeah. So
Interface module,
know how to set up the interface module,
Yes.
the fault.
yes.
Yeah, at least young auto can do this. Can have some way to export the
Extract the
alarm,
data,
extract the data.
okay.
Yeah. Yes. Okay.
Because in care portal is more to like hardware. You can get the data from the hardware itself.
Okay.
There's a block for that. They call hardware identifier. You can get the data from the hardware itself.
Okay.
For SIMATIC manager, they don't have particularly like from the hardware you can get the data.
So there is another way to do this.
Yes.
If the information we want is not from the I/O but it's from the hardware itself. How to
Yes.
do this?
Yes.
Okay. Got it. Okay. Yeah.
Okay, got it?
Yes.
Alright. So later after we come back, we set up this motor,
Okay.
the VFD, we check, we see how the VFD works, how to do that VFD.
Okay.
Then we can connect the temperature sensor so we can try.
Okay.
Because VFD just for a while.
Oh, really very fast one.
Okay, maybe we can do this because we want to learn the SCADA also, right?
Yeah.
Okay, so maybe in one process like everything like we connect.
Okay.
We do a simple VFD program, and when we do the VFD program, we do the global DB.
Okay.
We do the global DB. Then we do a SCADA.
Okay.
Then in the SCADA we do a simple one. Then try to put alarm everything. Then later on in the same project itself, we can add the PID, mode pass, everything.
Okay. Okay.
So
When we do the VFD,
Yes.
there is a word I used to hear my colleagues say. Parameterization.
yeah, parameter.
So this is something to do with configuring the VFD. When we,
Yes, configuring the VFD, the
So-
parameter settings.
when we configure the VFD, actually we do parameterization.
Yes, we need to do the parameter settings.
Okay.
I will show you that one also, because in this one I will be using the software to do the parameter settings.
Okay.
So I won't do like manually one by one.
Like go to the interface
Yes.
or push a button.
Yes, because I will go to the, I use TI portal. When you use TI portal, if you select how you want to use this motor, it automatically set all the parameters.
Okay.
For that, I'm not going to use the software. So I show you manually how to do the parameter settings. If you want to control analog, what you need to choose. If you want to control direct, what you need to choose. If you want to control the communication, what you need to choose.
Okay. What brand is that?
I don't know, PSC something. Universal Inverter.
Oh, it's not a famous brand, but it's something to.
Yeah.
But this is so PLC. Okay. So if
This is the manual.
Oh, there's a
This
manual.
is the manual. This is the parameters.
Okay.
This is some of the parameters I use, so I show you.
If this one has to connect to the PLC, it has to go through a Modbus.
Three-way.
Three-way.
Oh, if this one,
Yeah.
if I want to connect to that, must use Modbus.
Okay.
Modbus RTU.
RTU.
Because don't have
Is-
TCP.
we call it RTU because there's another serial
485. Using 485.
485.
Yes.
If you use Modbus RTU,
Mm-hmm.
then this is not using the IP address anymore.
No. Similar concept like Profibus. They will have a Modbus ID.
Oh.
One number only. Like this one just a 4 5 one number, right? So Modbus means only one number.
If I use Modbus Ethernet,
And
then
then it's the IP address.
inside I can set IP address.
Yes, correct.
Oh, that's a different. I still trying to get some understanding because a little bit confusing is this.
Sure.
Modbus, you can have a Modbus Ethernet.
Mm.
No, you call it Modbus TCP
TCP.
or Modbus
RTU.
RTU.
Yes.
Profinet usually is a Profinet TCP.
Yes.
But There is no such thing as a profit net, something else. I don't know.
No, okay, I know where you go.
Yeah.
You see, Modbus RTU is like Profibus. It's using serial cables.
Right.
Modbus TCP is like Profinet using Ethernet cable.
Okay. Modbus TCP. When we say the TCP, the word TCP, what's the meaning is? TCP is how to do the addressing on it. This device is 192, and then you have subnet, this kind of thing. It's called TCP.
Yes.
The meaning of Modbus is the Modbus itself is a language.
Yes.
How do you send the signal in?
Yes,
over
how
the
you want
backbone?
to send the signal, and they have their own addressing format.
Modbus.
Modbus, yes.
But the addressing format is depending on
Not the addressing for the what? The IP address, not that addressing.
the variable.
Yes,
the
the
variable.
variable addressing.
Yeah.
Like Siemens, they have the addressing. Input is I, output is Q. Input, input boolean is I 0.0. Output boolean Q 0.0.
Right.
Input analog is IW. Output analog QW. Right?
That is a
Siemens.
Siemens language, and the Profinet is using this kind of language.
Yes, Profinet, Profibus, they use this kind of language because they already Siemens product.
Okay.
If you're using Modbus have their own addressing format.
Right.
So like they have like 0 to 10,000 is digital input, something like that. Later I will show you on Microsoft. Then 0 to 2,000 is a digital output. Yes, not 0, sorry. 0 to 10,000 is a digital input. 10,001 until 20,000 is a digital output. 20,000 until 30,000 is like an analog input. 30,000 something, 40,000 to the analog, something like that.
The serial. But yesterday I tried to look from internet on the Modbus. There is also cable. It can be one end is a RS, one end is a Ethernet also.
Yeah, can. Actually, no. You see that one, that inverter. You see it's a, like Ethernet port, right?
Yeah, here is Ethernet port.
Yes, right.
Yes.
But it's not Ethernet. It's a serial.
So when I call it TCP or I call it RTU, it doesn't matter with the physical
What is the
connector.
connector? Yes.
Doesn't matter.
No.
Oh, what is matter is how you do the configuration and addressing
Yes,
inside.
yes. Because very simple. TCP always done. They're using the RJ45. Okay. RTU normally they use just 2 IO. Okay. Sometimes they use that RJ45 connector.
RJ45.
But they're not using all the 8 cables. Just using some 2 cables only.
So I assume this is when somebody buy the BFT lah.
Yes.
You want, let's say this is a modification project lah. Somebody want to buy this to integrate to his own Siemens system or whatever.
Yeah.
He really has to know this one support TCP or not TCP.
Yes.
And if it support TCP, then I can do the configuration like this. If it's not support, then I'm connecting through whatever port is this, because this one doesn't matter here.
Yes.
I can simply change. Just that after I connected, then the configuration,
Yes.
I have to name the RTU has the RTU way of doing configuration.
Yes. Just the module. Okay, wait. I'll show you one.
RTU is something comparable to TCP in terms of naming the device.
Yes.
Just now we said one PLC support
Yes, okay, I show you here. So for that project, for the UTM project, they have a mass flow meter. Okay? Yes, so they want to read all the data from the mass flow meter. Okay? So it's using RS485 combination. So it means it's a RTU lah. Okay? And they're using is the RJ45.
Okay.
But the protocol is 485 RTU.
When you say protocol 485, meaning that this is the RTU.
Yes,
Protocol.
protocol is just how we communicate.
485 equivalent to RTU.
Yes, yes, yes.
Okay.
Mm.
So people say RS 485, meaning to say this is a RTU protocol.
Yes, in
Which
bus.
when we pull the cable,
Yes.
it's not green. Oh, it cannot detect at all.
Cannot be, yes,
Cannot
correct.
detect at all.
In the program, you will have a block. One is for Modbus RTU, one is for Modbus TCP. So you need to select the correct Modbus block.
Okay, we have to define this as TCP or RTU
Yes.
first. RTU, this is a new word for me.
Yeah.
The only time I've seen it before.
Remote terminal unit.
Yeah, it's named remote terminal unit, but it means a control panel actually. But it's not mean a control panel.
No, no.
Oh.
It's a remote terminal, a unit. I mean, the name supposed to be like remote instrument.
Okay.
Remote instrument, yes.
Okay, so but this is a TCP lah, networking term lah, how to do the
Yes.
addressing lah. Okay. And this is separate to the Modbus itself. Modbus is the language. This is like a postal address.
Yes.
Okay, got it.
Yeah. For
Okay.
that project also now, because my controller is RTU.
Okay.
My PLC is, I'm using the 1002.
Okay.
It's just only Ethernet only.
Yes.
TCP.
Yes.
So what I need to do, I need to buy one communication module for RS485.
Oh, because but just now you say the hardware doesn't matter, ma.
No, must be same one.
Just now you said this is RTU.
Yeah, the protocol they're using RTU, but my PLC currently is TCP.
I mean, it's not something that from the TIA portal you can simply change it. You
Cannot.
need a hardware to do this.
Yes, of course. Because
RTU always needs a hardware to do.
yes,
Oh, so today, if this one, just now you said this is a TCP, right?
no, this is RTU.
This is RTU. Oh, this.
485 RS.
Okay. This is. Okay, where is the port first?
These two terminal. These two wire.
Two wire, okay. Not even using the.
No. Mostly like this. Some will be the RJ45.
Oh, it's not using the pins. I don't know how many pins.
The 9 pin.
9 pin. No, never use a 9 pin one.
Some terminal they use 9 pin. Some they just use 2 wire.
Two wire also can be RS. Okay, but most important is, so this one, it use a postal address of RS485, meaning 1, 2, 3, 4, 5.
Yes.
I cannot just wire this one, and then the other end is Ethernet, I assume. Ethernet go to the router, and then I just assume that my PLC will read it. Cannot.
Because why? Why cannot? Because in my PLC is a TCP protocol.
Always. You use 1005, 1002, always.
Yes. Ethernet means of course because that particular name is what? It's a Profinet port, right? It's an Ethernet port.
So the high level answer is Siemens never support RTU.
Directly don't have. You
Direct.
must use one additional module for that.
Which means it's additional card,
Additional card.
IO card.
Communication card.
Oh,
They
it's
call
not
communication.
even an IM card or IO card, it's another type
No,
of card.
it's what they call communication card.
Oh.
So either you add here or add here.
Oh, let's say this one, then probably you add next to it.
Yes.
No need the interface module to.
No need. There's two ways. This one, okay, that is one. Another way is you receive 485, right? You use a converter, convert to TCP.
What do you call? Is it the
It's
name
a
is called
converter. It's a converter. RTU to TCP converter.
Question, because there are something similar concept. I don't know whether it makes sense or not. It's called a gateway, but this is nothing to do with the gateway. No, it's not a gateway. Because I imagine now it's one. Let's say I just assume. Okay, let's say you have one PLC, but you have a lot of RTU devices. Then what are you going to do?
I have two options. One is I buy one RTU
communication module.
But yeah, but your communication module have limited port also, right?
No, like this lah. Look. Can be look.
You need a lot of communication module.
Not communication module, like I said. Okay. You see in this Profibus, right? You just imagine this is RTU. Same concept like this only. This one also 2 wire inside. So how it works? Then from here it jump. That's why you can jump to next one, next
So
one, next
you mean
one.
treating it as an IO card lah? Because you use, let's say I randomly say I say there is a,
Let's say if we have 5.
I say more drastic lah. I have 20 RTU.
Okay.
I have 20 RTU.
Can no problem. What you do? You have 2 options. One is
I add multiple communication card.
no need. This one is the S7-1200.
Okay.
I can add one RS485. Okay? Terminal lah. So this one will have a 2 wire. Okay?
So this is accepting 2 wire. So what bus is always 2 wire?
Modbus RTU is 2 wire. Okay? But RTU.
RTU is 2 wire.
Yes. Then from here to here is connect the 2 wire and the 2 wire will connect here.
Okay. This is the device itself, not the communication card.
It's just the segment the device, your VFD.
Okay, so you mean just look like this is sufficient?
Yes.
You do not need a multiple.
No need. Multiple
communication.
communication cable no need.
Oh, so.
This one is the RTU. TCP.
This is how to do it. I need one communication module.
Yes, additional communication. This one
And
is
then
already.
everything.
Here you have the TCP, right? And so 192.168.01 for example lah. Then this one is the 02, 03, 04. Let's say 05 for example lah.
Okay.
I mean the router lah, correct?
Okay, so this is how to configure.
Yes.
This is a TCP. That is a way to do the RTU.
Yes.
RTU is just
Then each so
Two
with
wire, two
alpha
wire.
ID. This one also with alpha like the Modbus, right? The Profibus number 245. Same. This one with alpha Modbus ID. What is the ID?
so I will do some programming to name the ID.
Yes.
Got the concept. Okay, yeah. So this is how to
How we
do it. RTU and TCP.
TCP. It's the same thing like we do Profibus, Profinet. When we do Profibus, just know what we do. We do Profibus, but we all take this start, take that. Then we set the Profibus address.
Right.
When we do Profinet just now, we take and we set the IP address.
Got it.
Same thing, here also same concept, but it's not inside the configuration.
Okay. So go back to say this again. This is very straightforward because usually TCP always Ethernet
Yes.
connector done already. RTU most common is 2 wire.
Yeah.
Sometimes they use the serial
The
port.
serial port or the RJ45 port.
RJ is an Ethernet port lah.
Right.
Oh, okay. O also possible.
Yes. But we need to know what type of, I don't care what port you're using. I need to know what protocol you're using.
Okay.
Is it a 485 or is it a TCP protocol you're using?
Okay. Get it. Yeah.
Another
Okay.
one, just to make you confused, okay. Another one, let's say this is 485. Okay, I have one VFD. Okay, what I do, but mine is a TCP one. I have 2 options. One is, okay, I don't connect from here, I just put one RS485, for this are separately connected. Or I just use a converter. This converter is a convert 485 to TCP. Then I can connect it. So the IP address you will send here.
Yeah, or how to set this one.
This one in the converter they will have their manual, so they will tell you what is the fixed IP address and everything. If you want to change IP address, sure they have some function to change the IP address.
Siemens sell this kind of stuff.
I'm not sure. Siemens don't have. Siemens have so many other brands.
So many. But the setting of this configuration is done internally here.
Internally, then and everything they will have a manual for this.
Oh.
Because if you convert to this, what is the IP address and everything? Because in 2 or 3 weeks back, I have one participant. He bring his own converter because he want to come and learn TCP, Modbus TCP. So his device is using temperature controller. His temperature controller is a 485. I don't have the 485. So he bring the TCP converter. Then we try to connect.
The concept is really this one, right? I get the concept first. TCP or RTU is really like a postal address. It's like telling how to read the address. It's read this is a postal code, this is a Johor, this is something. This is the format of reading the address. If I say that I read the format in this way, then you give me a tv@gmail.com. I cannot get that communication address because I don't know how to read. I only read this kind of address, Johor, whatever. And Modbus or Profinet is the language written inside the mail.
Okay.
Yeah.
Get it.
So I can have something written in Tamil. Either I want to use an email address or I use a physical postal address.
Yes.
Also can.
Yes, can.
So this one is like I using Modbus. I say the Modbus is a Tamil. So my language is written in Tamil. But I want to convert it from the postal address convert to the email address.
Yes.
So this is defining this in the end this mail, this information I want to send it to where.
Yeah, correct.
So this is the concept here,
That's
right?
the concept lah. That's the concept.
Okay.
Okay. Or there's another way to find out. You can say. Okay, how you want to travel, for example, from one place to one place. Let's say from KL to Johor, you want to travel. Actually, you have 2 options to travel. One is using highway, one is using the road.
Okay.
Highway is faster, road is slow.
Okay.
Okay. Then highway is like you something like you need to, example, pay. We don't do that. Okay. So the main thing one is faster, one is slow.
Okay.
So means this is faster, this is slow.
TCP always faster.
Yeah, of course. This one is slow.
You mean in terms of the scanning time lah?
In the system of transfer data.
Or you mean the rate is higher, the kilobyte per second is higher?
Yes, kilobyte per second.
Okay.
So we go to MB, this one KB. Okay? That is number 1. Then number 2 is because how so same goes for your Profibus, Modbus, everything. Okay? Same thing. Then now which which protocol you want to use? Okay? Which protocol? So you want to use Modbus or Profibus? That means which mode of transportation you want to use? You want to bring car or bus? Something like that. So if you bring car, this is very easy, convenient. So like Profibus, Profinet. So you alone wherever you want to stop, you can stop and go. If bus means you follow the protocol. So let's say set like the Modbus is like a bus means the bus they have their own rules. They only can stop here. They only can stop here. This is the time they take. This is how they travel. Something like that. So you need to follow their protocol if you're traveling a bus. That is like a Modbus. Let's say if it is a Profibus means you bringing your own. So everything is your vehicle. So everything is there. You just need to know how to drive.
Okay.
Something like that. Yes.
Yeah.
Because they have their set of rules. set of addressing, you need to follow that.
Okay.
Yeah, term and condition.
This is a languaging.
Yes,
This is
language.
how to handle the variable inside. Very fun. But in a, how to say, in a modern project, all is a TCP plus Profinet lah.
Yes.
No, cannot say Profinet because Profinet is a
For Siemens.
is a for Siemens.
Yes.
Actually, Omron everything else they don't use Profinet.
No.
They use what?
Yeah, their own.
Oh, their own.
Different
Different name again.
Different name. Omron they use fins.
Okay.
Fins also they have is a internet like similar like Profibus.
But he will not
That's why-
communicate to Siemens.
No.
Oh.
Omron to Omron product. Fins is like a Profinet.
And Alan Bradley is a
Alan Bradley is what? Their own protocol. Philippines or something like that.
so
Mitsubishi they call CC.
okay. So typically a device would not be natively just go to say, oh, I support Ethernet. No, sorry, I support Profinet
Yeah.
because Profinet is a Siemens thing.
Yes, Siemens.
But some of the manufacturers, they will just say that, oh, my device can support the Profinet language, or you can download the GRD file,
Yes.
and then just means that to make him to learn a new language.
Yes.
Got it. Yeah. So Profinet is really a Siemens thing.
Yes.
Modbus is a universal thing.
Universal. Yes.
And you can choose the addressing by, the networking address by
Yes.
using
Networking.
a TCP or using an RTU.
Yes. Correct.
Two method on it.
Two method.
Okay.
Because PLC communicating two method only. One is serial, one is Ethernet.
Okay.
So just need to know which one is available, then what protocol is can support, and then use that protocol.
Okay. This is really, yeah.
You get the idea, right?
Get the idea, yes,
So
yes.
whenever later when you do something, when you do project or something, then you know where to get the data, something.
Right.
Then you can decide also which one you want to use.
But really, almost never come across any RTU. RTU. I never come across any device
That is using RTU.
that's using RTU. Yeah.
Yeah, because RTU very old. I think 10 years back.
10 years back, people use RTU. Now, the modern,
I think
everyone
10
just
years,
uses TCP.
Yeah, I think more than 10 years back also. Because TCP is, you see, that PLC, right? The S7-1200. Right, S7-1200, you see, I think it's around 2000 model. 2000 model.
Okay.
20 years already. You see, and that model itself are already at the Ethernet port. Already support Profinet.
So this Profinet is a new technology.
Yeah, so
right?
already support Profinet. It means the Modbus TCP is already there. So it's like, so the RTU is like 20 years back.
But I don't know. Because not to say how to say, from the control and automation discipline, TCP IP is something that is a networking,
networking.
technology, right?
Yes,
It's like
networking.
computer, everything also using a TCP.
Yes.
But I don't know the RTU. I really don't know what is the background of the RTU. Anyway, okay, good enough. Yeah. Okay, so later I come back 2 o'clock.
Yeah, sure.
Okay.
Yes. Good.
Okay, all good.
Okay. This is what we plan to do. Configure this one.
Yes.
Yes. Yeah.
This one done already.
Yeah.
Okay. This is a single phase.
Yeah. Normally we don't see the drive. Normally drive will be three phase only. Three phase, but the voltage lah, some will be 220, some will be 230 volt. Depend on the drive. Only we see whether it's a single phase or three phase.
So this driver is particularly only for single drive or is actually both also can use?
I mean single phase or three phase.
Yeah, for the
No, this drive is single phase. You can see here.
the drive itself is a single phase.
Yes.
Okay, okay.
So some drive is three phase, some drive. So this one, that drive it's also Siemens drive. This one. This one is a three phase. To power up, this one I need three phase.
Oh.
So that's why I put it there itself, because I take all the three phase cable from here. Just extend until here, put it here, direct from the supply. Because normally in this
confused. Household.
household, normally single phase.
Okay.
Some double stories they will put three phase.
Oh.
But the plugs we all use single phase. Why? Because single phase only one life. The main life coming,
Right.
that one you use two for all everything.
Right.
If three phase means they will have three lives.
Right. Okay.
So what happen? They take one life for, let's say this aircon. Let's say double story lah, for example. So on the ground floor using one phase.
Oh. Okay.
The first floor using one phase.
Okay.
Another one is for some like aircon or that. So they make
Just to
try
distribute the load
maintain.
evenly.
Yes.
Oh, so your office are here.
Yeah,
You
so
also have
three phase.
three incoming.
Three incoming.
Oh.
So three incoming. So each aircon will be used one phase. Because if I put all in one, then others will just plug only. So this one current will be high. Others will be, the other phase will be low. So where do I put the current, your charges will be high.
Okay.
So you must maintain all these three. All the three phases I must maintain.
But you say you are mechanical, but you also.
I learned all that over the years.
So you mean you really can
No, I can
you
change
really
that.
can from there.
Yeah, can. I even once I changed the whole set for my friend house. Suddenly burn during COVID time.
You change the whole set from a friend house.
Yes.
Wow.
So what happened is the whole one lah. So what happened, suddenly got fire in the this one in the DB. So he was in Singapore. His sister was staying there in JB. So they called me. So what happened in front of the house, the main coming in there.
Yeah.
Main go to your meter. From the meter only then only we go inside the house.
You can switch off from the meter.
There's one in the meter. There's a fuse light you can take out.
Wow. How do you do that?
Yeah, normally we in the house we have what?
I know we have a meter, but how you know that there is a switch and there is a fuse you can take it out?
Yeah, I can look at my house. I seen that before, but I never done. I seen that before. So whatever, I take out that. So after that, no incoming to the house. So I take out all the old MCBs according to the same rating, same ampere rating. I go buy a new one and new box I put. I fix it. That's a rental house actually. I fixed. Then after that, he go out already. The other guy come and use the house. Then my friend again he ran back the house. It was still the same the DB I fixed.
I imagine doing that is like the concept is simple,
Yeah.
but know how to do it right is not everyone can do.
Because the same concept I'm using in the panel. The panel also same. One power source is coming in.
But there's always single phase.
Yeah, of course. But one power is coming in. Then you need to distribute to all the all the power supplies, all that. So the same concept.
Okay.
Okay.
Okay. So this is
Okay, this one you connect to the drive. This one has two electrics.
Yes.
Yeah, that's the
There's 3 actually.
Profinite one. This one is to connect set up this one. Because this one you have
computer.
this one DEF their own software.
okay.
All start drive.
But the TIA portal can do this, right?
TIA portal can do, but TIA portal means you choose what type of application you want to use. You can use that. Let's say this one I want to use for other brand, other PLC.
Okay. Yeah.
So what happened? I need to open the manual parameter settings.
Okay.
The where you one by one need to set.
When you say set question,
Yes.
say this is Siemens, not say Siemens doesn't like that lah. Say a good one lah, not a simple VFD, a good one lah. You always need to connect a laptop set, or you just play with the display
That's
and
okay.
finish.
That also can. Laptop also can.
Oh, both also can.
Both also can.
Not necessary that you must know the software. You must call the vendor into.
Yeah, not necessary.
Not necessary.
Not necessary. You can set that is all. That's okay. Set. Okay, escape, monitor, extra, parameter. Okay, standard parameter or expert. Okay, standard. Parameter 2 is 42.
Oh, you really just look at this, you can understand. You must have the manual.
Yeah, of course, must have the manual. So 9872, what is the meaning? To P3, P10, P15. So each one they have their own meaning, everything. Okay, so you can manually set. And also, yeah, sorry, sure. Okay. So this one we call BOP, Basic Operating Panel.
Oh, okay.
Can take up. Press here, take up.
Hey.
BOP. Without this also this one can run. Because here what happened is this BOP.
Okay.
So there's a two. One is BOP, then is another one is an AOP, Advanced Operating Panel.
Okay.
So BOP here can set the parameters, can monitor the value, everything like when it's running, what is the speed, everything. Manually you want to run the speed, everything can set here.
Alright.
Okay, for any fault can see here.
Okay.
Okay, advanced operating also same thing, but what you can do, you can extract this file, go into here.
Okay.
Back up to here, take out, put to another drive, from here I can restore. So if let's say you have 10 parameters, 10 VFDs, you only buy one enough. So you set only for one. The others all are just copy paste, just change the address or settings only.
Okay.
Got it?
Got it.
Okay, and this one. Then for this model, you can take out this. Okay. This is the power module. Okay, this is the power module. The power module is the one controlling, send the powers to here lah.
Yeah, so I just ask this question because I keep on looking at it. This one has two earth. This one is a green, one is this green and green.
No. Actually, this one is supposed to be, you must use the UVW. I just use normal cable.
Oh, okay. So this is not
not actual colors lah.
not the actual.
Yeah, here if you see this one also, I think because
But still strange. One because this is a single phase, right? How is it supposed to work? One line, one neutral.
no. It's this is still three phase. Go to here is still three phase.
This motor itself is still three phase.
Motor always three phase.
Okay.
It just depends what type of voltage controlling here.
Okay.
So two type of voltage you can see here.
Okay, so this is still a normal UVW.
You can
And
see
inside
yes,
still a star delta.
normal yes star delta. So you can see here you can control delta 220 also can, delta until star 400 also can voltage. Okay. So if this one is a single phase, means it just send you the 220, but it's a 3 cable.
So you mean the down. This one power up by a single phase or three phase doesn't matter.
It doesn't matter.
Or the output is always a three phase to the bottom.
Yes, always 3 phase. Only the voltage will be different according to
The setting.
setting. What is can supply.
Then I have a question first. If today if today this is a three phase, then I should have what I should have? I should have four cable, four power cable because
To power up this is it?
to power up this
Yes,
one.
of course.
Yeah, one L2, L3 plus
You
a
can see here.
neutral, right?
Yes.
And then the grounding is another one. Do not have to no need to connect to here.
Yeah. Can I take out this one?
But this one, how come you got? Yeah, I don't know how you
Yeah,
can take
okay.
out. How
So
come you can?
if it is single phase, just L1 L2 come. If it is 3 phase, L1 L2 L3.
But this ground is what ground? Oh, because the ground is this is a neutral lah.
Ethernet. Sorry, Ethernet. Earth.
Earth.
Yeah.
This is right. Then this is neutral. This is a light.
For this lah. For this one is this live. This is neutral.
But this is light. This is neutral.
Yes.
How come blue is not light?
In this color, brown is 230 live. Blue is neutral. This one is the commonly we buy in Malaysia. Any what?
Malaysia.
Appliance, any home appliance you buy normally. this
Malaysia brown is.
color. Yes, brown, blue, green.
Okay.
Ah.
Okay.
Okay, if 3 wire, the 3 phase, then it will be red, yellow, blue, RYB.
Okay. Three phase and it's okay. Red, yellow, blue.
Yes. Okay.
Okay.
Why we call this one inverter is because inverter means take AC voltage, convert into DC voltage, then convert back to the AC voltage. That's what they call inverter.
Okay.
Because you supply 240 or 415. Okay, 230 single phase, 415 three phase. Okay, and inside it will convert into DC. That's why we can connect our digital input, digital outputs to control the motor. Okay, then after we control that, then it convert back to the AC three phase. Go to the motor.
If you convert to AC three phase.
Three phase.
Yeah.
But the voltage is depend whether it's a 220 or 400. It's depend on this one. If this one is this power is a single phase, normally 220. But if this one is a three phase, I go to the 380 or 415.
Or it depends on what phase you use.
Yes, the voltage. So that one is no problem actually. Not an
Okay.
issue.
Okay.
Then the size of the motor, the drive is depend on the motor.
Okay.
Let's say this motor is how many kilowatt? You can see 0.85, 0.18 kilowatt. You can see
So small.
KW. So this motor, where is it? Because I buy this. Because I last time I have one intern guy. I asked him to fix this one to the board, but I forget to mention about this. The sticker at this side. So you can see 0.55 kilowatt the motor. It means the maximum motor I can use is 0.55 kilowatt only.
Okay.
If above that, still motor can run, but it won't run up to its what?
Full
Full capacity. If it is motor is overloaded, this one will go. So overloaded means what? When it's freely running, nothing attached. So the current is coming. So let's say it's a 2. So it means how they calculate the kilowatt, right? You send 220 volt, okay? Then it will draw some current to match the
You mean you have a
amp lah.
your current peak
Current peak lah, maximum, okay? So 220, then the current, that's how they calculate, they will get the watt, how many watt, okay? Now, when the motor running, suddenly you hold the rotation. What happened? So it will work extra. When work extra, it will draw more current. When draw more current, what happened? It will draw more power. Then this one will.
So when it able to run to a full load, you can burn this one.
Yes.
Okay.
But if it is, if the kilowatt is not, if the power is not matched, so always motor below the power lah. It's a
Okay.
good one. Okay.
Okay.
Then this one.
Normally, delta will start. Depend. People.
Depend. Normally we use delta lah. Depend on that one. If high torque is needed, then you need to connect. Start with the need to, because let's say this is the motor and the big drum is connected. So big drum is the weight is there, so means you need a high torque to rotate it. So what happen? They will connect with the star first, rotate. Once it come to a certain speed, then change to delta.
Depend on the initial needs, the high torque.
Yes. So for that, what they do normally, because this one is delta directly connected. So normally what they do, here they will put 2 contactor. One is they use the star connection, one is the delta connection. So your PLC will
Timer.
activate the star first. Now we use the timer, then only they activate the delta.
But we have a VFD, we don't need already, right?
Yeah, we don't need really, so we use delta
We
connection.
just so normally VFD just use a delta.
Delta connection. If let's say if sometimes some motor they use only for torque only.
If there is a
Torque
application.
Yes, this torque is needed, then we use that.
Okay. Unless only for we really needs a high torque.
Yes.
Otherwise, normal water pump whatever.
Yeah.
Just use a delta finish. Okay. Good. Okay.
Okay. But you must you must go and research on that lah. Research on that, because I'm not very, I cannot say I'm an expert on this lah. Yeah, I just give you
Just
whatever I know lah.
Yeah.
Whatever I know.
Okay.
So normally Siemens sometimes it will be like this. One is the power module, one is the control module.
They are not interchangeable. Like
Can change.
I mean, this model can be have many different.
Yes.
Can do also.
Yeah.
Oh.
That is the reason they have that type. Okay. So I have another one, another control module.
So if you unplug this control module, then this one not functioning. Okay.
Yeah, of course it won't work. So I have another one. This one is using Profibus. That one is using Profinet.
Okay.
If I want to connect to, you can see here part number. You see, CU see use the control unit lah, 250S2DP. If you see the one is a PN part number. Okay,
Got it.
good. Okay, and another thing is they have this one only this few types lah. They have different model. Later you can see the software. This one they have different size. Now it's just 0.55 kilowatt. If I say the motor is 5 kilowatt, 20 kilowatts, then it's bigger. But the controller unit only this one.
Huh?
Yes.
A controller is one
Yes,
size
the
only.
control, yes.
So your power module can, but this is not power module.
It's a power module.
A power module,
It's a
it
power
can be big or small depending on the motor size.
Yeah, motor
But
size.
you attach a controller, always one size.
Yes.
Okay, got it.
Sometimes that's why sometimes you see the panel, the module very big, but the controller is just this thing.
And this is called the
BOP.
BOP,
Yes.
basic operating panel.
Yes.
Okay.
There's another one called AOP.
Advanced operating
Yes.
panel. Okay,
This
got
one
it.
also BOP, but it's attached together.
Okay,
Okay. So what's the difference between two? Actually both are same. This one also, but this one more bigger, 0.75 kilowatt.
okay.
But the only difference is this one is Siemens, this one PLC. There's a difference.
Okay,
Another difference is this one Siemens or Profinet.
okay,
So easily communicate. This one don't have Profinet, so you have to use Modbus to communicate.
okay,
Or you can use just the analog communicate.
okay.
Now before that I will go this one first. How? Because on that on this one we don't know, we will be using the software to do the parameter. So we won't be doing one by one the parameter. Okay?
So we don't have to use a BOP. We just use
I use the software to do that. Okay. For this, I don't have the software. If you have the software, you can use this.
Okay.
It's RJ11. You know the phone line. Phone one. That one. Only 4 pin I think. So this one, they yeah, it's they have a software, but they use RS232 combination.
Okay, got it.
Now, you see, this one is also same. We have different models. You see, single phase, three phase 220, single phase 220, three phase 380 also got. Okay, that's depend on model number lah. Okay, then so we can go to the program F lah, right? F0, so F00, okay, first one. Okay. The first one is what? Sensorless speed control move. Okay, so I don't care, I just use the 0. Okay, so they said sensorless is widely used for application which define high torque and low speed, higher speed accuracy, quicker dynamic response. If you use VF control, suitable for general purpose such as pump and fan. So if you want to use that, you can choose one. Want to use torque control is suitable for low accuracy torque control, ECCD something. Okay. So it depends on which type of control you want to use. What type of application you use. Okay. But most important one is the
Says in the market has so many different method of the PLC.
yes,
This list of parameter is this considered a standard or
similar.
similar? Even though everyone has a different brand, model,
Yeah.
naming, but what they are setting is
Setting,
similar.
they also have like this, but they of course are different names, they call by different names. But same concept.
Concept. Only the concept is the same.
Yes, concept is same. The name all different. But still, this one can do normal control, torque control, low torque, high torque control. All that also can do that. Here.
Okay.
Whatever you're doing here, he also can do.
Okay.
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 Then the most important part is run command. Okay. Run command means turn on and turn off. Rotate the motor. So you want to use one. Want to use keypad, you must choose 0 or F01. Means I just on and off here. So normally, initially, when you buy new one, always on the keypad. So normally what they do when they do this commissioning, Okay, they will set all the motor settings, everything. Then they will check first motor running, rotation, everything. Then only you can change to terminal or communication. Terminal means your digital output connect here to rotate. Or communication means I use 485.
Got it.
On this case lah, 485.
Got it.
Okay. Then
So you were saying that the start of the motor triggered by what? Either is triggered by somebody go to the panel to
yes,
pay it,
yes,
or you have to use a DIDO,
yes,
or you have to use the
communication.
communication.
Yes.
How I say of course, and DIDO says the DIDO most likely possibility is this one is close to the push button. Let's say somebody opt to use a DIDO lah.
Not necessarily push button. My PLC output.
PLC output. How I
It's
say?
a normal output.
Yeah.
Just connect here.
I mean definitely that is possible, but just thinking let's say this is a VFD. Yeah, nobody needs a local green and red button for the VFD, right?
Yeah, of course.
Always people just come here to play this start or stop because here you already have a start or stop
Yes,
button
okay,
here already.
okay.
You do not need an additional
Additional button, yes.
button.
Yes.
Okay, just want to know like
But-
typically
Yeah, but this one, if you want to run this one, you must make sure it is choose keypad.
local. Okay,
I
keypad.
mean the
Okay,
local lah.
okay, okay.
Local lah, you
Yeah.
said, okay, keypad.
Okay,
If you want the DIDO, must be terminal.
okay,
If communication is communication.
okay,
Okay.
okay, get it.
Then this one, the up down setting is just to increase. You want to, let's say that the frequency is controlled by here. So you want to increase using this or using this lah. Okay.
Okay, this is especially for this one lah.
Okay, it's also same lah. So but they don't have potential meter. So there's, I think for this won't be have the setting on this.
Okay,
Okay.
okay.
Okay. Now, another important thing is the frequency. Means who set the speed. Keypad means are using this. Okay. AI means using analog. Means the terminal there. Okay.
Okay.
Then because this one got only one AI lah. Some module have two AI.
So
So
you have to choose either one.
yes, either one or both. If you choose both, it means we'll have like two speed values. So initially low speed, then high speed, something like that. You want to do also can. Okay, or multi-step speed also you can use. Means if multi-step speed it means you need to set all the how many steps you have, all the speed you must choose. So initially, let's say you want to do the four step speed it means so you cannot control the speed. The speed is already set here. Okay, you cannot control using this or communication. Then for the multi-step, they have this at the back. They will have the first speed setting, the second speed setting, something like that. They will have. Yeah. Is it multi-step speed 0, 1, 2, 3, 4. The last one 4. Oh, until 7 you have. So 8 speed setting you have. So you follow this only. So initially you run this speed. Then after that, next go to next speed. Up and down, up and down. You can do like this lah.
You mean the speed setting is follow this step speed,
Multi-step speed settings. So the speed settings you need to do in here.
which is in the parameter.
In the parameter FA parameter. Means
So let's say if this function also in the Siemens also, But what is the use and what is the
Usage.
ah,
It means, let's say you are not using analog. Let's say I have one PLC. I don't have analog input. So the analog output to control the speed. Okay, but my application is okay. When I start, I run at 10 hertz first, and after a while, I run at 20 hertz. Then after that, I want to run at when I hit this sensor, I want to run at 10 hertz. Under that, up and down, up and down.
So this can come from a PID or
Okay. First, if you have an analog, then you can use the analog output, do the program. For first 10 seconds, you send this value. Because you know analog output, how it works, right? 27,000 per unit. Okay. And after 10 seconds, this value. When it's sensor, this value. The motor follow what is your analog input. Okay, let's say my laptop, my PLC don't have analog inputs. But I want to do this. Up, down, the speed settings. Okay, so I can set the speed here. Then, yeah, so you can see here. So they have this S1, 1, 2, 3, 4. Right. So it's here.
So I have a S1 to S4 digital input.
Digital input, so I think only but using 3 only here. So if S1 on, okay, S2 off, S3 off, means
then
to run on the second speed.
Then I have a 8 combination here.
Yes. So just need to play with 3 output.
So if I get correctly,
Yes.
So there is 2 type of communication, not
Control the speed.
yeah, either is you use AI, either is you use AI or you use DI,
Yes.
right?
Can also.
So it's either is a local control or
Analog.
AI
Yes.
or DI,
DI.
or direct user
Communication.
communication.
Yes.
So there are 4 possibilities here.
Yes.
Okay, got it.
Good.
Yeah.
Okay. Even you can use PID to control. So if you choose PID settings, then I have to do the settings for that. So actually got how many?
This is part of the communication.
Yes. So keypad, analog input 1 or analog input 2.
Oh, okay.
Or you combine AI 1 and 2, or you put multi-speed. Multi-speed is using
Yeah.
this one. Then using communication or using PID.
The PIT also is a AI. Right?
Must use the AI, but the PID settings you must put it here. The gain, the coefficient settings you must put it here. There's the settings for that. PID settings.
I don't want to.
Go deep into that.
No. I want to go deep. I don't want to misunderstand because
Okay.
I happen to be at one time.
Mm.
There is this kind of problem during the commissioning. We have a set of pump skid, 2 pump. Somehow this one we come with a controller.
Okay.
So initially we thought it's a VFD. So no matter full buy or whatever lah, then we connect, set everything, or say, and then the contractor say, oh done already, you run it. Then we cannot run. We trigger from the remote and then we can read a lot of problem.
Yes.
In the very end, turned out to be the problem is we thought the AI, we thought the AO go inside to the
VFD.
to the VFD, the controller. It's a speed setting.
Mm.
It's a set point,
Yeah.
but it turned out to be wrong.
Oh.
That is not the set point for the speed.
Okay.
That is a direct pressure set point.
Oh. Okay.
So they have an internal control loop, and then somehow they taken out the pressure transmitter. Like the pressure transmitter is supposed to give in a pressure feedback to the controller,
Okay.
and then you give a set point of pressure, then he will regulate the pressure by itself.
Oh. Okay.
That's the correct way to do this, but somehow we taken out
Direct.
the communication,
Mhm.
and then we thought that this is a set point speed, and the contractor also thought this is a set point speed. Turned out everyone is wrong, and they take time to troubleshoot. I'm just wondering, this PID, it's not that meaning, right? It's not to say it has an internal PID or something,
Yes.
but the set point we give it is a speed set point.
Yes.
It's a speed set point.
This is set point.
Okay, so let's say it's a
It's
0.
still 0 to 10 volt or 4 to 20 milliamp only.
And it means that it means from the 0 speed to the maximum frequency.
Yes.
Like 0 to 50 hertz probably.
Yes, correct.
But somehow it's different to the AI. It's called
It's a normal AI. Okay, let's say normal AI control. Means if you send a value, it will run according to what you send. That's all. If you use PID, you know how the PID works. PID will have an input, do the calculation and everything. You will have a set point, right? Minimum, maximum set points. Then you will have an output. So output will follow your what is your input and also set point. Okay. So when you do that, the set points, everything, and you need to key in inside here. Okay. So you need to tell that okay when the analog value is 50%. Okay. No, I want to control my motor. Okay, at 25 hertz.
Okay, say that.
Normally, that's how PID works, right? I want to control my motor at 25 hertz. Okay, so if my input, okay, let's say is 50%. Okay, my input also must be 50%. If 50%, I want to maintain 25.
So I'm giving a 12 milliamp here.
12 milliamp. Okay, let's say I go high, then I need to reduce or decrease because let's say my set point is 50. I send a signal is 45 only. Okay, because based on the value of pressure. Let's say okay, like a temperature for example. Let's say this is the cooling mode, cooling fan. I have a temperature I want to maintain. Okay? Okay. So when I get a value, so let's say our temperature I want to maintain 50 hertz, 50 degrees Celsius.
50 degrees
Okay.
Celsius.
So the motor want to control the value. So I get the value, okay, the temperature value I send to here. Okay?
From the PLC I send to here.
PLC
Okay.
send to here.
Okay.
Okay. So what happened is this guy will have a set point. Means I must run motor at 40 hertz for example. Okay. So when 40 hertz I can maintain the 25. Okay. Let's say the temperature is high already. So the value will go here will be high also. Then the temperature motor speed automatically increase.
Yes, but it's not different to the AI at all. It's not different because
Yeah, it's not different.
yeah, it's not
AI,
it's the
so
same thing actually.
it's the same thing only. The thing is, if you want to do something PID, like controlling motor speed according to your temperature thing, you can do the PID in your PLC. Just send the motor value here. So just now you tell me right, PID output can be analog, can be digital.
What I mean is the PID control, the controller of the PID is all in the PLC. VFD don't know anything about it.
And no need.
He do not need to know.
Don't need. It's just based on the what you said. It will just
just
run.
based on the 4 to 20.
Yes.
You tell me 4, then I stop.
Yes.
You tell me 20, I run full. That's it.
That's all.
So the question is, what is the difference by choosing PID or by choosing
Normal AI.
AI?
Okay, very simple. If you want to choose PID, the PID setting you need to do here in the PLC program you need to do. So the temperature.
Internal PID controller here.
Yes, you need to do the PID settings here. PID control diagram. So preset speed. So the source, you see from the source from where you take up.
Then I will have another question for you.
Yes.
This is a standard feature or function every VFD also have.
The PID.
Yeah.
Yes.
Say I assume that is the case. It trigger me to another question. I assume this is a temperature controller. I assume this is a temperature control, very simple temperature control. There is a range of 40 degrees to 60 degrees. This thing, I have a PID. I want to maintain it 50 degrees. Just say like this.
Okay, okay.
And then I give an AI signal to here.
Yes, okay.
But I selected PID. So I assume he is so smart. He knowing that I give him the PID signal in, is telling him that this is the signal for the temperature.
Yes.
I want to have 50 degree.
Yes.
That's what I set the 4 to 20 here with some configuration.
Yes. Yes.
Exactly, I'm telling you, with this, I want a 50 degree. You settle it by yourself.
Yes.
That's what I'm doing, right?
Yes, correct.
But I didn't tell you. Okay. Then this is this AI here become a set point already. Or is it correct?
Source, not set point.
Source. So
Set-
it's a process value.
Yes.
It's a
set-
reading for the temperature.
Yes.
So I'm feeding him is at this second the temperature is 49.
Yes.
Speed up a little bit. Next second is a 51. You reduce the speed.
Yes, correct.
Then how I tell him what is the set point?
Set point. Okay. PID preset source. PID preset. This is where you need to set. How many percent?
So you have to manually come here to set.
Set.
I always want 50%. I think.
50%. Let's say 50 degree is a 12 milliamp. So 12 milliamp means it's a 50%, right? So I need to tell this. I want the value I get always must be 50% only.
And then I have to do some scaling at the PLC to show that 0% is a 45 degree, 100% is a 55 degree, and when the temperature play like this, his target is always maintained at 50%, which
Yes.
is 50 degree.
Yes.
Every BFD also have this.
Yes.
So this is how the internal PID works.
Internal PID work.
You are not giving him a set point for the speed.
No,
You
you
are
don't
giving
give
him a
you already do a set point, you're giving value.
process value.
Process value. So the motor will rotate according to what is the value. So it will keep on rotate until the value become 50.
Okay, so before this, I don't know lah. Probably
Negative
before-
100 to 100.
Or negative 100 to 100.
Ah,
So, okay. So my AI is somewhere between negative 100 to 100.
yes,
Okay, got it. So this is the PID meaning,
yes.
which is function differently to the AI. Okay.
Yeah. Okay.
Every motor, every ABFD also have this.
Okay.
But this is how to say? Okay lah. How to say?
Okay.
Almost not useful at all.
No, can be useful. Let's say, for example, the same concept. Okay, now I want to maintain pressure in this room. Okay.
Yeah, you give an example. Let's say, okay, then how?
Okay, I want to maintain a pressure in this room. Normally, I want to maintain a pressure. What they do, they will have a damper to open close to release air to increase the pressure here.
Damper. So okay, is it okay? Damper.
Okay. Or temperature is an example.
Okay.
This guy, okay, let's say this guy.
Mm-hmm.
Inside got a temperature. Okay, so one temperature sensor. Then I connect a motor here. Okay, to rotate. To is like a exhaust fan, for example.
Okay.
Exhaust fan.
So this is the exhaust fan.
Okay, exhaust fan. Or actually, I'm doing a project. That project also. That one is actually they have a heating element. It's a big chamber. Heating element on top. So they have a temperature sensor on one and here one. So this one, of course, near to this temperature will be accurate. This one no. So they have a blower to fully blow. Okay, so the blower speed now they are using just like constant speed lah, because they are controlling the heating element to on and off. Let's say I want to use the fan to control the speed. I mean control the temperature. Okay, a cooling fan, a box. I have a cooling fan. I have a heating element. Okay, and I have a temperature sensor. There's only these three only. Okay. Now, my temperature sensor will detect the temperature. They send a signal to this one, the drive.
Okay, you say stop here first.
Yes.
Okay, you say a temperature sensor. We define what type of temperature sensor it is. Whatever. Okay, this one.
Yeah.
So
It's a transmitter 4 to 20.
what is the setting out?
4 to 20.
4 to 20.
Analog value.
Okay, so say this 4 to 20. I assume this temperature sensor is calibrated very well lah.
Okay.
And then the branch, it have a transmitter lah. I see it has a transmitter.
Transmitter as.
It's set already.
Yes.
Okay. Let's say I say 4 is 100 degree and
Okay.
20 is 300 degree.
Okay.
So this is already have a branch as
Okay.
a setting,
Okay.
100 to 300.
Okay.
And then the middle is 200 degree.
Okay. So you want to maintain what? Okay, that's actually good
Yeah.
example. Okay, we draw it here so you get some idea. Then you will know why I need to do the PID that. Okay.
So this is we saying that it can bypass the PLC.
Yes. That's what I wanted to tell you. You can bypass the PLC. You don't need the PLC in between. Okay?
You just have to know that your transmitter is.
Yes. So let's say this is your motor. Let's say I have a fan here. Okay. Then this is the heating element. Okay. Then here is your temperature probe. Okay. Then this one go to the transmitter. Let's say the temperature range is 100 to 300. Okay. But you want to maintain 200 degree inside here. Okay. So this one keep on only. It depend on this one. Okay. Now, so 200 means okay. How many amp? Let's say this is 4 to 20 milliamp. So half, right? Half of this is 12 milliamp, right?
Yes.
You connect the here. Sorry, inverter. This is the inverter. Okay, this is the AI. Okay, like this. Okay, so here what you do, you will set, because it's just like negative 100 to 0, let's say 0 to 100%.
I have to set something. What
Yes,
is
0 to
mean?
0 to 100%. Let's say the PID preset. This is the set value. So you need to set what is the input you wanted here. Always wanted 12 milliamp.
Right.
Which
That's my
is
set point.
50%. So you put set point here 50%, then you connect here, then you can go. So in this case, what we do here, we eliminate the PLC. We don't need the PLC to do the job. If I have a PLC here, if let's say I have a PLC here, so this guy will send a signal to here. Here I do the PID program, then I control the motor.
I know what you're saying. Okay, so we have an option of eliminating the
Yeah.
PLC,
PLC, yes.
directly feeding the sensor into the
Yes.
PLC.
That's why they have the multi-step also. The multi-step one you don't need PLC. Say I just put some delays there, some delay and timers. When I start, initially 10 hertz,
Go
then
and
frequency.
three digital signal to.
Yeah, just give 3 digital signals, then you can control 3 speed. Let's say it's a conveyor, just the conveyor running. You want to maintain, if there's an object on it, run at 10 hertz.
speed.
If there's no object, okay, so 2 step enough. 2 speed enough already, for example. Then just play with the 2 output. One sensor, one is the normal start, continue run. One is the sensor, so when normal start, continue on high speed or low speed.
Got it. Now clear. Now I know what you're saying. Okay.
Yes.
Okay. Got it. Yeah.
Okay?
Okay.
All the settings you can do here.
Can do here.
Yes.
Which is not only this one. Most of the
BFD,
same function.
same function.
Okay.
Okay? Then of course you need to set the maximum frequency is what? Upper frequency, lower frequency. Because sometimes some motor is 60 hertz, some is 50 hertz. Okay? Then acceleration, deceleration time. The ramp up, ramp down.
Actually, okay, this is a maximum speed.
Yes, this one is maximum speed and upper limit that you can set. Let's say this is the maximum according to the motor. Okay, and let's say upper limit maximum you only can set 440 only. So you put 40. If the PLC give more, it maximum 40 only.
What is the difference between this one?
This one maximum frequency is the what the motor can carry. Depend on the motor, because there are two type of motor. One is 50 hertz, one is the 60 hertz motor.
Okay. Acceleration time is until the maximum speed time.
Yes, from 0 to your set point.
Oh, to set point time.
Yes.
Because there is more than this, right? Acceleration, deceleration don't have.
Deceleration here?
Oh,
Ah,
acceleration, deceleration both also here.
yes.
And that's it only. But actually there's more to set lah.
Later.
Okay.
Then motor parameters. Motor parameter you can use auto tuning or no action. No action means you set the motor.
There's a boundary.
Yeah, of course. Here you need to keep the motor function. That is, what is the motor power? Yours is 0.75. Correct. But motor is 0.25 kilowatt motor. So you need to put it here. How many kilowatt? Then what is the frequency? Motor frequency 50 hertz. Okay. What is the RPM? 1350, 1340 RPM. Motor voltage, what is the voltage? You're using 220 volt. What's the current here? 1.52 amp. Or you can use rotation auto tuning. Rotation auto tuning is once you're done, just press run. Whatever is you scan. Scan means it will send the data here according to the maximum frequency all you set here, right? Scan, then after that it will get back the data. Then it will automatically tune the.
And all the remaining things you don't have to set anymore.
The remaining thing, remaining thing actually got so many settings like the braking. Motor will have something braking, right? Some they don't use, some you need to use if the high load is involved, everything. All that can you setting. It depends on your application, where you use this motor, where you use this motor.
At one time, I encountered this problem. The motor is about the BFT. The motor every time running, there is some very high frequency, but low volume noise coming out from the motor.
High frequency.
Yeah, that's this kind of noise. Okay. So initially you thought, is it a bearing problem, whatever, and then you try to go, and in the end find out the sound comes from the motor itself.
Okay.
And then in the end, how to resolve this is the VFD have to do some tuning.
Yes.
I don't know what is it.
Yes.
But after
That's
you
what
tune
motor-
in,
Yes.
yeah, the sound gone already.
Yes.
You know what is it?
I'm not sure, but because maybe the settings they do manually. The motor settings is not correct.
Not correct.
Yes. Means okay. Here is 1300 RPM 50 hertz, but you set here 1500 RPM.
Okay.
So what happen is you set the value 1500, so it will auto tune. No, let's say you don't auto tune. The amp is become high. When the amp is become high, what happens is not accurate to this one. Maximum this one is 1.5, but you are giving 1.6.
Okay.
So it's like when it's a high speed, right? So it's like something wrong with your settings.
Something wrong.
What you can do, like what they do is auto tune, or you recheck all the settings. For example,
Okay. Okay.
because let's say this one, the drive need to send, because how this one works very simple. You set the speed here. It's like a potentiometer, right?
Right.
You send like this one is 220 volt example. 220 volt, run 50 hertz. So if you want to run 25 hertz, whatever, you just send under 10 volt only. That's all. So it's supposed to send 220 volt, but based on the setting, is sending at 240 volt. what happened? Your maximum, your motor is 220 volt, but you are sending 240 volt.
So the
of
settings,
course, so because it's why 220 to 240? Because based on your setting. That's why normally they do auto tuning to read the motor data first.
auto tuning first.
So read the motor data. Once done, then
Counter check.
any other settings you want to do manually you can do. Others.
Okay.
Initially you need to do setting like what's the motor, what is everything, do the auto tuning. Once done, any additional settings like PID control, all that later you can do.
Okay. Okay. Simple service, just like how we go through define the where you get the set point and everything, what you want, and then do the auto tune first.
Yes. And what's the you see the PID function, you see how it looks. This is your reference value. So the output frequency straight go until your reference value, then it comes to, then once you reach the reference value already, of course the motor speed decrease or increase. Let's say your temperature right, then it will, over the time it will limit. I mean it will stay like. Then why PID? Because PID will do the job up and down. At the same time, it will read the value. So the PID know when to increase the speed, when to decrease the speed.
Okay.
Initially, what happened? For example, initially when my temperature is 50 hertz, my speed is 25 only. After some time, what happened? If my temperature is 50, my speed is just like 23 hertz, 23 hertz. Because you already know already. So it will, later when we do this one, you can understand better on the PID.
Okay. Okay.
Okay, can?
Okay.
Now we do this one.
Yeah. Okay.
So, coming
So this is a SEM, this is all the
back.
DI.
DI, everything is here.
And the DI, what is mean by the DI? Can be configured inside the VFD.
No,
No.
this one will have in the manual only there.
Oh, I have to refer to the manual to say
Yes.
this means what then.
Yes.
But interestingly, this one do not have an AR.
Hmm?
Do not have an AIO here. Is it? Because O is a DO, DI, DI. So you cannot send the AO signal to here.
Can. I forget to leave it. Yes, one of the spot I forget to do which spot to do. Oh, I need to check whether this one only speed controlled by the drive only or not. Speed controlled by here or just the communication. Normally this one can, but I need to check which one. Maybe sometimes they use different addresses.
Okay, okay.
Okay, now open up here portal. You create new project.
Okay.
Create completely a new project. Then
Okay, so this is directly connected here.
yeah, all this connected to here.
Oh,
This one is connected here. This PLC connected to here. The laptop connected here. So you configure this PLC, this EQ model.
okay.
Okay. Then later on we add this. Now got error bus for right? Why?
Because I haven't configured yet.
Okay. Thing is, this one is already configured. We already informed this guy. Your PLC is this PLC.
Okay.
Okay. So it's searching for the PLC. But inside this PLC, you haven't configured this yet.
Okay.
That's why I'm giving this.
So these two using a different project file here.
Yes. That's the problem.
Okay, okay.
Therefore, VFD. Then you add the PLC first. No. See 1214, right? Correct.
The 1214C, right?
Yeah, but it's version 4.2. You right click the PLC, change. You right click on this side. Okay. Yes. Change device. 4.2. 1214 DC.
Oh, okay.
Okay. Alright. Then you right click the PLC. Properties. Because just now, when you open, there's a new protection, right? You only do the first one, then finish. Actually, got 3 things. So what we do? We go down. Communication. No, the protection. Okay, full access. Okay, connection mechanism. No. Okay, go down. Go to configure. Connection resources. Okay, no. Access level, okay. Communication. Because of 3 settings. Go up. Internet address here. Go down. Okay, then I might later issue with the one. Okay. Then you open this. You add one card. There is one card.
Oh, okay.
AO7.
SN1232.
AO4. EQ4.
So fast, okay.
No. Because that one I know. Because it's a 4 output. Is that I know?
Try to find where to read is a 4.
Here, the small one, EQ4 times
Oh, okay.
Another one is here, so you can see EQ 0, 1, 2, 3. 4 output now. And the part number is here.
Okay. So actually, usually you can read it from the front.
Yeah, the part number you can read from the front.
Okay. So you need to read from the front, right? This is the 4, and then this is the 32.
Yes. Okay. Then, so we don't need to do any programming first. PLC is still okay. Add new device. One like this. Oh, you click on device network. Okay, never mind.
Oh.
Actually, you can add new device also can. Here also can actually. This also can.
Okay.
Drive, Dynamics G. Okay, G120. But you can see see the G120 anywhere written there, because that is the PLC type. So it will show only Dynamics G120 is there. No, it won't show.
How you know?
Because when we buy it, I found it.
CU250S.
That's all. That's all.
But just now you say, I think what we have to choose is based on what is using, right?
Yes.
But here,
Doesn't
tell you what is the model.
The Dynamics, right?
Yeah,
Yeah.
How you know what to choose on?
That's the problem. If no, I must choose from here. Because here I will see click the part number. Type in the part number.
You can type a part number lah.
Yes.
Okay. But actually you know that this book, that's why you but here is this is article number.
No, no, still there. Haven't done.
Oh. Oh, this is a CU.
Yeah.
So it says this is a CU250S. So you have to choose one, you have to search one by one.
Yeah. Actually, here you close this G120. Okay, you click here. CU.
250S.
Okay, just enter.
Cannot.
Can I enter?
Cannot.
Device. You click on the part number.
Yeah.
Part number, the 6E something. But it's not 6E, 6SL something, right? Okay, press enter. No.
Cannot.
Manually. But sure there will be a way to. Okay, cannot. Maybe okay, you close this. Yeah, here, right? Okay, here you try to search anything, it's okay. Okay, click here. No, we got slash. Why slash? 6246. Okay, enough.
Okay.
Okay,
You go to this vector.
yes. But ours is PN.
221 FAO. Here is different.
That search for second one SCFO. Okay. The version you choose 4.7.10. This is the firmware of the drive.
Okay.
Like motor one lah. So can you see it's got 2 analog input, 2 analog output, 3 digital output, 11 digital input.
A has two in out.
Yes.
In and out.
Yes. So this one need to check the manual which terminal is using.
Okay.
Okay, just double click.
Okay, so we have it already. And we
Okay.
connect it.
Connect it can.
Connect.
Okay.
Oh, can. Okay.
Okay, click here. Okay, you need to add the power unit.
Inside here add the power unit.
Yes.
Okay.
So it's PM240 FSA. This one also same lah. You can find using the catalog number, but it's the left side. I show you. I think it's FSB because FS. No, not this one. You close PM-2 I think. Okay. Because ours is a single phase. Because the 240 all is a 3 phase. Ours is a single phase 200 or 240. Okay. It's under FSA. The second one is a single phase 200 volt 0.55 kilowatt. This one, you go up here. This part number for the drive, the power module,
Okay.
and the power, but the sticker at that side.
Got it. Just now I
Yeah, and I'll show you here. Yes. Done?
Yes.
Okay, good. Now we go here. Okay, finish, yeah? Now what you do, you go to drive. This is the IP address. Okay, just open the drive.
Right. Okay.
Go to commissioning. I can do parameter, the parameters. Okay. Then I need to see the one by one all. This is the current one, current configuration, based on your configuration.
Okay. Question.
Yes. But we won't do that.
No matter the power is big or small, this configuration here more or less a set, right? Almost like says to Siemens. Big or small, more or less they are always, this is the setting you have to key in.
Yeah.
Or it's not like, oh, the bigger you have a lot of advanced parameter and a small one you only can key in.
No, it just
parameter.
depends on the kilowatt. That's all. There's nothing different between controlling.
Oh, in terms of control, no different.
No different.
Only difference in
The
the
power lah.
power only.
For what this motor is for what, this motor is for what.
Got it. Okay.
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 Now we don't do this. We do go to commissioning. Yes. Commissioning basic. Okay. Basic step by step commissioning of the drive. Okay. Here. So what I do here, because when I do this one, some of the setting automatically set. Like, but still we do some settings here. The main setting just now we see in the book, right? The main settings we will do here. Okay, I'll show you. First, you remember that book, right? The first parameter is what?
The control,
The motor type. What is the type you want to use? Is it the normal pump, conveyors, or
yes.
high torque or low torque? Right?
Yes.
The same thing here. So the drive you want to use for what? Standard drive. So means pump, fan, compressors. Okay, click here. Dynamic. So dynamic is like compressor with displacement machines. Okay, it means you must have a distance. So if you want to use dynamic, you must have an encoder. You need to add an encoder into the drive and the motor.
Dynamic means you need to have a very exact speed.
Yes, the positioning lah.
Okay.
If expert, then you have to key in everything manual.
Everything.
Yes.
This one he help you to.
As we to do some
Simplify your
settings,
parameter.
some of the parameters is already set.
Got it.
Okay, next. Okay, so now, who control the RAM? RAM means the acceleration, deceleration.
So if I choose PLC, you mean PLC control the RAM?
No. If I choose PLC only send the value.
Send
The RAM, this one will set here. Acceleration, deceleration. Here means I need to do the programming for the acceleration, deceleration.
But if I choose this one, no PLC,
No
this is
PLC.
PLC control.
No, it's not the PID control. Means I just drive. Means the DIDO control also can use. This one is for DIDO or the PID.
Okay.
This one means I'm choosing the communication.
Okay, this one is still, I give a set point.
Yes.
This one is, summary is
The AI. AI.
okay.
It will follow the value in the AI.
Okay. You didn't write here, you know, because you did it already lah.
Yeah, fine. You're right.
Okay.
Okay. Next. So function modules means okay. This one the technology controller or basic positioner, free function block. Okay. All these is like a special blocks. Okay, special function blocks for your motor to control.
Special function block for the. Okay. So this is what, let's say, technology controller. Meaning to say, if I take it, then I have more advanced control feature here.
Yes, can do some advanced functions lah. Means like the position, the speed, on the control. So means you don't need to do like extra programming. So all is in the controller. So you
In
can-
the VFD itself,
No, it's a block in the PLC.
or in the PLC.
It's the block, so you can use that. But if you want to use this, must have an encoder.
All of this, all this function is some all relate to the.
Add some function block to control your dynamics drive. Later I show you.
It's
The
more
blocks.
to the servo motor.
Servo motor kind of controlling lah, but so it cannot be servo motor.
Oh, so this, I mean, generally people don't use it unless it's for positioning
Yes,
This is more to the positioning function.
yes, more the positioning function, then you can use this.
Okay.
Okay, next. Okay, this one is how you want to control. So field bus with data set changeover. Field bus means the communication.
I have a question before we go continue this page. Says if this is already installed outside, and then because to me I understand that configuring the VFD is not the automation guy or the SCADA guy job. It's a vendor job.
Yes.
Or the contractor lah. At least
Who's
it's a
installing
supplier.
this,
Yeah,
yes.
who is installing this?
Normally lah. I mean, mostly is like the commissioning team.
Yeah, whoever
Do the
in charge of
commissioning.
this VFD scope here lah.
Yes.
Says how he is the most efficient way of configuring this. Then he have to connect to the laptop, right? I mean
Okay.
easier lah. Okay lah.
Depend lah. Depend on the control type lah. How you want to control everything.
Yeah. And then for instance, we are going through this configuration here. Because I try to go through what we're doing. We start a new file here and then we name it A4 VFD.
Okay.
And then after we go through this, we save this configuration inside.
Yes. Download. Yes.
Download already. And then you have a correct setting already.
Yes.
Says I am the one who configure this,
Mm.
but I do not know anything about the
Yes.
overall PLC.
Yes, yes, yes.
Next day the automation guy come in. He plug in the PLC,
Mm.
the communication, and then he get a lot of fault here already. Because this is configured by me.
Okay.
Even though the parameter all is correct,
Okay.
but probably the configuration all is wrong.
Okay.
Wrong IP, whatever.
Okay.
Then isn't it become then he has to erase everything and redo everything again?
Not necessarily. You can back up that. Number one. You can
Back
back up that. Upload.
Upload.
Yes. Upload the drive and see what is the settings. Number one. Number two is giving you error, right? You go and check what is the error. Then diagnose. You settle the error, then it's okay because sometime, of course later on we will also have an error.
Right, I imagine let's say now we use a day 4 of VFD, set everything up. I unplug, plug again, then I create a new file. Then of course this is
But now in this case, in Siemens now, In this case, okay, the programmer will do the configuration. The programmer will do this. In this case, in Siemens drive.
I mean,
Let's say
yes.
it is a different drive. I'm just using analog only. My PLC is just using analog to control the motor. Then the drive is setting by a different guy. The PLC guy is not involved at all. If it is involved configuration, it's in my configuration. Normally the one who do the PLC will do the configuration. So they will choose, of course they need to have, of course they won't know all the settings. You know, like I said, the PID need how much, no. They need to have the sample. They use a sample program, just download it.
Let's go through first. Let's go through what is the drive setting, because
I know
what
what
I
the
feel
file
is
is
I don't see that this is a job for the
PLC guy.
PLC guy. Yes, PLC guy. And moreover is a lot of cases the person who do the programming or do the project file is not the person on site even.
Correct.
Yeah, so it doesn't make sense. Oh, you remote connect to this. I want you to from US or from wherever place configure this pump for me outside.
Yeah.
Cannot be asked him to do this also.
Cannot do that.
Yeah.
So that's why. But it is possible to another guy do like you said, another guy do.
Yeah, it should be another guy.
Can.
Actually, should be the whoever supply this one do this. Either you do by yourself or you ask your Malaysian Siemens guy come here to do. Depending this is a cheap or expensive lah. This
Yeah,
is a
depend lah.
200 megawatt or kilowatt or this is 0.5 lah. Definitely, I don't think this is something that
The programmer
the programmer has
yes,
to do
yes,
it.
yes,
Yeah.
yes.
So I know that you're going through this.
Because but I mean programmer also can do,
Can
but
do.
not necessary.
Yeah, and from the perspective of accountability, he shouldn't do.
Yes.
Something goes wrong. Oh, programmer, you are the one making
Yes,
mistake.
correct. Normally
Yeah.
they will just set give the thing with the whoever connected the drive.
Yeah. So I just wondering, what is the workflow here? For example, the vendor did the job. Probably it said that the vendor then you have to export the file and pass to the automation, or you have to come up with a checklist and give
All the parameters, yes.
Yeah, or what is the correct way of doing the
Okay, what is the correct way to
workflow,
do?
yeah.
Like you said, the thing is, okay, once they set up, okay, like in this case, Siemens one, right? Okay, they need to do the backup and give to the backup file to the PLC programmer.
You mean the file is a file that can download?
Yes, this is the file. This file later we will download. This file you can backup.
I mean, let's say for Siemens, this file is this AP18. It's an AP18 file.
Depend what they use. Let's say they use different TIA, then must use the correct TIA version. If let's say version 18, then you must use version 18 to upload.
Let's continue first. Yeah.
Mm.
Let's continue first.
Okay.
Yeah.
Right. So this one, the field bus means the using communication to control. Okay. Click here. A few times. One with one-way technology. Okay. Depend lah. For what you want to use. For conveyor or process industry. Okay. Because why? Process industry means you will have train PZD2/6. Can you see? Okay, what is that mean? 2, the first number is the input, the second number is the output. Okay? So means 2 input word, 2 output word. Okay, sorry, 6 output words.
Words.
Words. Means, so the first word is normally the control, how you control. Motor, forward, backward, all that. Second word is the speed.
Oh.
Third word is the top control, something like that.
So this is like I choose different option here, but I have to read the manual lah. When I choose process
How
industry,
many what you want to
yeah, then it
send.
will define all this AIPI
Yes.
means what here. If I choose different, then it gives a different meaning. Because
Yes, yes.
yeah, if I choose this one,
PZD2. Normally I use this
okay, okay,
PZD2. Okay, because I just use the normal data set changeover. Data set changeover means there's no specific control.
okay,
The PLC just can send the values. Okay.
okay.
PZD2 means two input word, two output word.
Oh, actually here is a description, right? EI, what it means here. Job, and then fault.
Yes.
If I choose something else, then it gives a meaning.
Yes.
Fault. Okay. Then if I choose something, okay, no. Okay, this one. Here is like defining the
EIS. Here the thing, here is depend on how many data you want to collect.
correct.
Yes. That's all.
Okay.
Means like how many data you want to send, how many data you want to collect. Okay.
Okay. So probably 6 is that. Get 16 and 6 out or something like this.
Not don't compare with this one.
Oh, no,
This one is different. This one is different. Telegram configuration is different.
Okay. Okay, but okay.
Okay, we use the field bus.
Basic.
Yeah, the data set changeover means here I can set the value. So speed set point is a 16 bit. Okay. Okay. Next. So the motor is a 50 Hz motor lah, or 60 Hz motor. Depend on the motor type.
Okay.
So ours is a 50 Hz. Okay. The drive unique supply. The drive is 230 volt.
Okay.
Okay. It depend on what drive you choose lah.
Okay.
Okay. Click next. Okay. Braking resistor. Braking resistor means you add the braking resistor, then you need to add to the motor. I mean the drive will have braking. So many terminal, right? There's 3 terminal normally for braking. They will connect the resistor back.
This braking function typically needs additional hardware or just
No,
use-
not additional hardware, just
no need additional hardware.
no additional hardware. No. It's just like a resistor to connect
To the
terminals.
terminal.
Yes, but the drive, I think we have the BR or something. BRO. You can see here. Picture.
Oh,
And this here. Here you have RORA set for the resistor.
okay.
The braking, okay, braking resistor. Why the braking resistor? This one now when it's free, yeah. Can you see? It's rotated free.
Yeah.
So when you have a braking resistor, when it's free, that's when it's not turning. This one will stick. That means you cannot turn. So that's why they use the brake.
Okay. So there's no braking.
No.
resistor.
Yes. Okay, select motor from configuration. Now what I do, if I'm using Siemens motor, then I can choose from the Siemens configuration. Okay, now I'm just using my own motor. So enter motor data.
Oh, if you use a Siemens motor,
Then they will have a part number.
then
That
just
part
key
number you can select from the order list.
Oh, okay. So I'll choose the motor data.
Yes. Induction motor is a delta connection. Okay. What is the motor rated current? Huh?
Is it?
No, current. Currently is here you see, using delta connection, right? Yes. 220. Okay, right. So it's a 1.28.
Okay.
M 1.28 M.
This is that possible to tune, is it?
Yeah, later we choose the auto tune.
Okay.
So anything different it auto tune. Okay. The power, okay, 0.80.
Okay.
The RPM is
1370.
no 1310.
Or 10.
Okay.
Yes. Okay.
Next. Next. Low temperature sensor lah. This one is an additional find the motor they will fix.
For the motor itself, right?
Motor, yes.
Okay, okay.
Okay, next. Okay, no holding brake configuration. Okay, no need because there's no braking resistor, right?
Okay.
The reference RPM. Normally, when you do in the drive, it's called frequency.
Mm.
Here they just use RPM.
Mm.
That's all. So 1310, the maximum RPM is what? The reference and the maximum is same. 1310. Enter 1310. Okay. Then RAM up time, RAM down time.
This one is about the question. So ramp up, ramp down, we just now say.
When you start running,
Question is this. Say my maximum speed is 1310. It could be different scenario, right? I could be starting from 0. I want to ramp to maximum speed 1310. It also can be starting from 0. I want to go to 650 RPM. So I key in here 10 seconds. Meaning to say, no matter I go to what set point,
the timing is the same.
always takes 10
Yes.
seconds ramp up.
Yes. It's not, I know what you mean. It's not like full speed means 10 seconds. If I put half means it's like the
5
half
seconds.
second.
Yeah.
No.
Okay. Just have to know this is what it means here first.
Yes. This
Okay.
is whatever your set point, from 0 until whatever your set point, it will take that particular acceleration time.
So ramp up, ramp down, even though I'm changing from 500 to 1000 or 500 to 600,
Suddenly change.
yeah, a step change, it will still use a 10-second time to
Yes.
slowly change.
Yes.
Okay, got it.
But don't put 10 seconds, too much. Put 2 seconds.
Okay, okay.
2 seconds, or if you want to see this, then you can put like 3 seconds or 4 seconds. Okay?
Okay.
Then off is the ramp down time. Quick stop is suddenly error. Okay? Suddenly the communication will break. The drive become error, right?
This time says from 0 to maximum speed. Because when we do the star delta, and this something to do with the inrush current, right? If we are doing star delta, not VFD. But now we are doing VFD. So this time setting here, any consideration with the inrush current? For example, I set too short here. I just assume I set too short at 2 seconds. And then I start the drive from 0 to maximum speed. Then I keep on tracking because too short here and then the inrush current is too big. No such thing. Because this is a VFD. The question is, I don't know, that's why I asked.
Oh, you mean when you initial current lah?
Initial current, then
Okay.
it's from 0 to start. Because if you do a start delta, then setting the correct time is very important.
Yeah.
But if you're using a VFD ramp up,
Not necessary because
Not
that's
necessary.
why we are using the VFD.
VFD will regulate everything
Yes,
properly.
VFD will regulate.
Okay, okay, got it. Yeah. Okay.
Okay, next. The quick stop maybe you can put 1 second lah.
Okay.
Yeah. Okay, next.
This is what we give just now.
No, this one is automatic.
Yeah.
based on the settings we just now we do, right? The motor, kilowatt, everything.
We also have key in the
Yeah.
line also.
We also key, okay, but this is the current limit. The one just now we current is the what is the current for the motor. That is 1.5 to 80. Go back.
Oh, okay. Just have a key now.
Go back.
1.2.
1.28. So the maximum that is it can the drive can supply to the motor is 1.9.
What happens if you throw more than this?
Then the motor burn. The motor coil burn normally.
Okay. So in any circumstance, if you not give more than 1.92, that is what it means.
Yeah.
If I set 1.6 here or set 1.2 here, no matter how it runs, it will always cap
The
itself.
limit, yes, up to 1.9 to maximum.
Okay.
Even though it's a suddenly motor jam or something, so to rotate because
Right.
why? When I give 50, 100, let's say I put 500 RPM. Motor must run 500 RPM and must give feedback to 500 RPM. Correct?
Yes.
If the motor cannot run, so what happens? It will draw more current to run 500 RPM.
Yes.
In that case, when I draw more current, then I go up to 192, whatever. After that, I won't. It's
Okay.
like
So
something
you're
like
staying
that.
at 1.92. Okay, get it.
Next. Okay, this is a constant. Okay, depend on the load lah. Okay. Constant load or speed dependent load.
Okay.
Okay. Then this one is. This is what we need to choose. Identify motor data as sensitive. This is the auto tuning.
Oh, okay.
Okay. Click next.
What is a shift here? I mean, it choose what?
Inhibited means no.
We don't do auto tuning.
Yes. Straight away line.
Identify motor data, sensitive, we need to say later. He will start to research what is
Yes.
tuning.
Yes. After download we do that.
After download.
Yes. This one second one is do the same thing. Motor data identification. Switch to operation means when we do straight away run start. So when first first motor run after you download, automatically you do auto tuning. Then only it will follow your process.
Okay.
The second one is you do auto tuning manually before you download the PLC program, before you start the system.
So I assume this is a water pump now. You can choose off. You just start pumping the water and let it do the auto tune, or you don't have water, but you manually do the auto tune.
Yes.
Okay.
Something-
Sounds right. Manually do the auto tune.
Yeah, of course not. Because then only we know what's the problem.
Okay.
Next. Okay, that's all finish.
Wow. Okay. Finish.
Now what we do, you click on the drive. Okay, before that, okay, now click on the drive. No, just normal click download. Okay, start search. Check the cable. Check the drive cable. The drive Ethernet cable is it connected? Okay. Start searching. Okay. No, not direct to the X. So click here. The PNIE. I mean the Profinet network. Yes. Fast search. Is that?
Here's a question.
Yes.
Do you know anything about, not exactly a control thing, harmonics generated by the VFD?
What's the difference?
Harmonics.
What's that?
It's a power quality thing.
Okay.
Like if you have running, especially the bigger the VFD,
Mm.
and then the plant has a lot of VFD,
Okay.
if you give a lot of dirty power to the upstream, and
Okay.
then causing the overall electrical system power factor go down,
Oh.
and then there's many ways. I'm not electrical
Yeah.
engineer. Of course, one of the things I see how is overcome this is you install a harmonic filter. Like before the VFD, you have another panel is called harmonic filter
Oh.
to filter the dirty power generated from the VFD. I'm just wondering, inside the VFD has anything to do
So this one.
to reduce the dirty
I'm
power?
not sure.
Yeah, but anyhow, this
This is the first time I heard.
yeah.
I'm not sure. Okay.
Okay.
I'm experimenting. Answer, what do you call harmonic power?
Harmonics, they call the harmonics.
Harmonics.
Yeah.
HARMONICS.
Yes, harmonics generated from VFD.
Harmonic. Okay. Harmonic distortion. Stability. Noise caused by non-linear load. Oh. Is it similar to a noise reduction? So actually, without this, what happened? Without harmonic filter.
In the bigger picture is TNB. I mean our utility supply TNB, right?
Okay.
Has a limit on every power supply to every factory.
Okay.
To everyone.
Okay. Yes.
There's a limit of 0.5 above the power factor this plant has to achieve. Because achieving, let's say, lower than 0.85, meaning to say this user is wasting the TNB power. So
Okay.
and then TNB have to penalize this factory.
Okay.
So and also on the other hand is the higher the power factor, the more efficient you are utilizing the power.
Okay.
You have a less heat generate, you have a more reliability,
Okay.
your whole cable sizing is smaller because you are more efficiently use the power.
Okay.
7M you're getting more out.
Yes.
If you are not doing this, then everything is very bad. For example, just look at this motor, the power factor of this one is very low. I don't know, 0.5 or 0.6 only.
Okay.
Meaning to say every 1M going in
Mm.
only 0.5 or 0.6 coming out, used by the motor only. The remaining all is wasted already.
Oh.
Sent to this,
Drive.
especially the drive. Yeah, drive will cause a lot of harmonics. Just like I say power factor, harmonic is one of the reason reduce the power factor lah. Sorry, the other way. Power factor is one of the reason causing the harmonics.
Okay.
But there is a lot of things to cause a harmonic as well.
Uh,
Non-linear drive is the most common, which is VFD is causing the harmonics.
oh.
And a lot of other things cause the harmonics. That's the thing here, I'm not an electrical guy,
Yeah.
but this is a very important concept here. The plant have to, from the engineering system, from the electrical engineering system, they have to design it, then to put in a lot of things like harmonic filter, whatever, to boost up this kind of power quality. We call it the impedance. Have to reduce the impedance. Yeah, the harmonic filter is the one The harmonic is the one causing the impedance here.
Oh.
Yeah, it's an electrical term here.
Yeah.
One of the main contributor nowadays the factory getting more and more this impedance is because people using more and more EFT. Right. Especially if you say small only a few, then doesn't matter lah. But imagine if a factory they have all the big motor,
Big
100
motors,
of kilowatt, everyone also using a big filter.
Current lah.
Yeah, and then it will cause a lot of dirty power. Yeah. But anyhow, that is another. It's an electrical thing lah. Yeah.
Okay, good.
Okay.
Done.
Yeah.
Now go online with the drive. Done. Okay, now use the control panel here. Yes. Okay, click here. Activate. Asset. Now you put some speed settings.
Okay.
Any RPM. Enter. Just click forward. Yeah. Stationary measurement in progress. You see? Now it's doing the
Auto tune.
auto tune. Done. Set again. This was just to test only. Okay. Okay, ready for switching on. Okay, just forward. Okay, the motor can run, right?
Yes.
Yes.
So now our auto tune is
Done.
finished.
Finish. That's why the motor can run. If I didn't do auto tune, I click just straight away do the program, it won't run.
Okay. This also have a high pitch frequency.
But because he's still under this one, right? That's why. Once this one done, later when you do programming, then you won't need to.
Oh.
Of course, you will never hear the sound of motor on the drive. I mean the exhaust, the fan on the drive.
The high pitch sound.
That one, yes.
Yeah.
Okay, you reset. So once this one done, you reset.
Okay, reset.
Yes.
So the
Because why just now drive is enabled, means you enable to run the drive, but you haven't start the drive. That's why just now the sound.
okay.
So later when you do programming, then you won't hear the sound. Okay, good.
We go into the commissioning page
Yes, this is under the community page.
and then we set it.
We actually firstly we activate the master control, then we set the drive, enable the drive, then only we do the forward backward.
Then we do the forward backward.
Yes.
The forward backward here. Okay. The main purpose we come here is to do the auto tune here. Okay. So now finish already. Then we
Done
done.
is ready. Then deactivate first.
Deactivate first.
Yes, then only the PLC can go to. Okay. Now, still got some error, right? Still the bus fault there, right? The bus fault LED.
Yes.
Yeah, because the PLC I haven't downloaded the configuration.
Okay.
Because why? Go to the drive. I mean device and network. Okay, why the error is still this error? Because we haven't tell the PLC that this is my drive. Because you haven't downloaded the PLC hardware.
Play configuration.
Yes. Because still is the whole hardware configuration. So in the whole hardware configuration, the drive is not there. Okay, so download. You right click the PLC. Download to device. Hardware configuration.
This is to the PLC.
Yes, now for the PLC, start search.
Okay.
Okay, now drive okay. Now I can do the program to control the drive.
For the drive, there is no configuration download, only software download.
No, just now when you download both.
Yeah, I mean because I select the PLC, right? When I download PLC, I can download.
Yeah,
Hardware
because
software.
okay, no, because drive why don't have the configuration? Because you are online. You go offline, then only can see the configuration.
If I really want to do download configuration, I have to offline first.
Yes, offline drive.
The one is a software. Can it download? There's no software for the PLC, right?
Software is the one like
For the drive itself.
software means actually software means the commissioning all that.
Oh.
The drive is the drive part number, the drive settings we do for the drives.
So the parameter is a software.
Yes, the parameter is considered software. It won't go under hardware. Like PLC. The PLC settings only become hardware. Whatever program we do, the blocks we do, all is software, right?
So you mean let's say this page here, everything, all the information within this page is called hardware.
Yes, correct.
Everything else here is called
This is the diagnostic. Yes.
diagnostic. This is software.
This is software.
This is software.
Yes, correct.
Okay, get it? Yeah.
Okay, right?
Okay, yeah.
Alright. We go for a break. After the break, we come and
Okay.
do the controlling, PLC control. Just very straightforward.
Anything has to know about acceptance.
Acceptance, I think, is the acceptance test. I've never tested before.
Or not a common thing or critical thing.
I'm not sure for what is the function.
Okay.
Because for normal control, I don't use them.
But just now we do all
When
this.
you click what happened, I also.
There's nothing much here also. Overview, test result.
Oh.
Yeah. And I'm just curious. This is something very, very important for the company.
Yeah.
Also, you just now you say download and upload. Let's say I take out this component, go to the other one. What is copy pasting to the other?
The drives.
Use the AOP. It's the software.
Yes.
It's the software.
Actually, software and the hardware both.
Both also can.
Yes, both.
Okay, get it. Yeah.
You back up both.
Hardware and software both also can
Yes.
back up. Okay. So I actually am trying to go through the parameter list and trying to export it because I see the parameter like I say this is we say this is common, right? Every VFD has a common parameter list, and then
Yeah.
it seems to be really very long here. But of course, not everything we have to
Key in that.
key in everything.
Normally
here.
all will be factory setting.
Sorry,
Factory setting.
factory setting.
Yes.
But some of it is influenced by us as in
Yes.
we are the ones that did.
Yes, correct.
And how I say, actually I just wanted to try to know how to keep a record. How to keep a record. This is the final.
This is the final one.
Right. So then of course,
Print.
yeah. Then I find out it can do a printing
Yeah.
I just wondering since this is a software it comes together with a project file also.
Okay.
Yeah.
Now I know what you mean. You
Yeah.
mean the file, right?
Yeah. The file is
You,
the file.
you are not requesting for the.
Let's say this is a file that if I say a hard copy paper or PDF file,
Okay.
here is where to do it already.
Okay.
If let's say the soft
project.
the software file, let's say the PLC anybody do this or not? And I only need the PLC for inside here, but I don't have a whole AP18 file, or maybe I don't need the AP18 file.
No, cannot do that.
Huh?
Cannot do that.
Cannot do that. You must have the AP18
Yes,
file
you must have the AP18. Because all together.
all together.
Yes.
You cannot I only have a software file, but I don't have the AP18 file.
Yes.
But I pass to you. This is the parameter, and then you can download it to the.
Okay, that one. Can you minimize here? No, the main.
This one.
Yes. Minimize here. Okay. Wait, okay, that is the start drive software, but
Yeah.
start drive is already together with this one. Okay, click
So
here.
this is obsoleted, right? The start drive. Nobody using it anymore.
No, can use.
Can use.
But I don't know, is it separated or together? No. Just click here. Okay, go down. Go to Siemens. Don't type Siemens. Just go to Siemens. Okay. Where is it? Siemens automation. Okay, go down. This is the VA runtime elements. No, start trying to that.
Not part of the package.
No. Because actually I installed separately, but it's go together with the DI folder. Go up. Wait. Don't have anything. Okay. PLC S7-1500.
But it still doesn't matter. I mean, imagine this. I just try to imagine this workflow makes sense. Imagine you
But
are
I
a
think
operation
can.
team.
But I think can.
Yeah, like I am the Siemens vendor here.
Yeah.
So I configure everything. I use my own file and then it's Siemens dot
Yes.
18dp. Then I configure, I say 20 EBS correctly already.
Yeah.
Then everything I tell you or everything is safe inside. Here's my report. Then you take over. You connect everything. After the network is done, you connect everything. Inside originally already have the configuration, already
Yes.
have the software, which is separate, right? We say the parameter is the software.
Yes.
And you still can use your own 18AP, I say that as a control system dot 18AP file to do your configuration for all the hardware, including the VFD as well.
Yes,
And
correct.
then do the PLC programming as well.
Yes.
But you're not touching the software side, the parameter.
Mm.
You just configure the address.
Configure the
Yeah. You have to go
the
back to
configuration lah.
configuration.
Do the
What
configuration. Yes.
Configuration is a very not many things can to configure for the VFD.
Yes.
But parameterization is a lot of things to do.
Yes, correct.
If you want to do that.
Mm.
Okay.
But wait. electronics, I don't think so. Yeah. Other drives they have. Starter, so. Simulation, yes. Then Siemens starter, Dynamic starter. Actually, it's a previous version they use this. Dynamic starter is a software.
Which is not part of the TIA portal.
Okay, why? Because earlier, SIMATIC manager for PLC, the Dynamic starter or micromaster starter is for the VFD.
Okay.
Two different.
Okay.
So now both in TIA portal.
Okay.
So when you install TI, the starter, you go into the TI portal.
Okay.
So what you can do if you want to, if you just want to send someone the drive file only. Okay? So without the PLC, you go to the drive, you do the setting, everything, then this file you can send. But still, like you said, it will be TI 18 file only. It's under the AP 18.
There is no universal format of file like all the BFD is using.
No.
No, I don't know. I'm just curious whether like CSV or something, or Danfoss also using this kind of parameter, and Siemens also using whoever, no such thing. Everyone has their own.
But you can export to Excel, you can export. The parameters are okay. If you want to export to Excel, yes, can.
Can import also? Cannot import. Can export only.
You go offline? Yes. Okay, click.
Cannot right click. You can right click. Export to CDF data.
Okay, you click that. Oh, it's an AML.
Where's the AML?
It's just a file only. If you want to import in another project, you can import that.
Or like combining the project file.
Okay, for example, not combining for project file. As example, you already configure everything. You want to send to someone only the drive settings only, drive files only. So you can export the AML file, send to him, so he can import that.
Configuration of the drive.
Configuration, everything.
Or everything.
Yes.
Okay.
Can,
For
we
the
can try.
drive.
We can try also.
But so the person how to use it, he open his AP18, import AP18, and then he import the
Yes.
AML file,
Yes.
and then he will show
The drive will be there.
it will be immediately there before the IP address, everything will be there.
Yeah.
And this is a Siemens file, not
Yes, Siemens file, of course.
Okay.
But how to export data?
So just now you say is it considered the fastest way to do? Let's say
Okay, oh, under the acceptance test, you can do the file. Okay. Is it online or offline or what? Yeah.
there's no safety integrated function parameterized on this drive, and acceptance test is not possible. Oh, I click the
No, nothing. Why do? Yeah. Let me check first here. I got. Acceptance test.
Because I try to understand.
G120 is not there. because I see under the acceptance test there is a G120 here, but here I'm not showing, I don't know why. Okay, then after that it can generate a report, then it can export the
From here,
from this
this is the right place to generate the final report lah.
the what in Excel.
No, it cannot do because
I'm not sure. You go online also same nothing.
because in another problem says just now we say the project could be has a lot of repeating VFD and repeating pumps, fans, or this set of this pump has 6 for example, n plus 5n plus 1, right? Probably have 5 pumps, 5 pump plus 1 redundant, you have 6 pump, and that fan has a 4 fan, same size, whatever, and then this set is a 5 or 6, whatever. There is a lot of repeating.
Yes.
Impossible, you ask them. I mean, not to say impossible lah. Inefficient. Ask the guy to, this one you set it already. Do the same thing, set it again, auto team. Do the same thing again, auto team. It would be like more efficient, like you say. Do one time, copy paste everything. Do one time, copy paste everything. Because they are essentially identical, same purpose, just they are repeating only.
Yes.
So what is the most efficient way of doing the parameterization or doing the
Parameter, like you said, I just do here and download. Okay, but the standstill, it still need to
consider this?
because this drive, even though the parameter everything is same, I need the drive to still scan this to do the settings.
You mean the auto tune have
Yes,
to
yes.
redo. So the right thing is the person brings the laptop, directly connect to the drive, open the TIA portal if he's using Siemens, and then you configure everything, not configure, do all the mainly it's all the parameter because there's no configure for him to do, no networking at all.
Yes.
Yeah.
But after do the tuning, then I think because I don't have any other drive to test, there's a problem. I have another drive, we can test it out.
Okay.
But I think if you ask me, right, because after the tuning, because if you really do all the parameter settings,
Okay.
right? So once done, then you save that. Then that file you can download to all the drives. So if in that case, I think no need to do auto tuning
So
for the other drives.
let's say because I direct connect so I can download easily lah. I scan it, then my hardware, my device is only one device. It's a VSD and the pump and the motor lah, and the power module lah. I done already. I download it inside already. Okay? And also I have the AP18 file already. I disconnect this one. I plug to the second VFD. Then I don't likely to be. I can just scan, search and found, and then connect, download, finish, and go to the next one.
Yes.
Do the same again.
But okay, there's a lot of things here. Okay, now the thing is, okay, let's say this I use one PLC, and this one PLC control how many drives?
Says this is a
10 drives.
Okay, 10 drives lah.
So in here, we must have all the 10 drives here.
That is a final automation guy
Yes.
job, right? So
Yeah, of course.
I
Yes.
mean,
In
imagine
this project, yes,
Yeah.
we will have that all the
I mean,
10
if consider I am the vendor for the Siemens drive and the pump skid.
Okay.
Yeah,
So
I'm
two
responsible
person.
to make sure this commission properly.
Okay.
But I
Then
don't
it's
care about
only
your
one file, like you
function.
said. Only one
Yeah.
file. Done. Auto tuning, then just go download.
Yeah.
Even I can use the BOP. Just back up from here. Just restore, finish.
Yeah.
That's how I do.
Say another integrator come in, the automation integrator, he do the overall project system integration for the control. Then he connect to all 10 VFD. Then he just have to do the configuration. If the VFD guy have done the correct job here, he deliver the correct thing. You just have to configure, this is the address, and if you configure correctly, this I/O, I already programmed in my PLC, I just have to correct the address. Okay. Then again, it goes to the address. I am the one setting the address here. I mean, the automation guy set the correct address.
Yes.
And then he set the correct address, everything is correct. Then the IO, I should be, this the IDO, I'm getting this, or I'm sending this BFD will behave this way.
Yeah.
That's it only.
Yes.
And then I don't have to like redo whatever parameterization, anything here.
Yes.
I just try to make sure that this is sounds logic, right?
Yeah, yeah, that's how actually they do lah. Okay, so
Or if this is a, or this is a like maybe for other project, the automation guy cannot be. I don't think this is going to be. I don't think this is common. The automation contractor supply everything until the VFD also supply, because normally they don't supply the VFD. VFD is part of the mechanical project.
of course lah. But
Yeah.
sometimes what happen if you take a project, they will supply everything. But of course they have a program on different.
I mean like
Yeah.
the control team, the control programmer, they can supply up to the device, the sensor, all this. But I don't think makes sense any project to ask to say that, oh, you control contractor, you supply the VFD, and then you are the mechanical contractor, you supply the fan only. That doesn't make sense also.
Yeah.
Because he has to be the one. This is VFD normally is considered part of the mechanical package, not even the electrical package. They are the one buy this one. They are
But
the one.
normally whatever, but that's the thing. Because if it is involved company, then of course, because like say you give me this project, for example, okay, let's say so whatever, I will have a mechanical team, electrical team,
Yeah.
a software team.
Automation and control automation. Yeah.
Okay, so 3 different teams. So
Right.
I will tell them, okay, you buy this VFD, this one, then you go and install. You do the wiring, you do the install everything. Then last one, the programmer will do that. So it's within the same, in the same company. Then you will don't have any conflict. Because I know some company in scale, because we worked together last time for projects or the same company. They supply the motor, they supply the VFD, supply sensors. But they because they have the manpower for each work. Yeah.
But of course, I mean, ideally there's a case. Ideally there's a case. When no matter how no matter what level it is, if there is a split of scope here, it is about the workflow. Who accountable for what?
Yes,
Who accountable for what? Mechanical package normally accountable for the VFD.
Yes, of course.
Control package normally accountable for this.
PLC
Then-
and sensors.
Yeah, PLC and sensors, right?
Yes.
And then how these two teams, then there is an interface here. The question is how these two teams going to work together most efficiently. That is a question I'm trying to think about. Like the mechanical package, or they done the mechanical very fast, or everything
Okay,
is on
now-
perfectly.
This also can happen because last time I did one small project. What happened? The other people, okay, like I said, I went to Sigama to do the settings. So I mean, to do some programming. Okay, so what happened? They hired me as a programmer. Okay. Then they already installed all the VFD and already tested all the VFD, all the motors.
With
Okay.
manual run.
Manual run.
Okay.
They don't set with your son. So in the manual run, what they will set the motor setting, everything. Only the control is by keypad.
Exactly.
Yes.
This is the part of the mechanical.
Mechanical, they
Up
only
to-
can do up to that only.
Yeah, minimum they have to do up to manual run.
Manual run,
Yeah.
yes. Now when I do program, I do the configuration. Now I go download I need to download all the configuration. That's what I just like.
So you mean you download their configuration? You do the configuration as in the network
Yes. So
configuration.
means you will do the configuration, the commissioning, right? Just now commissioning all the values, everything, right? You do that. For let's say you have 10 motors, for 10 motors you have to do here.
The parameter and the commissioning,
Yes.
you have to redo.
Yes.
Then you overwrite their original.
Yes, original setting. Because the original setting, because they up to make sure the motor running, that's all. They cannot set our data because they don't know how we want to control. Whether I want to control, because they are not the guy who do wiring also, right?
They are not the guy to do the wiring, which is
Because
Yes.
what I
Yes.
mean wiring means they don't even
they don't know the PIDO, what is the means here.
Okay, no, they of course they can know that, but the thing is they don't know whether the control is using analog or communication or PID. What control you want to use? It's depend on the
Okay, then
program.
it's very makes sense.
Yes.
I supply I'm mechanical supplier. My job is supply it and locally, individually,
Yes,
it's
yes.
functioning properly.
Yes, correct.
But I see that isn't it there are some setting in the VFD is so critical that even you are automation guy, you don't know, probably you're not familiar how to set. And it is something that it could
Only
damage
the-
the VFD. Probably even a Siemens guy only he know how to set. Probably I don't know, I didn't go.
Okay, for example, basic control, of course, the automation guys don't. No.
Yeah, basic control of course
No,
you
okay. Let's say you want to do like PID controls. You don't know how to do the PID controls. Then you need the guy who can do the job. Like special functions, you want to use the special functions, special settings you want to do. Then you need a VFD specialist. Even sometime, if sometimes the fault come out right, even the programmer don't know how to solve the fault.
Who really do the configuration?
Who need to do the configuration?
I mean now it's only the VFD part lah.
Yeah, I know what you mean.
Yeah.
Mean okay, then because I know why you asking this question. Later on, when anything,
Because it will be repeating and repeating and repeating.
yes, if not only repeating anything, need to change or something. So you need to contact who, right? That is the
Yes,
concept, right?
yes. Who is accountable here?
Yes, then you know who to contact on this part. Okay, if you ask me,
And
that's the thing. Depend. If it is communication, involve communication. Let's say Siemens Profinet. The PLC guy is the one doing the parameters. If you are using Modbus, so you no need to do the parameter settings. Okay, so you must have one guy who is familiar with this one to set the parameters to control using Modbus.
I know it. But in a way, I agree to you lah. Actually, automation guy, he has a lot of responsibility here.
Yeah, of course.
He has a lot of responsibility here to.
Because why I say he's the one, because he's the one decide how to control the motor. Whether
Yeah.
it's a standard just now, is a standard motor or dynamic drive?
Yeah,
Ah.
he's the one decided.
Yes.
You want to choose 10 second, 20 second.
Yes, the ramp up, ramp down.
He's the one decided.
Yes.
So the probably contractor is only I do anything up to I prove that the VFD and motor can work together. can
Working,
run,
yes, just
Finish.
working. Yes.
Parameterization.
So that's why you see when you buy a new drive,
Yeah, so if this factory like
no, because I've done that.
ah
You buy new drive, always my default is a keypad on off, the speed also is a keypad. You don't need to do any parameter settings. You need to need to do the motor data lah. Others all will be standard factory setting. Okay, so you go to the motor data, key in the motor volt, the power, everything done. Okay, then you just click start, motor can run. Sometimes it will be set in auto tune in the factory setting. Sometimes it's not in the auto tune menu. So what I do is, if it is not in the auto tune, just on. Okay, so for the mechanical team, this one, they are not need to worry about much on the drive. They need to know which parameter to set the motor data, then they just run and stop. Because they need to do the forward backward correctly.
Even you say like that, at least setting the motor data correctly, which is essentially this means that how you say, it means that this is configured properly or safely running lah. It cannot be this is a 230, he set it 500 watts something like
Yes. And normally, you know what happens is, let's say these guys, right, before I come and install, they already tested India. They buy one drive, they already tested everything. They just copy the file and keep. Once they come and install at your place, only one drive is already parameter set. Then they just because before I come, let's say you order something, you ask me to do a project. Before I come to you, of course I need to check whether this drive, this motor is correct or not. Everything I test first. Once done at the parameter, the basic parameter, I back up the parameter. And once I come to your place, install 10 motors or 10 drives. Okay, just copy. Can use the VOP or can use their own original software. Just download. Even I can use the software to run it, like just now we run and stop. I don't need to go manually run and stop that. Use the software to run. Okay, forward. Is it correct rotation or not? Wrong rotation. In the parameter, there's a setting to turn the rotation. Then you can turn the rotation. That's all.
Imagine this. Imagine says this is a software team. Let's say you have a software team, and then your client from the external third party, whatever, has a lot of different type of VFD lah. Not necessarily it come from Siemens. If it come from Siemens, at least easy lah. TR portal. At least
that's the thing.
Easily update. Says it come, I don't know, Schneider or Dengos or whatever, and ABB. There are so many different brands. So where you get the software to configure everything?
That's the thing.
If you say that automation guy have to be responsible for this.
Not necessary also. Because you know why? Last time I get requests for just VFD training only. They want to know VFD. They don't want to know PLC. They don't know PLC. They just want to know VFD training. Because these guys are go and install that, so they need to know how to set the parameters. That's all.
You mean the client himself have to set?
Yes. So what happened? Like you said, it's a mechanical guy. They are going to do the settings. So they go for this type of trainings. Let's say you ordered a machinery from me, for example. Okay. So I supply the mechanical part. Okay. Then you say you must use Siemens. Okay. So what I do I want to supply Siemens. Of course, what I do, I buy some parts from the Siemens. So when I buy the parts, if I have a manpower to do this configuration, then it's okay. Let's say my manpower is familiar with Omron. It's not familiar with Siemens. What I do, I engage with Siemens. When I buy the part, do you provide any training or not? So they will go for training. So in the training, they will teach how to do the parameters.
The Siemens teach the client.
Yes, that's what we do.
Still, it's like you're trying to say is that Siemens will teach the client. Client is the ultimate decide how he want to connect.
Yeah,
Of
of course. Because that's the thing, because different project, different type.
Yeah.
That's the.
I think I try to get from this like different project. This scope or the roles and responsibility
Yeah, it's
all
different.
all different.
Yes.
A turnkey project or whatever. The, yeah, the point is how to handle it. The point is how to handle it. The point is how to handle it. But anyhow,
No, I know what is your concern because when you manage a project, right? So you are responsible to, to get the job done. So if you want to get the job done, you need to know who is the responsible for this job.
yeah,
Correct.
easiest is like you say, if only one contact point, the mechanical, this pump and VFD and the SCADA control OBS under the same person, then
Yes.
I don't have to ask.
Then yes, correct.
Yeah, I don't have to ask. But usually this is not the case. It's
Yes.
always different person.
Different person.
If not managed correctly, then this person will just give you I done already. Bye
I
bye.
done my
Yeah,
part. I done.
yeah, and another person say, oh, because I don't get this, then I cannot run. This is not my problem.
Yes.
And you will be stuck here. Yeah.
Yeah, like you said, same. If let's say sometime the programmer I have seen,
Yeah.
not seen before, I have heard before, like my participants says, what happens is sometimes whenever there is a project, not project troubleshooting, so there's a PLC guy going troubleshoot, then this guy is not familiar with the VFD. So when the VFD is problem, he said, this is not my part.
Yeah.
I cannot do
You
VFD.
can easily say this.
Yeah, I cannot do the VFD. You just
Yeah,
check.
we ask
Yeah.
the vendor. Then vendor say, oh, it's running already.
Yeah.
I finished my job already. So this handshake is not there.
yeah.
So the question is how to define the handshake here. Like,
Okay, how to define it? Okay, maybe it's depend on the control, how you control. For if you ask me, if the PLC is controlled using communications, means which is in their configuration, like this.
yes.
Dynamics in their configuration. So before you start a project or something, you just check with them maybe, okay, who will do the configuration?
This is a fair point, like from the beginning of the
From the
project,
beginning,
already define the scope, right?
define the scope. So you
Yeah.
so from there you know already, okay, what type of communication using.
Yeah.
As a like, okay, now you know already. Let's say they say Profibus. Then you check, okay, Profibus, who is responsible for the VFD? Let's say VFD, of course like interface module, of course a programmer is the responsible. Right.
I think it's because, say this is a SCADA. I mean SCADA because we are doing TIA portal, right?
Yeah.
So we always say SCADA is
Yes,
a
yes.
TIA portal here. If this is a Siemens ceramic, you still have a chance. If this is not a Siemens ceramic,
That's the thing.
then you go in, only ask a programmer, you're going to go through a lot of problems.
Yeah, that's the thing because when you, but this one is you need to design in the starting of the project itself.
Yes,
So
yes.
let's say you are not using what? Siemens, you are using Modbus protocol. So if it is Modbus protocol, the driver is not responsible for the project. I mean the PLC guy. PLC guy only will get what is the Modbus ID of this drive, what is the address, which address Modbus you want to use. These two only.
Yeah,
So the other guy must do the job.
what I see the most likely if the automation team contractor, he responsible for everything, he cannot do
Yes.
because he will miss out a lot of.
Yes.
But if you say they are not responsible at all, the mechanical guy, they have the responsible to set everything.
Yes.
Impossible also, a lot of information they don't know also.
Yeah.
Some sort of shared responsibility here.
Yeah, of course.
It's like there are some way of workflow here. You have to pass this information to him first, and then he have to set a
course.
3 days plan on site, 2 team put together, this kind of thing.
Because let's say like you said, same thing, but like what you said is correct. Like Profinet is still okay. It's under programmer. Right? When we talk about Modbus, okay, let's say Modbus. So like these two guys must have the meeting to know, okay, Modbus, okay, let's say mechanical, they say, okay, we will set Modbus.
Right. Okay, I think
So-
Modbus is a good example.
Yes,
here.
that's why I said, because Modbus is you can separate into two teams. Because if you do profit net or profit bus, it's like you cannot separate
All from
into two
the
teams. It's
same
like
platform, yeah.
it's because using the same software. Okay.
Yeah.
So when we talk about Modbus, okay, you need these two teams clearly need to know what is the data the PLC guy need from the mechanical team, from the drive. Okay. Then for the mechanical team, need to clearly know, okay, what type of data I need to give them.
I think you are saying that there is a sort of, it needs a, let's say, a 1 day
Yes, yes.
signal exchange on site.
Yes, yes.
Two parties
Two
we
parties will sit
together,
down. Maybe
one by
one
one
person
go through the
yes,
signal
go
exchange.
there, change. I mean, let's say it's complete, because that's how. If you give me this job to like the whole one company, that's how they also work together, right? One guy is the programmer, one guy who do the setting on the VFD. Both of them sit together, we discuss. If there's a same company, if let's say it's a two different company, they need to decide like one day, like come up with the one drive, everything. They come up, okay, because the PLC guy will tell them, okay, I want to use Modbus. So this is the communication. This is the what? The speed. This is the parameters, everything.
I
And
think
from
I
that
get your
guy,
point.
yes, he will tell, okay, this is the motor speed. So you cannot set more than 50 hertz.
It has to be mandated that, let's say this is an automation team and the VFD vendor,
Yes, correct.
we have to be set 1 day, sit down,
Sit down.
go through together.
Another thing is, actually I get that good, that's one. Another thing is, because you are the mechanical guy, you know about the drive, you know about the inverters, everything. You need to tell the guy what are the data you can take from the inverter. Because
But
you
of
need to
course-
tell them the
But usually, I mean, not to say usually lah. I was imagining most likely in the beginning when the automation team he design or he do the programming, he already know. Can I say he already know? Not necessary, right? Because he don't know what about the
not
VFD.
necessary also.
Yeah, not necessary. But
Let's say like if he is like example, what to say?
But he can know what is the basic one lah. He can know what is the basic
Of course,
one.
you need to, because Modbus you need to download the manual, because from the manual only you get all the data. So you
Right.
need to know what drive, how to extract from them.
If this project is designed to use a Modbus
Yes.
communication to control the VFD,
Yes.
and that is very important. Actually, this is the point here. The Modbus, yeah, I think we haven't go through that.
Yeah.
The Modbus communication,
Mm.
to me, is very important, really.
Yes, sure,
Because
sure.
always I will see this kind of thing happen.
Yes, sure can.
Modbus, and then how to make sure that both party, the protocol is correct, receiving and sending the signal is correct.
Yeah.
How to have a correct workflow here, and then what are the file, like the Modbus address or whatever, how should this file be shared to each other from who to who and so on.
Yes.
Yeah.
Okay. Tomorrow we can do. That's why I set up both, because I don't have a mobile TCP communication device.
Okay.
Anything to communicate with TCP. I have RTU, but I don't have the RTU module here.
Or can we change this or not? Let's say this is TCP, right? Make it a TCP Modbus or something like this instead of find it using the TR1000. Then we have to force it to use a Modbus format to communicate. I mean, like, so that we can have some testing, right? Testing.
Okay. I will check first, because it shows can do. I've never done before. It shows can do. Check first.
Okay.
If can, then
Then
can
try.
make
If
it
cannot,
as a-
then yeah.
if cannot, then no problem, because we can communicate this between
this-
these two.
These two still can use a Modbus to
Yeah,
communicate.
for us, one is the
okay, can use this one also.
client
yeah.
server, but never mind. I just check,
Yeah.
because it shows the Siemens can. So I need
Because
to.
actually this is doing the same thing also.
doing the same thing,
Yeah.
but when you, I know what you mean. When you do that, you get the idea.
Right.
If you
Because this is going to be very common.
Common.
We one pass to PLC
yes,
is going to be very
yes.
common.
So I give me like today, I just go and check how to. The thing is how to enable the Modbus. I never done before. So need to know which parameter to enable the Modbus.
Oh,
Ah.
because this is very specific to the device.
Because this one got two types of communication device. One is Profinet, one is the Modbus.
Right.
So I need to check which setting to do, change the setting to Modbus. Then, if in that case, you will have two files, two TI portal project file. One is for the PLC, another one for the drive, or PLC drive in the same project file, but you won't do the
connected.
yes.
Ah. Okay, I got your
Okay,
point.
got it, I got it.
Yeah.
Today I go and do some research and see.
Thank you. Thank
The
you.
thing is, I need to know how to change the setting to Modbus. Number one. After that, we just go to the what? The manual. The most important is the manual. Because from the manual only, we can know what is the addresses.
Okay.
Mm.
I know we have tomorrow one last day. If
Never mind, never
we
mind.
can make it tomorrow to test the bus, do the SCADA and test the PID tuning.
Using alarm. Can.
Can. Okay. Okay.
Can, sure.
Okay. Yeah. I think this, because these 3 are
The most important.
Most
Because
important
the
for
thing
me.
is, for me,
Yeah.
I don't need to explain on power the data types all. Because you know the data types already.
yeah.
So when we do PID also same. You know what is PID works. Just need to know how to use the blocks. That's all.
yeah. Yeah.
Same thing for Modbus also. Modbus you roughly get an idea how it works. So when we do Modbus tomorrow, so we can learn at the same time the addressing. Then just
Okay.
need to know how to get the data from the Modbus.
Yeah.
Then the SCADA. SCADA is very simple. SCADA is similar to
SCADA
HMI.
is very simple.
Yes. Similar to your HMI. Just
Actually,
need
the
to
SCADA is the most. I don't know how it
depend
works
on
inside.
the what SCADA model you're using. Since this is a Siemens, because it's everything there, it's easier to do the
Oh.
tagging. It's the most difficult part is the tagging part.
Okay. The alarming is part of the SCADA.
Yeah, alarming is part of SCADA. Even in the HMI also you can do the alarms.
Yeah. Also can put alarm.
But the same concept.
Okay.
Actually SCADA, the most difficult part, for any brand. The tagging is the different part. I mean the difficult part is the tagging.
You mean pick from which MD or something like that?
Yes.
Why is that difficult?
You know why? Because if we are using the TI portal and TI portal SCADA,
Because if you're
Same
using
project.
different vendor,
if you're using different vendor, you have hundreds of tag. You want to use that.
actually that makes sense. I want to ask also.
They
How you're going to do
export, import the tags or the DB.
this file called what? The file you export. Let's say I use that to do all the programming, PLC programming.
If sometimes we'll have Excel or XML.
XML.
This depend on the SCADA software you're using.
And then I have to use say my last project is Aviva, right? I say
Mm.
Aviva. So the Aviva SCADA have to import
The file because of
File.
what happened, because normally they don't import PLC tag, they will import the global DB.
global DB, which is could be CSV or
No.
XML.
No, it's a .db file.
.db. Wow.
So what happened in Aveva, because you already want to use Siemens PLC.
Mm.
So in the tag table, when you want to import .db, it can detect.
I get what you're saying.
Because you don't need to detect. I know what you mean. It's an Excel, right? Excel is a universal,
Right.
right? But since you are in the SCADA, you already choose. I want to use Siemens PLC. The SCADA itself know Siemens PLC S7-1500. I want to take the data from the DB file. So I use the DB file to import.
And let's say I say this is Aviva, the runtime is in the server, in the SCADA server.
Yes,
It's inside the SCADA server. Networking, if everything networking set up, I just start the runtime, then the alarm will be running already. And then the operator from his operator PC can see
Yes.
everything.
Yes.
I'm just wondering how this, let's say if this is a third party or even this is a WinCC, right? How it can detect. Just now you say already, this is I give a DP and then this is a list of mapping address. I have a 100 variable here, and then he know that this is a definition of 100 variable. Or curious at how it looks like, and how he know that this variable always come from where? Come from this IP address, come from this PLC, or come from
Yes,
other,
yes.
because it could be like one scale, I have a lot of different devices, different PLC.
Yeah, different.
Even something is without the PLC directly.
Direct,
to the,
yes, like
yeah.
a temperature controller or like.
Yeah, it could be a lot of things. How this WinCC going to communicate with all of them?
So that is where the driver is important.
Driver.
Yes. So when you select, okay, you need to add first, okay. First PLC is the S7-1200.
Okay.
You add, okay, 1200. Then under the 1200, what are the tags I want to use?
Okay.
So I need to import and import here. Then I will get all the tags there.
Okay.
Okay, tags or DB or tags that depend. Okay. Then I can design for that. Next, I add another driver. This driver is LM
Okay.
Under the LM is tag.
Okay.
Their tag is different type.
Okay.
Different way of tagging.
So in the
But the data type is still same. Boolean, integer, double integer, real word, double word, these things only.
so in the SCADA you have to install driver for
Yes,
all your
all the
devices.
drivers. That is where the price is.
Where is the prices?
Yes. Different drivers, but normally all the SCADA software come with all the, I can say the most common drivers even the common drivers also are more than hundreds of drivers. Because even Siemens itself, 300 and 400 is considered one driver. So 300 PLC, 400 both using the same driver. 1500 is different driver. 1002 is different driver. 200 is different driver.
So you mean the owner he buy the runtime license, he have to pay for each driver he uses.
Normally all the driver will be there. Normally SCADA software is based on number of tags you are using.
But this number of tags using
Yeah.
driver will be always
Driver is normally all the driver will be there. If we anything new driver, something new coming up, then of course the SCADA software they will add on drivers you need to buy for it.
number of tags essentially is not only the I/O, it's more than the I/O because
Yeah,
the memory also is a tag.
Okay, not I/O actually. Number of tag means what you want to show in the HMI.
Oh, show.
In
Let's say
the
not show.
not necessarily.
Not necessarily.
Yes.
Only how many you show in the
Yes.
HMI.
How many you want to show? That's where when you want to import, you need to select correctly. That's why what I like with the Siemens, because whatever I want to share to the SCADA, I can put into one DB, one data block. Then I just take that particular data block only. Some PLC not like that. Some PLC they will give all the memories.
Or wasting a while.
Yes, power tabs. Yes. So, okay. So what you want to show, but very simple. Okay, but the values, everything, and your alarm list is considered the tagging also.
One alarm considered
One tag.
one tag.
Yes.
This is a tank one level high.
Yes.
Is one tag.
One tag.
Okay.
To get the idea, right?
Yeah, there's the idea. There's the idea.
Yes.
Yeah. Okay, got it.
Mm.
It sounds to me it sounds very complicated.
Yeah, but the thing, you need the software and hardware to understand. Let's say however, because however don't go and give free.
trial version or something.
Don't have. No, because why? Of course, like that question cannot download from the internet. SCADA software very hard to download. Some free SCADA software is there, but difficult to do the settings. need to do this setting. Actually, however, all very straightforward.
What are the famous brand nowadays?
Actually, famous brand is WinCC of Kota Siemens.
Last time I heard
Ellen
one
Bradley
is
one
a
is
twin something, I forgotten.
What's it?
Twin something.
Twin Cat.
I think so. Is it Twin Cat?
Twin Cat is a back off one. I'm not sure they have a SCADA, but they have the visualizations.
Okay. But WinCC definitely is the
It
famous
says
one.
famous one. Factory Talk.
Factory Talk.
Factory Talk View.
Okay.
Ellen Bradley.
Ellen Bradley, the one. Okay.
SITEC.
Also that one.
SITEC is the one that is now Aviva.
Oh, Sitek.
Yes,
Aviva actually, are they from any hardware brand? No.
it's a Schneider one.
Aviva is Schneider?
Yes, it's under Schneider.
Schneider I don't know lah. Schneider got PLC ah.
Schneider got PLC.
Okay.
Schneider actually what happened? Schneider is first PLC is actually Modicon.
The Modbus company.
They are the one who created the Modbus and everything because initial days don't have this one. Okay, Modicon. Then Schneider take over Modicon.
Oh.
Ah.
Schneider.
And Schneider also previously, if not mistaken, it's not Schneider, if not mistaken lah, Telemechanic.
Okay.
Then this one take over, they buy this, and all that. Okay, so that's why the Aviva under Schneider.
Aviva now is under Schneider.
Before that Aviva is they call SITEC. SCADA. Then Wonderware is famous.
Ah yeah, Wonderware, yes. Wonderware is under who?
Wonderware, if not I'm not sure. Wonderware is
Not from Siemens.
no, not from Siemens, not from Schneider or any famous brand. Not sure because they are
Wonderware also time to time heard about it.
yeah, Wonderware. I like the software.
Aviva is Siemens, Aviva is Schneider.
Schneider, then what else? Okay.
WinCC is Siemens.
iFix.
Uh,
iFix or iFlix. One SCADA. Then got few brands. Then Profici.
The most common you see is which one? Changing
Common. Because I very rare I go to SCADA.
Okay, you do the
I
programming.
more to because whenever even I do some for training I will use WinCC lah. WinCC then I will use like for other brands I can use the TELUS. It's like a small time SCADA, like not like bigger one.
Okay,
It's a small
okay.
one. Okay, it's like a more to remote runtime only.
Okay.
Concept is like a SCADA PC based lah, but more to runtime settings. Okay. Then other than that, very rare I use the SCADA software. Other brands lah. Okay, because very hard to get. Siemens is very the TIA portal come together, so it's easier.
More people learn.
Then when I go troubleshoot also, I more troubleshoot on PLC and HMI. SCADA nothing to troubleshoot actually.
To be honest. Of course, yeah, if first time done already, then nothing much
Because
already, right?
SCADA mostly is more to get the data, get the values.
But in the initial commissioning time, SCADA can have a lot
Yes,
of
of course,
problems.
because why the
Yeah.
tagging problems.
Yeah, send the wrong signal, this
Yes.
button not okay.
Yes,
And
sending the
all
wrong signals. That's the main thing lah. Initial
Yeah.
days when you do commissioning.
Yeah, in
Because
the beginning lah, but if everything solved out already,
Yeah, that's why I'm not very involved in the projects.
yeah.
Last time also I have a project, but I never involved in the project. I just moved to the documentation and because it's from China. The project is from China because my boss last time worked in China. So we get the project, but we don't have manpower to do. So we hire a different company to do supply the manpower. So it's something similar to like what you are doing as a commissioning. So the machine is from China. They come here. So first initial days is I send manpower to do the cabling work first. So motors, everything is there. So they
Okay.
need to do the cabling, connect the cables, everything. So we will buy the cable, we will send to them. So they will do that, they will charge for the manpower supply for cabling work, everything. Once the cabling work done, then we hire a commissioning team PLC guys teams, they do the PLC commissioning.
You send me the program and then you
The
install.
program is already sent. From China they send to us, then I send to them. They do that.
Okay.
Then once that one done, then we hire, because that team they are good in PLC programming and everything. Then we have control engineers to do the instrumentation and everything lah.
Oh,
Okay.
okay.
Then after that, once that team finish, then we hire another company to do the. Once done with the, during the commissioning time, we call this company also to come do the commissioning together. Once done, once commissioning done, this commissioning company will go off. These guys will be there, was there for 3 months to test run.
What machine is that?
It's the automated storage and retrieval system.
For warehouse?
Window, yeah, warehouse, window tissue paper. You know window?
Sounds like I heard of, but so this is the warehouse for their product lah. The product how to like
Automated
automate.
warehouse lah. So they use two PLC. One is Siemens, one is Mitsubishi.
Have
So
you
the
go to the
Mitsubishi-
site to see their warehouse?
No.
You can do the programming even without seeing the.
No, I didn't do program.
Oh, you didn't do
That's why I said I
programming.
didn't do anything. I just do more to documentation.
Oh, okay.
But-
Just
but-
manage
so-
a project only
Yes.
lah.
So from China, they will tell me what part to buy. I need to send everything, and I will source everything. I will buy. Then I will send a manpower and will send to them. So they will go and do the fixing everything. They will come back to me. So there's one engineer from China. He go and try on that. Actually, my boss wanted to want to take this project
Okay.
because we don't have manpower. But my China boss said, "Never mind, you take the project, but let others do the job. You just handle the project for me." So I do a lot of the things like
Managing it
parts,
lah.
more to management, documentation and managing it.
Got it.
So they will send me all the
report and
all the
everything.
report, everything. I need to check everything, all the report, then I need to send back to China.
Got it.
So in that case, actually they called me from China. They said I need to go for commissioning. They asked me to go. Then I said no, because if I want to go, can go. They say they can pay. Then they say they can offer me a place to stay everything. Then I see this project is like they asked me to spend 6 months for the project. They also during COVID time some because it's supposed to finish in 1 year plus, but they dragged to 1 and 7 months I think because of COVID, the budget, everything.
Yeah.
Asked me to go, then I said I tell my uncle if I can go, no problem. It's a good opportunity for me, no problem. But if I go, who going to do the training?
Because you still have your.
Yeah, so I'm that time all I already started to do trainings. So who going to do the training? Because I cannot come and go and off and on. Because it's 5 days, they are working until Friday, Saturday. So if I go there, I also need to go there on Saturday. So you cannot do training. So 6 months you cannot do training. So no problem, I can earn the money. The China company can pay this company. But after 6 months, you want to come back and call back do the training. It's very
People
difficult.
already know about
Already
this company,
know-
no more training.
No more training. So that's why I say I can go. It's a good opportunity, good salary, no problem. But if I go, who going to do the training?
Then you lost your business.
Yes.
Continuity here.
Yes, lost the business. That's why I say never mind, uncle. I stay. If they want me to, like 1 or 2 days or 1 week, I want to go and check, guide them, then I can go, no problem. Or if they have engineers, you want to train them, I can do, no problem. Actually, I trained one of the engineer. So when he do commissioning, so he come and learn Siemens.
Interesting.
So I never even been to the company, but I don't know how the company works. Everything, everything from here.
Probably from the back. Okay lah.
Okay, see you.
Okay, see you tomorrow.
Yes.
Thank you. Okay, bye bye. Oh, see you.
Yeah.
That means you still can able to negotiate lah, on the
Yeah.
percentage. That's what I mean lah. Okay, now everything lah. Okay. Now everything lah. Alright, thank you very much.